Hello everyone, my name is Anjali Gupta and I'm presently working with Microsoft in their Windows team. Here on Euron, we are conducting a course on system design where we are going to be learning what system design is. Why do you even have to learn system design? How it is helpful for developers? And if you are actually stuck in some system design rounds, so how you should be answering. So I'm going to be helping you by providing you some guidelines about how to answer in any system design rounds, like how you can be interview ready for a system design round. At the same time, we are also going to be discussing some of the case studies with the help of which you will able to understand any of the system end to end. So this course is going to be super interesting. Let's get started. So before jumping into system design, let's just take some example. Okay, so let's take an example of some house. Like let us say you have bought a land and you want to build a house. Okay, it's not that you will straight away go and construct a house there, correct? But what you will do, you are going to be taking help of some of the architect who is going to come to your house, see the dimensions of your land, and based upon that he is going to be creating a layout for that. Okay, now after that layout is ready, it's not that it is going to be the final one. You are going to give some of your feedbacks. If you're not liking something, you are going to say that, hey, can we have a bedroom here? Hey, can we have a kitchen there? Can we have a lobby there? Like based upon your requirements, you are just going to be having some of your inputs. By taking those inputs, the architect is going to create another layout, and once you are approving it, then he will go ahead and perform the construction for that. Correct? So if you will just take that same example in the field of software development, so something similar to that happens even here. Okay, here what we are going to be doing, a person is going to come up with some of the request that, hey, I want this problem to get addressed. In order to solve that problem, what you will be doing, you are going to provide some solution. Now, before jumping into implementation of that solution, what you will do, you are going to create a layout for that. Then you are going to be proposing that layout to that company. If that company is approving it, then you will go ahead and perform the implementation. But prior to that, there are going to be several rounds of discussions where we are going to be seeing what the needs of the customer are, and are solutions correctly optimized, performing the solution well or not. So that is how it is going to be there. So this system design is extremely interesting and important. Okay, so here as a part of this course, we are going to be learning your low level design as well as the high level design. As a part of your low level design, we are going to be learning certain things like what design principles are, what design patterns are, how you are going to be applying those in your software. And in the part of high level design, we are going to be discussing things like how you can scale your system, how you can optimize your system, how you are going to be applying database. Like as a student, even I'm sharing my own example. As a student, I used to think that, okay, if we have something called as RDBMS, so that is something which we are going to be applying everywhere. But when I grew up, I understood that, okay, even as a even for a project, it's not going to be same for all the scenarios. We are going to be having different set of databases. So what those different databases are there, how you're going to be making those decisions, what cap theorem is there, what is horizontal scaling, what is partitioning, all of those things we are going to be covering as a part of your high level design. Okay, so if you will see, when you are working for any of the company, correct? So what your role is going to be there, you are going to be, let us say, a developer there. So what as a developer you are going to be doing for that company, how you are going to be contributing there. So you are going to see that what any of these companies across us are doing. So we are actually having some real life problems, and what any of these companies are doing, so they are trying to provide you some solution for your real life problems. Now we can actually discuss what are these real life problems and what are we actually saying here? Let's make some sense here. Okay, so let's see, like, I'm talking about some time back. Okay, so let's talk about some 15 years back or 20 years back. At that particular time, it was not easy to do anything through your phone. Like, if you want to get something done, you will have to step outside your home and you will have to get all of those things done. Everything required a lot of patience plus a lot of process. But now, if you will see, if you want anything, everything is available at your fingertips. So let's take the example of cabs. So, like, previously, like, let us say my family wanted to go out for some vacation. It's not that we can just book some cab. We used to go outside, we used to talk to some travel agents who are willing to provide us some cab, provide us some quotation. We used to take quotation from different people, finalize one, and we used to wait for that guy to come to our home to pick us up. And if he is not showing us up, we used to go outside and try out other agents. So that is how it used to be working back then. But if you will see today's scenario, what is happening? If you want to book a cab, you have options of Ola, Uber, correct? All of these applications are helping you in booking a cab. If you want to buy groceries, so previously the only, like, now also we are stepping outside to buy groceries. But if you want, like, if you are not well or if you're just feeling lazy, if you don't want to step outside, then what you have applications available for that. And these days, like, if you will just see, they are literally delivering at your doorsteps in 10 minutes, which is really incredible, right? So you have options of Blinkit, you have Zepto, you have Big Basket, and so on, like many other platforms. Now let us say you are hungry and you just want to eat some food and you don't feel like cooking. So previously you just had the option of going to some restaurant, ordering some food and take home and then eat, correct? Now if you will see, if you want to order food, you have options like Zomato, you have Swiggy, based upon different regions where you guys are staying, correct? Like previously, if you were not well, you don't have the option of getting medicines at your home. But now if you will see, for medicine, you have options like 1mg, you have Practo. Similarly, like, these are the things which where we are just ordering some service at our doorsteps. If you want to make friends, previously it was only possible like if you're going outside, meeting new folks, making friends and all. But now if you will see, everything is possible even from home. You have applications like Facebook, Instagram. If you want to date people, you have applications like Bumble, Tinder, and whatnot. So these are the applications. So what these applications are doing, so these are actually targeting in providing solution for your real life problems. And how they are providing solution, they are actually building a software, and that software is helping us in providing the solution for all of these things, right? Now we are going to be discussing what and all steps are involved while developing any of the project in any of the in any of the organization. So I'm not going to be telling you about how we have done it in any of the books. I'm going to be telling you how we do it in the practical perspective. Okay, so the first step which we have here is going to be the requirement gathering. As the name suggests, we are going to be gathering the requirements. Now, this is going to be the first step in any of the application development. You cannot go ahead without gathering the requirements. So what we are going to be doing here, we are going to be collecting all the information and we are going to be understanding what the problem we are trying to be solving from that project. Now, we understood, okay, we have to gather the requirements, but the question is from where you are going to be gathering it, from where you are going to be getting all that information. So we have two sources for that. So the first one is going to be the customers. Now what you can do, you can go ahead and directly talk to the customers. You can like, let us say you are coming up with some groceries application. Now that is something which everyone is going to be using. So these are going to be the ultimate customers for that, correct? So what you will do, you are going to go ahead and conduct some of the surveys, and with the help of those surveys, you can also conduct some of the polls. You can ask what the potential customer problems are, what issues they are facing, how then you will have to put more energy on solving all of those issues. So what problems they are facing, what features they are actually looking for. So you need to understand what the customer's requirement is there. So you can conduct that after having some of the surveys. Okay. So the second one is going to be the product managers. Now, what is going to be the meaning of this? So if you talk about some of the large companies, so their product managers are going to be there, who are going to be telling you that, okay, these are the requirements. So they are going to go ahead and define the requirements. So they are actually the specialists in the organization, in the market, where they are going to be understanding what the competitors are doing. They are also going to be studying the market needs. They are also going to be coming up what is the best we can deliver as a part of that team. So based upon the research, they come up with the ideas like, okay, this is the new feature or this is the new improvement which we can do, and later on they pass it to the developers. So if you talk about the company like Urban Company, so previously this was known by Urban Claps as well. Okay. So what this Urban Company was doing, so this, like, the main approach of this application is helping you in providing the technician for some home service. So previously, getting all of those things was very difficult. It was a hassle. People used to make multiple calls to the technician and they used to wait for all of them, and at the same time they also used to face some of the uncertainty about if they are going to come up or not. Now that is the issue which previously people had. What this Urban Company did, they came up and recognized their problem. They created a platform where with just single click you have the option of booking the technician, right? And by solving this problem, like, this is a common issue which everybody was facing. By doing this, they automated the process and they made the life easier for everyone. So in this case, if you will see, Urban Company has gathered the requirements by understanding the pain points of the customer, and they addressed all of them with a solution. So this is one of the way to gather the requirements, by talking to your customers directly. So that way you will get to know what these guys are, what issues they are facing, and then you can look into providing the solution for their real life problems. If you talk about startups, where, like, if you will talk about a startup, the team size is going to be smaller, that then the developers themselves will take the initiative to identify the problems and they are going to be suggesting the solution. And why I have taken this thing up, because, like, the startup is where people are already having some idea, and then that idea is going to be discussed among the entire team, and they all come up, like, the similar set of people, and then they all work together so that their ideas can improve the application, or they can also solve some of the customer requirement. Once you have gathered all the requirements, the next step is going to be defining the problem statement. Because initially, like, I can say implement a button. Now, what button you want? I need to define it down. That, okay, I want you to implement a login button. And after clicking on that, I want you to open a login page. So that is what defining the problem statement is. So this is where you are going to understand what the exact problem you want to solve, and whether it is going to be coming from the customer need or some product manager insights or the developer's idea. Like, the source could be different, but the idea overall is, like, the overall goal is to identify what product needs to achieve. So if you talk about the requirement gathering phase, so this is very important because it sets the foundation for everything that comes next. With this, you will get to know, okay, how it's actually going to get implemented, what you are going to expect next. And without a clear understanding of the problem, it is not easy for you or for anyone to build any useful and scalable product. If you are very clear with the requirements, then only it will be easier for you to go ahead and perform the implementation for the same. Yeah. Now, when you talk about any of the application, everyone is going to be having one big question, that is it going to happen over a day? Are we going to build it in a day? So the answer is no for that. Because if you are going to be building any of the application, that cannot happen in a day or two. It takes a lot of time, it takes a lot of planning and a lot of coordination, and based upon all of that only we can expect the delivery of the same. This application building is actually going to be involving a lot of phases. It is going to be having the design phase, it is going to be having the development phase, and once it is developed, you are also going to be performing the testing of the same. And once you have tested, once you are very sure about all of the features, once it is working end to end correctly, the next one is going to be the deployment. So once everything is all up and ready, you are going to go ahead and deploy it so that it will be available for the other users as well. If you talk about any of the big companies like, Facebook, even if like, if you talk about that application, like, a lot of people actually have this question as well that, okay, if you talk about Facebook, so that is already built. So now if it is already built and a lot of people are already using it, now what is the need of having a development team for that application? Like, like as per them, they just think that, okay, if the application is all up and ready and available in the market, we do not need a set of engineers who are still working on that. But if you will see why that team is already there, so that they can work on two things here. This app is actually going to be involving a lot of updates and improvements. At the same time, we are also going to be having some of the enhancements as well, new features as well. So the team is going to be working on improvements. At the same time, they are also going to be working on the enhancements. They are going to be improving the uh, application by providing new features. Correct. So these things are going to be taken care by the development team. So already if the project is there, still we get a lot of, like, we need a lot of team which is going to be maintaining it. Even if you talk about your phone, if, like, if you are having some app store or play store, you can see after certain number of days we keep on getting updates from all of these applications. And what these updates are doing, either they are going to come up with some of the new feature or some of the improvements. Like if something, like, sometimes you must have seen, if you will go ahead, what's new, they will specify, we have added this new feature or we have improved the security patch or something. So if you will go ahead there, you will understand that what the team is actually doing, they are improving it. Even if it is some game, they will try to add either some new feature, new levels, or they will just try to add some new boosters or something in order to make it all interesting. Otherwise it will get monotonous and people will not consume it after a certain time or a certain period of time. But if you will keep on adding some new things there, it will be all exciting even for a customer to use it. So you can say this is the customer retainability which is required for any of the application. So this engineering team that is going to be required so that our application can grow even after the initial launch. And this team is also going to be responsible for maintaining and scaling the application. And this team is going to be ensuring that we are improving the performance and we are also adding some of the new features. So this is what the role of engineers is going to be doing, and their role is never going to get finished. Because if an app, like, if we are discontinuing that application, if we are shutting it down, like you can take the example of Orkut, if something like that is happening, then the team is actually going to get dissolved. But as long as that application is still up and running in the market, we will still need a set of engineers who will ensure about all of these things. Okay, because there is always going to be a room which is going to be there for the improvement, innovation, adaptation to the new customer needs. So we have understood, if we want to get the requirements, how we can get it. We have majorly two sources, the customers and from the product managers. At the same time, like, one more source is there, which is the self driven ideas. So based upon these sources, you can go ahead and get. So this was the first step in the development of any of the application, that how you will go ahead and gather the requirements. Now, once the requirements are gathered, the next step is going to be scoping. So what do you mean by scoping? Okay. So, like, this step is extremely important in the software development cycle, where you are going to be defining the scope of your project. So what you will be doing, so like, your entire application is going to be a bigger one. Now what you will do, instead of implementing, like, if you have any project, This will have lots of features. Let us say feature 1, feature 2, feature 3, and so on. Now, instead of delivering all the features at one, you can go ahead and define a scope for the features. Like you can say in the one go, I am going to be delivering these set of features, and in the second go, I am going to be delivering these set of features. So what you are doing, you are defining the scope. You are going to be telling it, you are announcing, like, even when you work in any of the company, you must have seen we follow a roadmap. With that roadmap, what we do, we try to uh, tell it to the organization and to the outside world as well, that okay, this is how we are planning, we are scoping our work, that okay, by this time frame we are expecting the delivery of this feature, by this time frame we are expecting the testing of this feature. So that is how we are going ahead and defining it down. So basically what we are doing here, we are going to be determining which features will be included in the initial versions and how the development process will unfold over a period of time, like over the period of time what and all features you are going to get it better. Now in order to understand it better, let me take the example of some 5-story building. Now let us say you are at the ground floor and your goal is to reach at the top floor. Now, like, unless you are some Spider-Man or Superman, you cannot just go ahead and jump on the top floor. If you want to go there, what you will have to do, you will have to define it in a way that okay, first I will go to one floor, after that I will have 4 more floors, then I'll go to second floor, then I will have 3 more floors. So what you are basically doing, you are breaking it down floor by floor, and one by one only you are going to reach on the top. So that is how it is going to be there. So if you want to reach on the top floor, you can even take some stairs or some elevator. But if you will see, even if it is stairs, you are going to climb them one by one, or even if it is elevator, it will go one floor by one floor. You are not going to go to the top floor directly. Okay, so that option is not there. So what basically I'm trying to explain you here is that if you want to do something, you will have to do certain things step by step. You cannot reach the end in the single go. In order to reach there, you will have certain set of steps involved. Like let us say you are hungry, let us say you have to cook your own meal, you do not have any other option. So it's not that if you are hungry you can just straight away eat it. The first step is going to be buying it from the market, buying the groceries from the market. The second step is going to be cleaning it down, performing the initial chopping and everything. Then you will have to start the cooking. The cooking also involves a lot of procedure, the time frame. And once everything is done, then only you will have it already in your plate and then you can consume it. So if you want to eat something, like I'm not giving you the option of buying it from outside. I'm just saying if you have to cook it on your own, you will have to follow certain steps. So that way only it will be easier for you to like it will be possible for you to consume. Okay, so in the same way, when you start working on any of the big application or any of the software project, you do not try to build everything all at once. Instead what you do, you start with some of the core features, like if you want to just if you take the example of this story building, so if you want to climb one, you are actually defining your work like okay, in one go I have to reach the first floor. So how you are going here step by step. Similarly, when you talk about any of the application, that is how it is going to be working. So basically what we do, just how we have broken down our work here. Similarly, if you want to perform any of implementation of any of the project, your task is actually going to be breaking it down into smaller manageable pieces. Even if you talk about some of the big products like Microsoft, Facebook, Amazon, LinkedIn, Google, so none of these things was built in a single day. These apps were built over the time with smaller features which were added gradually. So like when you work on any of the application, it is very essential for you to focus upon what features you want at the first. Of course, like if you talk about any of the application, like let us say you are building some shopping application, so you cannot go ahead and perform each and every step in one day. But you what you can do, like you can plan your work, like in one day I will be listing down all the products, in the second day I am going to be implementing the login page, third day I am going to be adding the support for card, Fourth day, I'm going to be adding the support for checkout. Although, like, here I'm taking very less time frame, but all I'm trying to do is to break it down. Like, okay, these are the steps I'm going to be needing. And once it is all ready, then only you can work on the delivery. Like, why I'm putting a lot of focus here on the scoping, because that is one of the most common mistakes which a lot of developers do. Even when I was a student, like, I thought of building one application. But with that, like, since I was just a student, I had zero idea about how to do it. And I was thinking, if I am creating any application, I have to look into all of those things from the day one itself. But no, it doesn't happen that way. If you are building any application, you don't have to make everything ready on the day one. Even if you talk about any of the application, like if you talk about Facebook, the initial UI of that application was different as compared to what you have today. That application has grown over a period of time. They have added a lot of features as well which were not there earlier. So if you will see, that app has grown over the period of time. So when you build any of the application, it's very essential for you to understand you are not going to do everything on day one. It's going to get scattered over a period of time. Now let's take the example of, like, let us say you are going to be building some application like Facebook. Okay, now it can have a lot of complex features. So you cannot build everything at once, but what you can do, you can build smaller features. Okay, now what can be the smaller features? So let us say the first one is going to be sending friend request. And you also want to add friends. So this is going to be one feature, that you should be able to send requests and you should be able to add friends. Okay. Now the second one is going to be, like, the second feature could be something like post on wall. I'm talking about the initial Facebook. Okay. That time we had wall. So if you want to post something on your wall, so that could be one of the feature. Now after this, if you have friends added there, maybe you want to add the support for chatting so that you can go ahead and chat with your friends. So add support for, or add chat support. So what I have done here, I have broken down all my features, that okay, these are the three features which I want to implement first. And once these features are going to get implemented, like, once all of these are implemented, then I can go ahead and implement next set of features. The next set of features could be something like upload image, upload video. You can also add support for liking or commenting. So once initial set of features are delivered, then these are the next set of features I am going to be doing. So if you will see what I am doing, I am breaking down my entire project into smaller features. And with this, what I'm doing, I'm making my entire development process manageable and achievable. So this is what we refer by scoping, where we are defining the work which needs to get done and how I can break it down into smaller and achievable tasks. If you talk about any of the, like, any of the typical company or the software development process, we don't work on the entire project, on the entire product from the start to finish all by yourself. We actually go ahead and take help from the other teams as well. Like, one team is going to be dedicated for the testing. Like, of course we have certain teams where everything is taken care by one person only, but if you will see on a broader picture, there will be, like, even in the team there will be certain expertise in the testing, there are going to be certain expertise in the front end, back end. So what we will be doing, we are going to be dividing it, and you don't have to do everything on your own. You are going to be dividing it in that team so that everyone can take care of some of the responsibilities. So it is very important for you to understand, especially if you are still learning or if you are very new in the industry, that you don't have to do everything on your own. It's going to get broken down in the entire team with the scope, that okay, I want it by the end of this month, or I want it at the end of this quarter. So in the organizations, basically what happens, we break down our entire feature into smaller features. Like, even if it is a bigger feature, then also we break it down into smaller one. And if it is if it is achievable in certain number of days, we just scope it down. Okay, this work 5 days, this work 10 days. So that is how we scope it out. So once we are breaking it down into smaller features, then we plan when you can work on them. So in the industry, generally, all these things, it happens in the quarters. So in the entire year, we will have 4 quarters: quarter one, quarter two, quarter three, quarter four. So basically, in the organizations, our work is divided into 4 quarters. So you will be focusing upon developing special features in all these quarters, and this is also going to be helping the entire team so that they can set their clear goals and they will know what features to be done in the given timeline in the given time frame. And even if you talk about my organization, so we have some core responsibility, we will be actually building some of the roadmap where we will be saying something like, okay, starting off Q1, Q2, Q3, Q4, and then we will say, okay, by this, at least this task is going to get done. By this time, I'm going to be testing it. By this time, I'm going to be deploying it. And this I'm going to be doing even on the feature level, that, okay, this feature is going to get completed by this time, tested by this time, and deployed by this time. So that is how I'm going to be creating a roadmap where I'm going to be scoping my work over spread over the entire year. So if you are going to be defining the scope, it's going to give you a lot of clarity. People are not going to come to you repeatedly and asking that, hey, is this task done or not? If you will have this clear roadmap, people will have the clarity about what they have to do when. Even the teammates are going to know when to do what. So what we do in the part of scoping, we plan which features will be developed in which quarter. Okay, so that is how it is going to be there. Now let's say that you are working on some social media application. Now let us say in the quarter one, you are defining what work you want to get done at the end of each quarter. So let us say in quarter one, you are going to be focusing on some of the core features, like you will go ahead and perform user registration. The second feature could be something like login. So these are the core features, on the first go, you want a user to register themselves. They want to, they should be able to log in. And the last one could be profile creation. Now, in the next quarter, what features we can have it? It can have features like adding friends. You should be able to post on wall. Okay, you should be also able to like posts. So these are the tasks which I'm dividing in the quarter two. Now in the quarter three, we can have the functionality of add chat support. All right. At the same time, we are also going to be providing the option of image and video upload. Now, let us say you talk about quarter four. In this, let us say now you are adding the support of notifications. You're also adding the support of searching some user, like you want to add someone. So you're going to be searching it, right? So that option should also be there. Then you can also go ahead and add some premium features. Now, if you will see, for this, I have separated down my work in different quarters. If you will see, I am not going ahead and implementing everything in day one. Even if you will see the premium features that I have added at the end, because let us say you're coming up with some new application, and on the day one itself, you're going to mark it as paid. How a user is even going to use it, correct? In order to make it even if you talk about some of the applications, they will provide you some of the basic features which are available for free. For the advanced features, they are going to charge you. So with the basic one, people are actually going to be testing out your application if it is really good one, if you are going to get some like good use case out of it or not. So once you are able to see how your application is going to be working in the basic manner, it will be easier for the customers to understand your application and start using it. So basically what we are doing here, we are breaking down our bigger project into smaller ones. And we are also trying to be seeing that when we are breaking it down, we are breaking it down based upon the achievable goals. It should not be something like it's not at all achievable, so that the entire project, it should be there on the track, and we can also ensure that it is going to get delivered on time, plus it can have a visible growth. Okay, now the next one which we have here is, like, we are going to be discussing why scoping is important. So far we have discussed what scoping is. Now we are going to be discussing why is scoping important. So, like, if we talk about scoping, so how it is actually helping you. You are having a bigger project, which is complex. With the help of scoping, what you are doing, you are managing the complexity. Instead of building everything at once, what you are doing, you are focusing upon some set of features at a time. And with that, you are trying to make the project go smooth. Okay. With the help of scoping, what you are doing, you are also setting clear goals, like I discussed about the roadmaps. So with that, what is helpful here, you are actually going to be telling the organization or the team that, okay, this is what work we have. You are setting that goals very clear to them, and how you are achieving it, by breaking it down into smaller tasks, so that everyone in the team knows what needs to get done and when. Along with this, it also helps you in the better time management, because if you talk about any of the big project, like, if you talk about any project on the day one, it will be very difficult for you to understand how much work you need to deliver when. And in that case, it will be very difficult for you to manage your time effectively. But if you are going to be breaking down your work in the quarters, you are actually setting some realistic target for each phase of development. Just now we have seen that, okay, in the different quarters, I want this and that to get done. So it will also be easier for you to manage your time. Like, you are going to be planning it out accordingly. Also, if you will see, by scoping, you're also ensuring the steady progress. Because if you talk about any of the application, if you are not going to see any of the outcome out of it, you're not going to understand what you are doing and where all of those things are actually going. But if you are going to set some smaller and achievable goals, in that case your project can evolve gradually, and by that you're also going to be avoiding any kinds of delays. And if you are setting some of the timeline, you are also going to be ensuring that you're going to be matching all of those deadlines. Now, the next one which we are going to be discussing is going to be your MVP. MVP stands for minimal viable product. Now, what is the meaning of this? So if you will look around today, we have a lot of startups. And if you will see behind all of these startups, majorly the people are the young brains. What do I mean by young brains? Means they are early in their careers and they are very enthusiastic about what they want to do. They really want to have something of their own. They want to start their own company. So they are going to be very excited about their idea, and they also want to pitch into the investors. However, if you are just going to approach to the investors with just an idea, and if you will talk about it vaguely that, hey, I just want to have this idea and I really want to go ahead and perform it, they might not consider that you are serious enough about it. Because anyone can go ahead and talk about the idea, but that is not going to make a strong impression. But what you should be doing, you should be going ahead and coming up with some of the POC. That POC stands for proof of concept. So what we actually do in this POC, we are going to be creating a simple prototype, or you can say a basic version of your application. So if you want to pitch into the investors, what you will have to do, if you have some idea, you should not be going to them directly. Instead, you should be coming up with some POC. That POC should be having some basic features here. Okay, and if that basic feature is going to be having a basic, like you can say some simple prototype about what your idea is all about, how you are envisioning that idea, how you can go ahead and achieve it. So all of those things are going to be coming as a part of this POC. So that POC is actually going to be having some of the core feature which is going to be telling about how your idea is going to be working, and that is actually called as MVP. So if you are having that minimal viable product, once you have all of these things ready, then you should be going ahead and pitching it to the investors. So that is actually going to help the investors in understanding that, okay, you have some great idea on the table and you have the caliber of implementing it, and based upon that they are going to be evaluating you, showing that you are serious enough about your idea and your idea has the potential of growing over the period of time. So this is actually going to be some smaller application only. It's not going to be having everything implemented from end to end. Similarly, if you talk about any of the corporate setting, so as a developer, again, you can have some great idea, some new feature or some tool, but you can just not go ahead and say that, hey, I'm having this idea and I want to implement this or that. In that case, because even if you want to implement anything as a part of a corporate, you cannot go ahead and do it because everything involves a set of approvals. In order to get the approval from the higher authorities like VPs or directors, that is something which is not going to be easy if you are not having an MVP. If you want to convince them with the words alone, it's going to be getting little difficult. But if you are having some smaller application which is having some minimal features which is demonstrating your concept, your idea, so that concept, that small application, that demo is going to be acting as a proof where they can see its value. They might give you more resources to build it out. It's not that, okay, if you are having some idea you have to do it on your own. They might help you out in taking the help. Okay, but all of those things are depending upon how you are presenting it out, how you are building that MVP. So that basic application is very required. The MVP is very much required. So in order to simplify this more, you can think MVP as some tester. So if you are going to some shop, let us say you want to buy a perfume, and a lot of perfumes are very much expensive. So what you can do, you can go to a shop and you can ask for a tester. With that tester, let us say, just example, the perfume is of 10,000. Now the tester you are going to get, sometimes some application like Smitten, they have started selling out the samples. So example, if this tester is costing you somewhere around 100 rupees or 200 rupees, so instead of spending your entire 10K, what you can do, you can buy a tester, you can use that fragrance on you, you can see for how long that is lasting on you, and accordingly you can take a call if you want to go ahead and invest your money in that. So what basically this tester is doing here, this is actually helping you by providing a smaller version of the entire product so that it can help you guys to decide if you really want to buy it or not. So far, if you will see what and all we have, what and all we have covered as a part of our software development here. So first one which we discussed was your requirement gathering. And the second one which we have covered is scoping. I hope by now you must be very clear about all of these things. Okay. Now, once we have created a MVP, now what is going to the next work here? So once you have provided your concept, the next step is going to be building any application. And if you want to build any of the application, that requires understanding what the infrastructure requirement is going to be doing. And all of those things are actually going to be covered as a part of this system design, where you will tell that, okay, if I want to create a chatting application, if one message is taking 1 KB and if 1 million users are using it, then how much space it is going to take overall. So all of those things are going to be covered as a part of infrastructure requirement. Okay. So like, whenever you will have to build any of the application, it is going to be requiring three major components, and what and all those are going to be there. So the first one which we will have here is going to be compute. The second one is going to be the storage. The third one is going to be network. Now, what and all these are, how we are considering them while making any of the applications. So all of those things we are going to be covering one by one. But I hope by now you will have a fair idea about if we are building any of the application, what and all things we are going to be requiring there. Okay. So if you talk about today's world, everything is revolving around data. All the devices, all the applications, if you talk about mobile phones or the laptops, everything is working upon processing and manipulating the data. It's not that these apps are trying to track you where, like, to keep an eye on you, to spy on you, but what they all are actually trying to do, they are trying to help you in improving the personalized user experience. And how they are doing, like, let's take some of the examples so that you can understand it better. Okay, let's take the example of Uber. If you will talk about Uber, like, let us say you want to book an application, book a ride on the Uber. In that case, what will happen, you will expect that driver to reach to your doorstep to pick you and then drop you to the destination, correct? That is what your end goal is from the Uber. Now, if you will see how Uber is able to process your request, so it is using the map data there to locate where you are, at the same time to navigate to your destination. So all of those things are only possible by providing your own data there. If you are not providing your current location, the driver is not able to reach to your destination, correct? The next one which we have here is, let us say, Google. So if you talk about Google, what is happening there? Like, let us say you have went outside. Okay. Now they will like, even if you will open some maps or something, based upon what your user data is there, they are going to be suggesting you places accordingly, right? So based upon your user data and behavior, because they will also be analyzing, okay, if this guy goes here, like, if you will see what map is doing, they are constantly taking care of your location. If you will go and you will see the timeline on the Google Maps, it will actually be able to tell you how you have spent your entire day. It will have the entire timeline about where you have gone, how you have commuted. Like, it will also be providing you a summary in the mails where it will tell, okay, in this quarter you have been to these many places, you have eaten at these many places, you have spent this much time here and that. So all of those things, how it is able to provide you with the help of your user data only. Even if you will see your mobile phones and all, it is very, like, they also provide you how much time you have spent on all of these applications. So they are also tracking your user data, like, if you are opening WhatsApp, how much time you have spent there, and then accordingly they are going to be telling you about how much time you have spent on all of these applications, right? The next we have is Netflix, or you can say YouTube, both. Now, if you will have observed here, what happens, like, let us say you have watched some animated movie or some cooking shows on YouTube. What will happen? The next time you are going to open their application, they are going to be providing you some personalized recommendations based upon your preferences. So if you have watched some animated movie, in next time they will say that based upon your watch history, we are recommending you the movies which you may like. Or if you have watched some YouTube cooking video, the next time you will open YouTube, you will see a lot of cooking videos by the different YouTubers. So what they are doing, they are taking the user data, or you can say the user preference, and based upon that they are able to provide the personalized recommendations. And how it is even helpful, so if you will see, as a user, you, if you are very much interested into watching only cooking videos, so how it is helpful for you, because you do not have to navigate to the different YouTube channels to see some related content. Instead, it will provide you the recommendations on the YouTube homepage, where it will be easier for you to see the different videos. So it is helping your experience overall, right? Similarly, let's take the example of ads. What will happen, like let us say you have opened some Myntra and you have looked for certain trouser there. Later on, what will happen, if you will open any of your website, they are going to be showing you some trouser recommendations from the different websites. So what it is doing, so based upon your browsing data, it is providing you recommendation upon what you might be liking and how it is helpful for you, because you as a user, your major target is to buy a trouser. If it is providing you some personalized recommendation, that is going to make your work easier only, because you do not have to go to different websites to see what collection and what price they are offering. In the form of ads, you're able to see all of that. So if you will see here, overall what we have some interaction with the data. And if you will see in today's world, what is driving today's modern world, so data is something which is driving it out. And that is why if you will see what concepts we have, something like data science, big data, so that is something is coming into the picture. Data is the new oil which has gained a lot of prominence over the period of time. And if you will see what all the businesses are doing, they're understanding what is the importance of the data, what is the power of data, how it is actually going to be helping you out overall. Okay, so the data is something which was already there, but it has evolved over the period of time. Previously data was limited, but now if you will see, the data has evolved exponentially. Now we are going to see that at a higher level, how applications are dealing with data. So applications are dealing with data in two of the forms. The first one is going to be how you are storing your data. Now, why this is even coming into the picture? That is because if you have some data, like example, we have something like Google Drives. We are uploading our pictures there. What is the one thing which we want as a user there? We want our data should be safe. At the same time, we want our data to be accessible. So that is why all of these applications are targeting on these things, that whatever data we are putting there, that should be safe and it should be accessible, that if we want it later, it should be easier for us to go ahead and access it. The second one which we have here is going to be computing it out. What is the meaning of computing data? That is, like, we are like, I'll give you a very small example here before jumping into what it is and how we are going to be using it out. Let us say you are creating some profile on some application. So there you are going to be providing your name. So once you are going to log in on some of the applications, you must have seen on the top, they will mention your name. Hi, ABC, and then you will have your entire browsing page, landing page. So if you have seen from where they have taken this out, so they have computed their data from there, they have taken your name out, they have processed it, they have analyzed it to make the decisions and provide the results. So this is a very small example, but like, in the broader picture also, we will be having a lot of data, like, just let's talk about some banking application. Okay, there what will happen, you want to see your transactions, and based up, like, in this database, it will have all the transactions from the beginning time till now, correct? All of these things are going to be there, but let us say you only want to see some March 2024 data. So what you will do, you're going to be putting that filter here. These things even the applications like Amazon are doing. So if you will go to the order history, they will show you some limited set of orders, but they will give you the option of filtering your orders out. So accordingly, you can also see your cancelled orders, your regular orders, the time frame, the year where you want to locate your product, so that you don't have to scroll down each and everything. You will only have some limited set of piece of information in front of you. So that is what we actually refer by computing the data. So whenever we are building any of the application, these are the two operations which determine what infrastructure you are going to be needing. Now we are going to be breaking down the infrastructure here. So the first one which we see here is going to be compute. Now we are going to be needing some computational power to process the data. That is going to be involving, like, just now I gave you the example that if you want some of the data only of the March month, or something only from the year 2023 or something like that. So in order to perform all that computation, what you are going to be needing, you're going to be having the access of some running algorithms, which is going to be helping you out by managing the user request, and on the top of that they are going to be performing some of the calculations. So this power is going to be coming from the servers or the computers, which is going to be performing this thinking part of your application. Now the next one which we have here is going to be storage. So after computing, the next thing which we require is going to be storage. So if you talk about the applications, all of the applications are requiring storage to save the data. So whether it is some user data, some application configurations, or some large data sets, everything needs to be stored somewhere. Like we should be having certain of the placeholders, and this storage, like, this is often hosted on some servers or some cloud platforms. Like I'll give you example of Google Drive, Google Photos. So if you will see, there is some uh, that is a cloud platform only, because if you want to put some of the photos, because by default it will provide you a storage of 15 GB, right? So if you will see this 15 GB, they are not taking it out of your phone, but they are providing it on the cloud, and from there it is easier for you to access it out. Okay. Now the next one is network. The example which I have just taken will make more sense now. Now, if you want to access these Google Photos, since they are not lying in your phone, but if you want to see your Google Photos, how you will be able to do it? Only with the help of internet, correct? Because they are stored on the cloud. Like I clearly mentioned, these are those photos which are not there on your phone. So if you want to access them, what you will be needing? Internet. So in the age of internet, no work works in the isolation. We, like we said, we are going to be having different set of servers, we are going to be using a lot of devices for that. If I want everything to communicate with each other, for that we are going to be needing network. So this network is going to be connecting everything, and it is also going to be helping you out in maintaining the data transfer. Like this Google Photo, you will see some option of syncing. So what syncing means, it will take pictures from your phone and it will put it on the cloud. So that is what it does. And sometimes we, if that photo is not there on our phone, we have the option of downloading it down. So how all of these things are happening? So all of these things are happening, like we are maintaining this data transfer between the users, servers, and the databases. And if you will see, without a network, if you talk about any of the application, be it like your Uber, Netflix, that is not going to work. And if you want to make all of these things working, we need to have a internet connection. We need to have a network connection. Okay. Just now I have mentioned that in the infrastructure, what and all things we will be requiring? Some compute, storage, and the network. Now we will see why these three are interconnected. All right. So if you will see here, whenever you are building any of the applications, so these are the components which are going to work together. So if you talk about the computation, so how that app is going to work in the computation field? So it is going to be processing the data on servers, right? Correct. Now we are going to be needing some of the storage as well, because if you talk about this process data, like, I gave you some data and I asked you that, okay, example that bank only. If I'm asking you only the March transactions, after extracting it down, I need to have some of the storage, which is going to have, like, if you wanted to present it on your screen, it should be taking some of the memory in the backend, correct? So we will be needing storage for the processed data as well as for the raw information. Correct? So in order to save all of these things, we are going to be needing some storage. Now we need some network. Just now I said, one second. Just now I said in the computation, we are going to be processing data on our servers. So if you want anyone to interact even with those servers, we are going to be needing some of the networks, right? So with the help of network, what we will be doing, if we are having some of the devices, it is going to be providing a communication, or if it will be having some of the servers. So if you want to interact with them, if you want them to access your application, and if you want to share some of the information, so all of those things are going to be happening over the network only. Now we will see whenever we are going to be planning any of the application, how we will go ahead. Yeah, so like, if you are planning for any of the application in that, like, whenever you plan any of the application, at that time, you need to perform some of the estimates. You need to come up with something like how much compute you are going to be requiring, how much processing power your application is requiring, because not every application is going to be requiring the same level of processing power. In some of the applications, we may be performing a lot of computations. On the other side, some of the applications are not going to use a lot. Like if you talk about some applications like Amazon, there you need to perform computations at the cart level. You also needed to take out the order history. You also need to perform it when you want to sort your orders, where you want to sort your products on the landing page. So all of those things are actually going to be coming as a part of your compute requirements only. The next one which we have is the storage requirements. Like I just took the example of Amazon. So on that we have variety of products listed on their website. So you should be knowing how much data your application is needing in order to store and access them. The next one is the network. This network also plays a vital role between the different applications. So you should be knowing how much data transfer we need to be using in order to connect to the users and the servers. Example, if you talk about some applications like Netflix, YouTube, since they want to buffer the videos on your devices with the given video quality settings, they are going to be consuming more data. On the other side, if you are using some chatting application where you just want to send a message, text message, that is going to consume lesser. If you want to send some image or video, that is going to take more data. At the same time, if you talk about messaging application, if you are sending hi to someone at, let us say, 11 a.m., you want it to get delivered at the same time to the person you are sending it, right? That means you want a constant network between your server. Otherwise, if let us say you are sending some happy birthday at 12 a.m. and if it is delivering the next day, will it make sense? No, right? So that is how, based upon the different applications, you are going to be deciding how much network capabilities you are going to be needing. So if you talk about all of these things, this computation, storage, and network, so these are actually like the foundation for any of the application, and they are going to be helping you guys in processing the data, the storing the data, to share the data over the internet effectively. So all of these things are very much required to plan before starting working on any of the application. So that's all. We have completed the first module of our system design. Now we are going to be discussing new more things in the next one. So I'll see you there. Till then, happy learning. Bye bye. Hello everyone. So in our today's module, we are going to be learning low level design. So first of all, I'm going to be telling you as a part of low level, what in all things we are going to be covering. And in this particular module, we are only going to be covering one part of it. The remaining one we are going to be covering as a part of our next module. So when you talk about low level design, here we are going to be covering two major things. So the first one is design principles, and the other one is your design patterns. So when you talk about low level design, like here there is nothing something which we are going to be learning something new. So these are the things which are already existing there, and we are just going to be telling how to implement them in order to achieve the different design principles as well as the different design patterns. So this is nothing new concept. All of these things are something which you have already learned as a part of your object oriented programming. All right. So in today's module, we are only going to be covering your design principles. So let's get started. So when you talk about system design, so in that particular one, we always ensure that, whatever application we are building, that application is future proof. What do you mean by future proof? So like I gave you the example of Facebook in our previous module, and what I told you on the top of that, I said that if today it is coming up with one feature, tomorrow I'm going to be integrating something new, correct? So similarly, what we mean by future proof. So if you are building one feature today and if you are building second one tomorrow, when you are going to be doing that, you need to ensure that feature 1 is also working perfectly. Also, by future proof we mean if we are building any software today, that should also be usable 6 months or even years down the line. It doesn't matter, it doesn't happen that if you are building something today, it will only be usable in our today's date. If we build something, we always see that, okay, like example, if when Amazon got started, nobody started it with the intention that we will only use it for 2 months or 3 months. They built it with the vision that in future we are going to grow massively, and that's what you can see. Like, I don't even remember when it got introduced, and we guys are using it every now and then. Like whatever we want, we Amazon is such a platform which we trust the most. So if you will see, whenever these guys built Amazon, they ensured that it is future proof. All right. Also, like when I gave you the example of adding new features tomorrow, what does that mean? It means whenever we are building any application, we always build it in such a way that it is flexible enough that tomorrow, if I want to add any new feature, if I want to add any new enhancement, our application should be flexible enough to adapt the changing requirements without breaking the existing logic. Because if the existing one is not working, then the new feature is of no use, correct? So whenever we have to integrate anything new on the top of something existing, we always have to ensure that the existing one is perfectly working fine, the existing system is still untouched. So when you talk about any like system, so whenever we talk about any of the system, we always design it in order to address some real world problems. And in order to achieve this, like if you talk about anything in the real world, we have two things, right? So we are actually going to be talking about, like if we are talking about some real world problems, so what we are actually dealing with there, so we have entities and we have relationships. What do I mean by that? Example, if I talk about a car and if I talk about a person who is ABC. All right. Now, this is a individual entity and this is an individual entity, but there is no relationship between them. Correct? But if I say this is my car, when I am saying my, what I am actually doing there, I am building a relationship there. So if we say this car belongs to me, we are adding some relationship there. And this is something which we have, like that is something which we have already learned as a part of our object oriented programming, that we are going to be having some entities, we are going to be having some relationship, and with the help of object oriented programming, what we try to build a relationship between all the entities. And like this is what is actually going to be useful whenever you are going to be designing any of the application. So if you are having any problem statement, so that problem statement is actually going to be having some entities, and you are trying to be like firstly, your first approach is always going to be, if you have any problem, you are able to represent different entities there, and the next one is going to be how you are building relationship. So that is what you are going to be doing, right? And just now I said, in order to address both of these challenges, what we are doing, we are actually using some object oriented programming here. Correct? So that is what is actually going to be useful in this scenario. Okay. Now, when we were doing this, how we were actually implementing it. So in this object oriented programming, we were making use of something called as classes and objects. So whatever our problem statement was there, we were trying to represent it in the form of some classes, and we were also using certain objects in order to access these classes, and these are the things which are the building blocks of our object oriented paradigm. Correct? Now, like, I'm actually telling you very briefly about all of these things because these things are going to be there as a part of your design principles and patterns. So, like, very quick brush up. Okay. Now, when you talk about classes, so what a classes is, like, whenever you have to create a class, what you try to do, you try to create some template, or you try, like, either you call it as a template or some blueprint, where you will actually be telling that, okay, if I want to create a, like, example, if you are trying to create some person class, so in this person class, what you will be doing, you are going to be creating some of the like, if you have to talk about person, so how you are going to be representing him, you are going to be providing some attributes like name, age, gender. If you are talking about some car, so there what you will be doing, you are going to be discussing something like model number, color. Exactly. Now these are the attributes which we are going to be using for that class. What are going to be the, like, having these attributes are nice, but what these attributes are going to be doing, how it is actually going to be working. So for that we are going to be having some function, like for the person I can have some functions like eat, like a person is eating. It can have something like sleep, a person is sleeping. Like, these are the functions of this person class. For the class, what can we have? We can have some functions like start, which is going to be telling, okay, when it is starting. It can have something like stop, when it is going to be stopping. So if you will see, for these classes, we are also, like, we are telling, with this attributes, we are telling what kind of entity is there. And with this class, we are also telling that, okay, this is the blueprint which is defining what attributes are going to be there and how these attributes are going to be behaving, and how we are telling it with the help of these methods. All right. So that is how you are going to be representing it out. Now, if you will actually be seeing like how you can put it into a class, we are just going to be defining how we define any class. We define something like class. Here we provide class name. Inside this, we are going to be defining our attributes. And after defining attributes, we are going to be also be defining some of the behavior of these attributes. So that is how basically a class is going to get represented. Now after this, let's just quickly see what and all the core concepts of our object oriented programming. Like, I'll just give you some quick overview only. In the detail, like, you can just learn it separately. Okay. So when you talk about object oriented programming, so we are broadly having 4 core concepts. So the first one is encapsulation. So in this encapsulation, what we try to do, we just try to wrap everything in one class. The next one which we have is abstraction. So what is abstraction? You just hide unnecessary stuff and you just try to make the, like, the core things visible. Like, if you try to withdraw money from the ATM, you don't see where the money is getting stored, you don't see how it is coming forward to you. All you just see, you are entering your pin and you are getting the cash outside. Similarly, when you talk about any website, even if you talk about Amazon, Facebook, anything, let us say you are trying to upload a picture on Facebook, you don't see what reasoning, what logic, what algorithm is written behind that, right? What you see, you are just getting the functionality of upload. It is browsing the picture. The moment you're clicking on upload, it is getting posted. The next one which we have here is going to be polymorphism. So when you talk about polymorphism, what does it mean? It means you are going to be getting many forms of the same thing. Now, this polymorphism is further of two types. The first one is your compile time polymorphism. The second one is your runtime polymorphism. In the compile time, we learn broadly about two things. That is your function overloading. The other one is operator overloading. Now, what is function overloading? So in the function overloading, we have same function name but different return type or different set of parameters. And why do we do it that way? Like, I'll give you one quick example about one of my code, like which I have worked in one of my organization. So there we were running some different types of functions, like we were referring to them by calibration. So for our major project, we had different calibrations. Every calibration had a run method, but all the different calibrations were having some different types of parameters. So in order to maintain a readability throughout your project, what we try to do, we try to have same functions for the same type. Like if every calibration needs to run, we were only having run function, but the parameters were different and based upon them, they were getting invoked. The second one is operator overloading. Now, what does it mean? Like if you talk about plus operator, that plus operator is also used for addition as well as concatenation of two strings. Now, when we talk about runtime polymorphism, what we cover as a part of this, we cover something called as function overriding. Now, what does that mean? The function name is going to get same, but it is going to have a different implementation. And why it is required? Because sometimes you just need, like, if you are talking about some area, probably that area is getting some different requirement. Like, you might be computing it something like just taking the dimensions, performing some operation on the top of that, but sometimes we need to have a different implementation. So instead of giving some different name there, we can maintain some same name, but inside that we can have some different set of implementation. Now, the last one which we have is inheritance. So when you talk about inheritance, that is something where what we do, we maintain a parent-child relationship. So if parent is having something, it will give it directly to its child. But there also we maintain what things to give it to a child and how we perform it with the help of the access specifier. So that access specifier is something which is very used, which comes into the picture when we perform any of these operations, because if it will have access, then only we can go ahead and access them, correct? Now inside inheritance, we have single level of inheritance, we have multi-level of inheritance, we have hierarchical inheritance. Then we have something called as multiple inheritance as well, but that concept is not there in all of our programming languages. It is there as a part of C++. If we talk about Java or if we talk about C Sharp, there we do not have it. But if you still want to achieve that functionality, you have a functionality of interface. So what interface does, it provides you to achieve multiple inheritance. Okay. Now we are going to be discussing your design principles. So basically what I have done so far, I have given you a quick brush up about what and all concepts you are going to be needing as a part of your low level designing. So when you talk about design principles, so first of all, I need to tell you what is the actually meaning of that. Okay. So I'll just give you a very easy scenario to visualize it. So like, have you ever struggled to add a feature to your application because code was too rigid? As in, like, I have faced that. So I wanted to add some feature where I wanted to take some of the parameters, but I was not able to do that because of the rigidness of the code. Or sometimes, like, if you are finding yourself that you are rewriting the code so that it is going to become more testable, or if you are adding more logic so that you can optimize it for different platforms. So these are the these are the situations, these are the challenges which are not following the proper design principles, because we write some design principles in order to ensure that we are not running into all of these situations. So in this class we are going to be covering the essential design principles that every software engineer or the programmer should understand. So these are just the guidelines, and these are only going to be telling you how you can design your systems that are easier to extend, easier to test, easier to maintain. Okay. Now we are going to be learning firstly what design principles are. Whenever you have to learn anything, you should be actually be able to know three things. First is, what is that, why we are learning that, and how it is going to be useful. So this is something you should be knowing before learning any of the concept. And this is not just specific to learning in any of the classroom, but this is also specific to learning or performing any task in any of the company as well. If somebody is giving you any task, you should not be straight away jumping into the implementation for that. Instead, you should be asking certain of the questions, or certain of the questions should be clear to you. First one is what we are doing, why we are doing, how this is going to get consumed, how this is going to get helpful for us. Once you have clarity on all of these questions, it will be easier for you to perform the implementation for the same. So here we are learning firstly what are design principles. So this is something this is a strategy. This is not a concept, but this is a strategy. And this strategy is going to be what strategy we are going to be coming up with the design principles. So this is going to be telling you like how you can go ahead and implement the individual components, how you can write some clean and maintainable code, how you can develop the architecture of a system. So all of these strategies are going to get covered as a part of your design principles. So when you talk about design principles, so a lot of people say these are the strict rules, but these are not strict rules. But by following these rules, these principles, you can save yourself from the headache which you will be getting in the future. Why? This is actually be helping you by making your systems flexible, scalable, easier to work with. Okay. So these design principles are going to be helping you for all of those things. Now let's discuss why do we actually teach design principles. Okay. So I'll be taking some example from the old Vedic era. So in that times, children's actually, if you remember, if you have watched some Ramayana, Mahabharata or something similar to that, you must have seen that in those eras, children's were following a unique way of learning. Modern education was not existing back then, right? So from the age of roughly around 5 to 15, they will be back then they were leaving their homes and they were going to some forests and all in the wilderness, and they were actually be under the guidance of some wise saints or gurujis and all. And that was something which was common across all the religions and the cultures. So during this time, they were actually be getting taught about how you can live a meaningful life, how you can interact with your parents, with your siblings, with the society, and how you should be able to understand and respect the environment. Over those years, they were actually be learning some of the vital skills, some of the manners, etiquettes, and the values, and these processes used to shape them into a transformed individuals, which used to prepare them fully to lead a purposeful and meaningful life when they are returning back from the forest. Now, this traditional model of learning was not just about gaining the knowledge, but it was also be about developing how you can develop that character in you, how you can be equipped with handling somebody's life responsibilities with some wisdom and grace. So what I'm actually trying to explain here is that system design course is also serving the similar purpose. So when you are already working in the software world, or if you're about to start, So you know that this course is actually going to be giving you all the tools and the knowledge where you want to excel. So that when you are going to be done with learning the system design, you will be able to put all of those learnings in the new projects which you are going to be doing or the existing ones. Like I'll tell you one thing, when I started my own career at that time, I was not well versed with system design. I started my career with the basic knowledge of OOPS and programming languages. After that, like after a few years, I decided to make my career transition. And that is where I was learning system design. Trust me, at that time, every code, every piece of line written in my project was making sense to me that, yeah, if we are using this thing here, how it is going to be helpful for us, why we are writing it in that way. Previously, I just used to think that, okay, if my teammates are telling me to create an abstract class, let's do it. But after learning design principles and design patterns, it was very much clear to me that why we were doing all of those things. So, like, trust me, even when you will be done with all this course, everything is going to make sense to you. Initially, it's little difficult for us to understand and get an hold of what we are doing. But eventually, you are going to be able to connect all the dots. Okay. Now, what is the goal of system design principle? So this one is going to be teaching you the foundation which you require to build a scalable, efficient, and a user-friendly system. This is also going to be helping you in creating a system which are easy to understand, customize, adaptable, and this also ensures that whatever the software you are designing, that is providing a better user experience, where it is also able to extend in the future, where it is future proof. So just like those ancient learnings, how they were shaping the individuals for life, so these design principles are aiming to prepare you for creating your systems which are efficient, which are going to stand with the coming time, and this is also going to be serving their users in the effective manner. So when you develop or when you start building any of the application, you aim to create some clean and well organized design, and you use that knowledge for your application. And when your application is growing at that particular time, you are going to see some of the challenges as well. So what those challenges are going to be there? So the first one, some of the challenges which we are going to be facing over the period of time, you will see that some bugs are appearing over time. Now, what is actually this? Like how bugs can actually come appear over a period of time. So, no matter how well the software is designed initially, bugs may surface as the application evolves or interacts with the different components or the external system. Because initially you were providing basic functionality. It was not interacting much with the different components, with the different layers. But eventually, when you are going to be introducing more layers, more components, there could be a scenario where it is not going to work correctly. So at that particular period of time, you are going to be getting certain bugs, and no application is bug free. Even if you see today, like I said, you will get some software updates and all. So there will be something like at-rest bugs, because bugs will come from here and there. Like nothing can be bug free. Now, frequent changes are inevitable. What do we mean by that? What do we mean by that? Every new feature request or the change request is going to be requiring some modification in the original design. And when you are adding something or if you are modifying something, so that can make your system go complex. At the same time, it is also going to be making things difficult for you to manage over the period of time, because now, like initially if you had some 10 lines of code, now you will have 10,000 lines of code. So that is going to be making your system complex. The next one which we have here is increased efforts for simple tasks. So initially it can happen that initially it was easier for you to perform simple tasks. But if you will see over the period of time, it will get little difficult for you to even perform simple tasks because that will require significant efforts. Developers, like, they need to understand, like, if you will observe whenever you join any organization, you should be knowing two things. The first one is your technical knowledge, second one is domain knowledge. Now, technical means you know how to write code, but domain means you have the deep understanding of the entire system, so that later on, if you want to perform any of the changes, it will be easier for you to. So you will see that if you want to make any of the changes in your system, you should be well versed with what system is, how it is behaving. That means you should be having the domain knowledge, and once you have it, it will be very easier for you to perform even the simple task. But if you do not understand the domain, then it will be difficult for you to implement. Okay, now let's discuss the different types of software design principles. I am only going to be covering few which I have observed in the interviews. And we have multiple design principles, but it only, if you will actually observe, that is not something which is new. It's something which you are already doing, but you might not be aware with the terminology. Okay, so the first one which we have here is dry. So dry stands for do not repeat yourself. What does that mean? It means if you have already written some piece of code somewhere, example, you want to print, you want to have some print method, like some set of lines you have where you are printing the actual value, modified value, certain set of lines which you are printing multiple times. So what it says, do not repeat yourself. If you have already written it somewhere, try to reuse it as much as you can. So that is what we try to achieve by writing methods. So what we will do, instead of having those print statements repeatedly, we will put it into some method, and later on we are going to be calling it out as many number of times as we want. Okay, the next design principle which we have is Yagini. So the Yagini stands for you ain't gonna need it. What it means? It means that if you are implementing something, you should be knowing that if you are writing something, you are actually going to be needing them. And you, if it is not helpful anywhere, you are not going to have it. So you need to understand, if you need something, then only you write the code for that. Do not do and keep things ready before that. As in, if I want to have some compute function where I'm just performing some of the calculations, I know I will be needing it in future. So what if I think that, okay, today I have some time, let me go ahead and write it out. That is not how it is going to be helpful, because tomorrow in future, maybe we will be changing the requirements as well. Maybe we will be introducing some parameters. So what will happen in future when I will be needing it? At that time, I may have to do the rework. And that is something which is of no use. Plus, there could be a scenario where if I feel today I need that method, tomorrow I may not be needing it. So what it says, you should be writing a clean code. If you don't going to need it, just don't write it. If you need, then only you write, like basically based upon the requirements, but don't just try to keep things ready and lying in your plate. Okay, the next one which we are going to be discussing quite a lot in detail, that is your solid. And solid is something which even people ask in the interviews as well, be it about your tier 1 company, tier 2 company, or tier 3 companies. Every company is actually targeting into asking the questions on solid principle. So here every letter in the solid actually states for something, and we are going to be covering all of that one by one. So let's see. Like firstly, I'm going to be telling you what this solid is, and later on we are going to be covering all of these one by one. So here S stands for SRP, means single responsibility principle. The next one is O, where O stands for open close principle. L stands for Liskov substitution principle. I stands for interface segregation principle. And your D. D stands for dependency inversion principle. Now, in the interviews, sometimes people will be just asking you, like, I'm telling you from the interviews in these tier 2 and tier 3 companies. So what they will do, they will straight away going to ask you, okay, tell me what is solid principle. Once you will tell, okay, solid stands for all of these, then they will be asking you, okay, tell me what is O here, what is L here. That is how these are going to be asking. But if you talk about tier 1 companies, so they are going to be giving you a situation where they will say, okay, now you just apply this guideline here. So that is how the interviews are going to be different, but the core concepts are going to remain same. Now we are going to be starting with our S here. Single responsibility principle. Like the name is actually suggesting, but it is saying single responsibility. Do not handle more than one responsibility. One class should only be doing one thing. And what is the major intention here? The major intention is to avoid confusion. That is why we are saying one class should be doing one thing. Let's take the example of hospitals. Okay. Yeah. So let's take the example of hospitals. Okay. So that it will be more easier for you to understand what is the meaning of the single responsibility. Okay. So now you must be knowing when you go to any hospital, you are going to be having different physicians there, right? Now, these physicians are again going to be of different types. The first one is the general physician. And the second one is going to be the specialists. All right. Now, these general physicians, they have, they are generally who have done the MBBS, correct? And if you talk about specialists, so these are the ones who have done the master's MD into some of the things. Now if you talk about any doctor, correct, so if it is a he is a doctor, they can actually be doing a lot of things. If you talk about general physician, so like let us say you have fever, if you have some issue related to the eyes, if you have issue related to the heart, if you have issues related to ears, firstly your first go to step is go to a general physician. So basically they are going to be taking care of the simple illness. Once, let us say in certain of the cases, what happens when we go and tell them, okay, we are having this, they will give us some basic medicines. Then we'll tell, okay, now we are having this issue, it's not even going. They will ask us to get some of the tests done. After tests done, they will figure out, okay, this is something which is related to one of the serious illness. Then they will say, now you go to some specialist. I'm not sure if you guys have faced it or not, but I have done, faced it a lot of times where after a certain course of treatment, I have to go to consult some specialists. I have to even go to the hospitals and all. Okay. So for a simple illness, a general physician will be able to help you out. But for a serious illness, you will be needing a specialized help. Okay. Same way when you are building any of the application, means your software, here we are calling our software as the specialized stuff. So with all of the experience which you have over the period of time, the experience you are with which you are building your object oriented programming, you will realize that when you go and create a system having 100 different functionalities, that is not a good design, because that might lead to several serious problems. You will be tied up with so many issues. So it is better if you go and have a clear distinction of what your class is doing. So if you go and follow that, then that is called as your single responsibility principle. So what SRP says, one principle should, one class, one functionality. Okay, one class should be doing only one thing. Now we are going to be taking one of the examples so that you can understand it better. So some people are like, let's take some example of boating. Okay, so few people are fond of boating. So what they do, they buy the boat, and the same person might be interested in driving the car, so they buy car as well. Normally if you talk about India, okay, so we do not have this culture, but this is something which you will find typically in US. So they will all buy boat, not, okay, they will also, like, not exactly a bigger boat, but a small kind of boat, and they will carry that small boats on the top of their cars, and they are going to be taking it to some nearby place like the lake. They are going to have some family time there, and that is what they are going to be doing. Now if you will see what they are doing here, they are trying to do two different things here. Why don't we, like, they are actually going to see that, okay, we are having two different things here. Like if I want to drive a car, I am going to be having a car, and if I want to have a boat, I am having a boat, and I am actually putting both of them together, and I'm taking it out in order to have a family time there. But what if somebody is thinking that instead of having two different vehicles, why don't I have one single vehicle which can go even on the water as well as on the roads? But is it even possible? It maybe, it is going to be possible, but if you will see, that is going to get tightly coupled. What I mean by tightly coupled, it means probably something like this is going to be available across the globe, but they are not very popular. And the reason why it is not popular, because they are going to be serving the multiple functionalities involved here, the functionality of car as well as the functionality of boat. So if there is any issue which happens because of the car, you will not be able to use the functionality of both, because they both are tightly coupled. We have tight coupling here because they both are coupled together. So when you keep multiple components in one system, and if one part is not working, then the other component will also start getting infected. So normally in such case, what you do, you try to keep multiple components at multiple places. So even if one component is not working, you will not be able to use the entire system. But let us say the same example, car and the boat. If they both were two different entities, if car is not working, you will still be able to use the boat. If boat is not working, you will still be able to use the car. So that is what we go ahead and say here. Like, even if you have to talk about this in the world of, like, uh, your software development, you will see that we have a mouse. Like, you will be knowing if we have a mouse and if we have a keyboard. So these days everything is USB controlled. So I'll give you one personal experience only here. Okay, so I had the option of buying a mouse separately, keyboard separately, but that will be actually be getting used by two USBs. I thought, why to block two USB ports? Why can't I just make it work by the single USB port? So there are certain options available where with one USB I can be able to use both of these things together. All right, and these are the things which are available in India only. So what happened? I opted for that one. Sometimes we just act smart. I acted. And later on, what happened? That USB got misplaced. As a result, what happened? Neither I was able to use the mouse nor the keyboard. But imagine, what if I have bought both of the things separately? I would still be able to use at least one of the device, right? Because I have lost that USB now, it is of no use for me. Correct? So that is something where I like, even in this case, when I'm having only one USB for both, you can see it is tightly coupled because that one USB was actually helping in both of the scenarios. So if I have lost that, since both were tightly coupled, now none of them are working. But if I would have had it separately, then it would be lightly coupled. Then even if one goes wrong, the other one still be able to be in the working state. Okay. Now we are going to be quickly seeing one of the code where you will actually be seeing how it is working. I have already pasted here a functional code and I'm not writing it here so that we can save our time. Otherwise this module will go quite longer. Okay. So here what I have done, I have created an employee class. So here if you will see, we have employee class where I have taken some of the attributes like ID, name, date of joining. Now I have a constructor where I am initializing all these values. Now what I am doing, I'm having some of the behavior of this employee class, which is like calculate salary. So this one, like I have not written any logic here. I have created these dummy methods here. So this one is going to be containing the logic for calculating the salary. Now we have another behavior which is hire employees. So this one is going to be writing the logic for hiring the employees. The next one is evaluate employees. So here we are going to be writing logic by the evaluating team. Now we have get ID, set ID, and these ones are going to be needing, like if you are having some of the ID, so you will be retrieving it out. You should be able to set it down. Then similarly for the name, I have get name, set name. Then for the date of joining also we have get and set. Now this is our main method. So what we are doing as a part of this method, if you will see, so we have employee. Now for employee, what I have done, I have created an employee and for that I have given employee ID, I have given an employee name, and I am just using new date. I'm not providing any date, like it is just going to be fetching the current date. Okay. Now after that, if I want to print it down, I'm going to be using get ID, and if I want to get the name, I'm going to be using get name, and similarly get the date of joining. All right. And if I want to hire employee, I'm going to be using this hire employee method, calculate salary, evaluate employee. Now, one question which I have here from all of you, like, although it may seem it is following the single responsibility principle, but is this class following single responsibility principle? Just pause the video, take your time to analyze and understand if it is doing it that way or not. So like, if you will see here, we are having too many methods, and that does not indicate that this is a single responsibility. All right. By single responsibility, it means it should be changed or impacted by only one actor. Here, if you will see, we are letting hiring as well here. We are letting calculating as well here. We are also having option of evaluating employee as well. But we are not doing all of those things. Everything is taken care separately by separate entities. But here if you will see, we have put everything under one class. So what do you mean by single responsibility? It means it should be changed and it should be modified only for one reason, irrespective of how many methods do we have in that class. So in this class, if I will see the calculate salary, the logic for this function is actually calculating the salary, which is going to be done by the finance team. Finance team will be interested into calculating the salary of the employee. Now hiring employee, the functionality which is getting triggered by somebody, we call it as HR. So this is another division in the class. The next functionality which we have here is evaluate employee. This entity is going to be triggered by another actor. You can call it as manager. We have a single class employee. but the change in this class is being done by multiple people, multiple entities, and since all of them live in a single class, the change made by one of them may be impacting the another, and that is why this is violating our single responsibility principle. So if you understand the single responsibility principle, then it says that class should be changed by only one actor. Here if you will see, finance people are also be able to change, HR people are also able to change, managers are also able to change. It means that this class is very fat. Fat is not good for health, fat is not good for class either. Here everybody is looking into their functions, and all functionalities are different from each other, and they are interrelated. Like let's say finance team perform change in tax lab. What does that mean? Change in tax lab is going to be impacting calculate salary method. The change in one class is going to be responsible for deploying the entire code. The whole code is going to get redeployed. So even though if you will see here, we are not making any changes at the HR, there is no impact in the employee performance, but still this whole class is deployed. So during that time, the finance method is getting, it is making changes at that time. HR team is not able to do anything. Manager team is not able to do anything. So they are getting impacted. So what do we actually want? We want if it is working differently in the different scenarios. So for that, like, if manager is making change, the other two teams should not be able to have any dependency. It should be lightly coupled, not tightly coupled. Okay. Now I will be showing you how we can modify this code and how we can make it work according to single responsibility principle. Now, if you will see, I have made changes in my class and I have kept that updated code here. All right. So if you will see here, we still have that employee class where it is having all those attributes. And if you will see, I am not having all those behaviors inside that employee class. Rather, what I have done, I have created a separate class that is salary calculator. So this is something which is going to be decided by the board of directors of the company. And here I'm just having the method which is calculate salary. I am having another class which is employee evaluator. So which is going to be decided by the managers and the evaluation team. Next, we have employee hiring. So previously, if you will see, everything was there in one class. Now, if you will see, I have split it over three teams, three classes. This employee hiring is going to be decided by the HR team. Now, if you will look at the manager, if you will look at the main class, you will see that whatever operation we want to perform, everything is getting performed here separately. All right. So what SRP says, one class should change only if the instruction is one per entity or one per actor. So if a class is having more than one actor, then I will break it down into total number of actors. In this example, we had three actors. So what we have done, we have split it into three classes. If we had five actors, we would have split it down into five classes. So SRP says every software module should have only one reason to change. This means that every class in your code should have only one job to do. Everything in that class should be related to single purpose. It does not mean that your classes should only contain one method or one property. There may be many members as long as they are related to single responsibility. Like if it is about manager. So whatever responsibility a manager has, we can put it into his class. It doesn't mean that only we are going to be putting one function in one class. We can put more than one, but it should be related to single responsibility, single actor. All right. Now the next one which we are going to be covering is going to be your open close principle. Now the next one which we have is OSP, open close principle. What does that mean? If you have any software application, as a part of that application, we should be actually having two major things, that it should always be open for enhancements. It should be open for new features, and it should be close, closed for code changes. Now what it is, I will be actually explaining it in detail. So this principle says that our code should be open for enhancements and feature addition. Like If today we have one feature in our application, tomorrow we should be having the flexibility of adding more than one feature. But at the same time, when you are adding that feature, when you are making that change, at that time it should not be impacting your existing code. You should be doing the minimal change, but it should not be impacting the entire implementation. Like, let us say I start an application, something called as animal feeder. Okay, so initially I started it with feeding the dogs. So initially, like, let us say I'm getting some positive response, so I thought of extending it to provide support for cats as well. So I provide support for feeding cats as well. Now if you will see, in order to provide support for feeding the cat, what I have done, I have to change the existing implementation of the animal feeder class. In order to do that, in order to add a new change, a new feature is like requiring some of the changes in the existing code, but at the same time, like, as far as it is manageable, I am okay. But if, let us say, in future I want to add more animals, if in future I'm getting more funds from all over the world, and if I want to provide support for all the animals, so do you think by modifying one of the class, like, initially I just had one class animal, later on I made it like, later on in that animal only I made one entry even for the cat as well. But do you think, if I'll have to add all the animals, if is it even going to be a scalable solution, that every time I have to go and provide a support for a new animal, I will have to go and make change in the animal feeder class? Of course no, this is not the right approach. Even though this code is not going to give you any compile time errors or runtime errors, but still, if you follow the open close principle that says that if you are adding a new feature, like, adding a new feature is okay, but if you are adding a new feature, in the name of adding a new feature, you should not go and change the existing code. Now the question comes is, we understood the problem statement. Now how we can go ahead and fix the problem? So in order to provide fix for these problems, the solution is interface. With the help of interface, I can comply to this open close principle. So let us say that I start an application animal feeder. So initially I started with feeding the dogs. I started getting some positive response, so I thought of extending it in order to provide support for cats as well. I will, like, what I will do, I will be changing my existing implementation. So adding a new change is required here. But if you will talk about interface, so what I will have to do, I, like, whenever I have to provide support for any of the animal, that should be child of this interface, and by that it will be easier for us to extend this for the new enhancements, but at the same time we are not modifying the existing class. Okay, let me show you the code for that. Yeah, now if you will look here, what I have a interface, that is iAnimal. So what this iAnimal is having, in this one we are just having a feed function, because like I said, initially I was doing with feeding the dogs, later on I started even adding support for feeding the cats as well. So now if you will see, I have a dog class here, correct? With this dog class, what I am doing, I am implementing the animal interface. By providing that, I'm also like providing the implementation for that feed method. Similarly, if you will see here for cat, I have provided a separate implementation for that feed. And if you will see later on, we have animal feeder. So what this animal feeder is doing, so this one is actually calling our feed method. Like, if we anytime want to feed animal, what we will be doing, we are going to be calling this feed animal, and there we are going to be providing the new animal which we have. If it is a dog, we will provide new dog. If it is a cat, we are providing new instance of the cat class. Similarly, if you in future, if you will have any other animal, so what you will be doing, you're just going to be adding a new class for that, and that is going to be implementing our iAnimal interface, and later on you will just straight away call it from here. Okay, so this is how, if you will see, like for the dog class we are passing the dog object to this animal feeder. For the cat class we are passing the cat object. Similarly, in future, if you will have tiger class, you can pass its object without changing the animal feeder. So in this case, if you will see, we are able to provide support for the new animals, but the existing animal class, existing animal feeder class. It does not require a single line of code change. But previously, like, what if we were not having a separate classes for the dog and cat? We would be continuously making changes in our animal feeder class. So this way, by segregating it out, by providing the extension for the new enhancements, but closing it for the code changes, we can say we are achieving the open close principle. So open close principle says open for extension, closed for modification. So we need to design our modules or classes in such a way that new functionality can be added only when new requirements are generated. And closed for the modification means if we have already developed a class, it has already gone through some level of unit testing. Later on, we should not be altering it out, because then we are going to find, like, some newly introduced bugs in that. So that is why we always try to close it for the code changes. All right, now we are going to be learning the Liskov substitution principle. Now we are going to be learning Liskov substitution principle. So what Liskov substitution principle says that you should be able to use any derived class instead of a parent class. And you should make it behave it in the same manner without modification. If you will closely observe this, whatever I have said, what does it mean? It means, like, this is something which is the closed reference of your open closed principle only, because here we are ensuring that we can have a new derived class that can extend the base class without changing its behavior. What does it mean? If you have a parent class and a child class, now let us say you want this parent class to behave little differently, but we are saying do not make changes here. Instead, what you can do, you can create a new child and you can make this child behave in the same manner. So this ensures that the derived class is not affecting the behavior of your parent class. In, like, it says that whatever the derived class is there, that should be substitutable for the base class. Now, like, when you talk about inheritance, that is where we perform is a test. Like, I'm just trying to explain it more further. So when you talk about inheritance, here we perform is a test. What we actually do here, so like, let us say we have two classes, class 1, class 2. If we can say class 1 is a class 2, so basically what we are doing, if this relationship is true, if we are able to build this relationship, what can we say? We can say C1 extends C2, and if we are able to achieve this, we can say here we follow inheritance. Correct? This is what our inheritance principle is all about, correct? But this concept, which inheritance is following blindly, Liskov is saying that this is not enough. Doing is a test is not a great way to choose to decide if we follow inheritance there or not. If you're not able to understand, let me give you some real life example so that it will be all meaningful for you. Like, if you talk about a real life example, if a child has taken birth from a parent, so that is not the only criteria which is going to be deciding that whatever the parent is going to have, we are going to give it to the child. Correct? Although in India, we follow that only, that whatever the parent is having, they will give it to the child. But if you have seen certain scenarios where the child is not at all behaving nice, parents are nowadays saying that, okay, we are not going to give you anything from our property. Correct? So this is like, although this is something which we feel that, okay, this is a normalized thing, but still nowadays a lot of people are taking some actions on the top of that. So what they are saying, like, even ideally what should have happened, if the child is a good son or a good daughter to take care of the parents properly, also they are a good human being, then only they should be inheriting the parents hard earned money. Because, like, these days kids are not at all responsible enough. So if they are able to do that, and if you will just look at it morally, so this is also right, that if you're not taking care of the parents, if you're not listening to their words, if you are against of whatever they are saying, then considering that whatever property they are having is going to become yours. That is not at all right. So this is what Liskov principle says. So it says that just because if C1 is a C2, that doesn't mean that it is going to be sufficient for the inheritance. So understand that for inheritance, just like in the real world, child should be an ideal child. Similarly, in the world of programming, for the inheritance to happen, it should happen only if parent can replace child at all the places, then only inheritance should be allowed. So this is what we should be considering, that if a child can replace parent in all of the scenarios, then only it should be happening. Like if a child is actually taking care of all the responsibilities. Let me take an example here. Let us say we have a cat class. So this is our parent class. Okay. Now out of this, we have two childs for that. So the first one is pet cat, like a real cat which you are having as your pet. And the another one could be your toy cat. So this one is just a toy. Now we can say pet cat is a cat. And similarly, we can say toy cat is a cat. If you will see in both of these, we are having is a relationship, correct? And that relationship is correct, both. So here that relationship is getting satisfied for inheritance. Now we need to see for the Liskov's principle. So this toy cat is not an obedient child because cat said, I want you to do two things. First one is drink milk. The second one is speak. Correct? Like that is what we can expect out of an animal. Now, since this toy cat is a mechanical device, if you will give him milk, it will get spoiled. It will not work. Correct? So drink milk method is going to throw exception in this case, because since it is a mechanical cat, it cannot drink. So what Liskov principle say that if your child is not obeying the method, it says that even if you follow inheritance, even though your toy cat is implementing the cat interface, still it is not obeying the drink milk method. It is violating the Liskov principle because here it is not obeying the drink milk method. Here the Liskov principle is getting violated. Now, how can we sort this problem out? So in order to sort this problem out, we have the next concept, which is interface segregation principle. Now we will look into it. Yeah. Now the next one which we have is here ISP, interface segregation principle. Now what do we say here? Like, if you are not following your interface segregation principle, then there will be violation of Liskov principle. If you will see, these both are also interrelated. So it says that one interface should not have multiple methods. Interface should do as minimal things as possible. Interfaces should not have multiple functionalities. It is best if you have limited methods in your interface, because if you will have many methods in your interface, then you are forcing every child to implement all the methods, which might not be possible. Like I'll give you one example. You have employee class, you have department class, and let us say they are following some interface, I interface, just giving this name. And in this interface, I have something like get employee salary. And I have something like get employee department, get department count. So if you will see, if I talk about just employee class, here employee salary and employee department is making sense, but department count is not making sense. Similarly, if you talk about department, their employee their department count is making sense, not the remaining one. So these two interfaces are not going to get implemented. So if, like, I have seen some of the developers writing the code, and there they just provide some dummy values for these methods, or they will just leave it unimplemented. But that is not at all a right approach, because we are forcing the child class to implement those methods even though we are not providing any implementation there. All right, so what we say, like, we'll just continue with our cat class. So if you have that interface iCat, so what we had two methods there. The first one is drink milk, and the another one is to make sound. So these are the two methods which we have as a part of our interface. So now the problem will happen when we will have child toy cat. This cat is only going to be making sound. It is not going to drink milk. Cat interface is having both of the methods. So if your toy cat has to implement this interface, it will be forced to provide implementation for both of the methods. If toy cat is not having implementation for any of these methods, then for toy cat, it is going to be throwing exception. So this problem with your toy cat is like, this exception which your toy cat is facing is because interface is having multiple methods. But instead, how we can actually solve it? We can create two interfaces, I mechanical cat, so since this is mechanical cat, we know this is not going to be making all the drink milk method, right? So here we are just going to be providing make sound method here, and we are going to be having one more interface, I living cat. Here we will have both methods, make sound, other one is drink milk. So both methods are listed here. So what we will be doing, like, this is what we require here. So what we will do, is it even logical to, like, declare make sound here separately? What is the ideal approach? Instead of doing it in this way, what you can do something like this interface implements, because one interface can implement the another one. So we can implement I mechanical cat, and what we can do, this make sound, instead of creating a make sound of its own, we can go ahead and implement this one here. So if you will see, we are not repeating our code, we are making most of it. And again, whenever we want both of the functions to get implemented, we know, then we will be calling I living cat. But if you want only make sound, then we are going to be calling I mechanical cat. So if you will see in the interface, what we are doing, we are just segregating it out. That is what your interface segregation wants to, like, this interface segregation principle wants to say, that, like, we should not be forcing anyone to implement interfaces they don't use. Instead of having one fat interface, we should be having many small interfaces which are going to be having some set of group of methods and serving one sub module. Like, if everything is just related to one, then only you should be putting at one place. So an interface that should be more closely, like, whatever code you have written, if that interface is more closely related to that code, in that case it should go ahead and implement that. Otherwise, no. Okay, now the next one which we are going to be covering is your D. Now we are learning D. D stands for dependency inversion principle. All right, so what it says, that if you have a higher class, so it should not directly depend upon your low level classes. Like, I'll just explain it to you with the help of example so that you can understand it more. So, like, let us say there is a person, and, like, this person wants to make movie. Now in order to make a movie, what and all we require? So we are going to be require a producer, we are also going to be require a director, we are going to be requiring actors as well, we are going to be requiring actresses as well, correct? Now future, we may be having a need of adding a choreographer. All right. Now, if you want to go ahead and add it here, if you want to perform that addition, what it will be doing, it is going to be violating your dependency inversion principle. Now, how it is actually violating? Because if you will see your open close principle, this is violating that as well. This is a bad design because my parent class, my high level class, which is movie maker, is directly interacting with the low level classes. So it is violating the dependency inversion principle. That is why we say that open close principle is getting violated here. Correct? Because initially it had only these attributes. Now I'm adding a choreographer as well. Correct? So dependency inversion principle says that higher class should not depend upon the low level classes. So now the question arises, if it is not going to be depending on your low level classes, then on what it should depend upon? So the answer is abstraction. Higher classes should depend upon abstraction for the low level classes. So you will also realize by now that all the 5 solid design principles are kind of interrelated to each other. If one is getting impacted, the other one is also going to be infected. This dependency inversion principle is very much similar to your open closed principle. Like, I'll give you one more example. In the company, you know, we are going to be maintaining some of the hierarchy, right? So on the top, there is going to be some CEO. Under that, we are going to be having some VPs. Then we will be having some directors. Then we will be having some managers. And under manager, we are going to be having some employees. Now, I don't know if you have seen, the CEO is not going to come and talk to the employees directly, even if we are having any issue or anything. In none of the case, he is going to come to you. We follow this hierarchy here. So this is the low level class here, which is employees. If you will see, if some issue is there with this employee, who is going to come and talk to that person? Manager. If the manager is making issue, who is going to come? Director. And so on. This is what we are doing here. So if you will see, we are following dependency inversion here. So dependency inversion principle says high level modules, high level classes, they should not be depending upon your low level modules and classes. They both should be dependent upon the abstraction. Also, abstraction should not depend upon the details. Details should be dependent upon abstractions. So whenever you will be having a high level module or the class, and if that class is having a dependency on the low level modules or some other class and knows a lot about the other classes, it is interacting. So we will say it is a tightly coupled. When a class knows explicitly about the design and the implementation of the another one, it is raising the risk that if we are making changes at one class, that is going to be breaking the another one. So we should always be maintaining these high level and low level modules and classes loosely coupled, like as loosely as we can. In order to do that, we are going to be making both of them dependent upon the abstraction instead of how these both are related to each other. So that's all I had for the solid principle. Now in the next one, we are going to be learning about your design patterns. Hello everyone. In our today's module, we are going to be learning design patterns. So when you talk about design, like let me give you some quick brush up about design, okay? So this designing is basically of two parts. One is your design principles and the other one is your design patterns. Now, if you look at it, so this design principle, that is actually your theory and there is no concrete example of the same. And if you talk about your design pattern, so this is where we go ahead and perform our major implementation. So when you talk about design principle, that is where we actually learn what we should be doing. On the other side, if you talk about design patterns, so that is where we see how we should be doing that. So in many of the interviews, you must have encountered a lot of interviews related to the interface, abstract class, delegates, and other features related to your object-oriented programming. along with the design related questions, uh, design pattern related questions. So these design related solutions are evolving from the features of your object oriented programming. So a lot of people actually feel that what design patterns are. So a lot of people actually feel that this is code. I repeat, this is not at all a code. These are the design level solutions from the problems which we engineers are facing. I have also said it previously as well. Here we are not introducing anything new. We are not doing anything new. It's just whatever existing we are having. Here we are following certain guidelines that how we can use them in order to achieve our goal. Okay. So these, if you are going to be using these design patterns, using all of that, whatever the design you are going to be achieving for your solution, so that is going to be a, that is going to have a good readability. And these design patterns, these are basically created and used by your object oriented programming languages such as Java, C Sharp and all. So these design patterns are going to be providing you the solutions for the problems which we encounter in our day-to-day life. So these are actually targeted at solving the problems of your object generation and integration. Now I'll just give you one example here. So when I was giving my interview, when I had some 2 years of experience, so at that particular time, what happened, they asked me that, okay, you create a class, and on the top of that they said, okay, now you go ahead and implement some design pattern on the top of it. So just with 2 years of experience and zero knowledge about system design, I could not able to answer it. But later on I understood, okay, how we can actually improve it properly. Okay, now we have different types of design patterns. Now how these design patterns are actually coming into the picture, how we are actually deciding that how it should be there. So if you talk about any object, so for that object, we actually if you talk about any object from the object oriented programming, the center part is always the object. And with any object in any application, we can do three things. Either we can go ahead and create the object, correct? Otherwise, we can see how the behavior of the object is going to do. And lastly, with this object, we are also going to be seeing how we can structure it out. So these are the broadly three things which we can do out of our object. So based upon this, you have seen based upon this, we have a different design related design patterns which we are going to be learning here. So broadly, we have 26 design patterns, which gang of four is there who has introduced these design patterns, and category wise they have divided it into three parts. The first one is your creational design pattern, the second one is your structural design pattern, the third one is behavioral design pattern. When you talk about creational, so here we are going to be seeing how your classes are going to get instantiated. So these can either be your class creation related patterns or the object creational patterns. When you talk about creational patterns, so they are going to be giving your program more flexibility so that you can go ahead and decide which pattern you are going to be needing for your given case. The second one which we are going to be having is going to be structural design pattern. So these structural design patterns are designed in order to how your class is going to get structured, how you're going to be composing your class. This design pattern is going to be focusing upon decoupling interfaces, and here we are also going to be providing the implementation of the classes and its object. What is the main goal of the structural design pattern? So the main goal is to increase the functionality of these classes without changing much of its composition. And similarly, when we talk about behavioral design patterns, so here we are going to be seeing how one class is communicating with the another, how one class is behaving with the class and the other objects. So basically, this is what we are going to be having. Now inside your creational design pattern, the most commonly asked design pattern is the Singleton design pattern. Now, if you talk about either of the company, generally, people will be asking a straightforward question like, tell me what a singleton design pattern is. Or they will be saying, okay, this is your given class, convert it into a singleton design pattern. Or they can just ask you questions like how you are actually going to be determining if we can use singleton there or not. So broadly, I have told you the three types of questions which can be asked out of this design pattern. So let's just take a deep dive into a singleton design pattern and try to get answer for all of these questions. Now we are going to be learning about singleton design pattern. If you will see this word singleton, what you can understand from here, single. So this design pattern says, I believe in staying single, but even after staying single, it will have dominant role in the society. Singleton design pattern is majorly used when any one instance or object for a given class is required. So any application, if you look in the industry, if you go by the number, just say if you are having any of the application and that application is having some number of applications, class 1, class 2, and up to class 100. So these are the different classes. If you will see, we have a lot of classes available here, right? And for any of the effective work, the flow can move through the different classes, because that is how it is designated, like the flow will go from one class to the another and so on. Now, how your code is executing, whether everything was in the place or not, how you can figure out, that is by logging in the details. And that's what all the things are happening in each of the classes. So what you can do, you can just log it. I'll just give one small example here. You must have seen sometimes when you are sending a message to someone, or like if you are performing some of the operation, not just be specific to sending a message, if you are performing any of the operation, you must have observed that after a while it is crashing. Like not always, but sometimes it does, correct? So now as a developer, how, as a user, how you are going to be telling it to the developer that hey, your code is crashing here? How a developer will get to know where I need to put my more efforts in order to investigate what has went wrong there? By logging in all the messages, example, it crashed while sending the message. What if you would have logged all the steps, what and all steps we involve to send a message? Unlocking a phone, opening the message app, sending selecting the sender, composing the message, clicking on the send button. Let us say before clicking on the send button it has crashed. So by maintaining these logs, we will see that there is no log for sending message. That means it failed before that. So with the help of these logs, any user will get to understand where it has crashed. So that is where logging comes into the picture, because even if you would have seen your normal code, we provide a lot of logging. Even if we see any code can possibly result into some exception, we are going to be printing one log message there. And that also states which line or which function this must have created the problem. So the whole purpose of creating a logger is that it will help you in understanding where the crash has happened. So now if you will consider this class which I have just taken here, this application which I have just taken here, in this application, we will have only one single file which we will be naming as app.log. And what will happen? So whatever is happening in this class C1 or whatever is happening in this class C2, C3, C4, all of that logic will go to one file, and that is app.log. So you will understand how the request flow works. So if you want every class to go and log in the app.log file, you will need an object who is typically doing that, who is typically doing this job for you. Since every class is going to log in the same file itself, what we will be needing, we need one object throughout. Because if there will be multiple objects, there will be multiple instances of that object, and there will be some different logs. You will not be able to understand, because every instance is going to be creating a new logging, and then it will be difficult for you to understand how, like, where the flow has broken. So if you will see, in order to maintain one object throughout, that one object is going to be called as singleton. So when you talk about singleton, like I said, it is going to be a part of the creational type pattern. So we are here we are actually going to be dealing with the object creation mechanism. So here what will happen, if you are having multiple classes, let us say class 1, class 2, class 3. So what we will be doing, instead of creating, like, normally this will create object 1, this will create object 2, this will create object 3. Correct? That is how generally happens. What we are saying, instead of this, all of these should be reporting to singleton object. All right. And that singleton object will go and it will perform the given task. So if we are following this flow, if you will see, what we are doing, we are just trying to make our class singleton here. We are just trying to have one single object throughout. Now we will see how you can go ahead and create a singleton class. So, for this, we have to take care of certain of the things. First of all, you will have to make your constructor private. Like, first I'll tell you what and all things you will be requiring, and after that we are going to be discussing everything one by one. Okay. So make constructor private. Now after this, what you will be doing, you are going to see that whatever the object has to get created, that same class will have to create the object. Okay. Or what we can actually say, we are like, since we want uh, to have a single object, so what we are going to be doing, we are going to have a private attribute of that same class. Because if it is private attribute, so what will happen, only that class is going to be responsible for creating the object. Now since this is a private attribute, and now you will be needing to expose it to the outside world. So in that case, if you ever want to expose anything to the outside world, what you need, some some public thing, right? So in this case, what we will be doing, we are going to be needing a public static method, and that public static method is going to be exposing this private attribute outside the class. Okay. So, like, why we are actually making this constructor private? So by making the constructor private, our class is actually going to be responsible for creating the object. We are not going to let anybody else to create the object, since it is private. So only that class is going to be having the access of creating instance of that class, so that that problem is sorted, that nobody else is creating the object for that. So at least one class should be able to construct it, so the class will be creating the object itself. Now when anyone needs that object, then they will be calling this class, and they will say that, can you give me that instance, can you give me the instance of your class? So the static method which every class will use to get the instance. And if you will see here, we are actually needing the three things here. First, and all of those things are actually interrelated to each other. The first one is private constructor. So if it is private constructor, nobody else will be able to create a instance of that class. The second one is private attribute. Now that constructor is going to be instantiating that class, and with the help of this private attribute, we are going to be instantiating it. The third one is public static method. So this one is going to be responsible for exposing that private member outside. So these are the three things which we are going to be needing outside. Now I will be showing you one example of the singleton class. Now in order to understand singleton design pattern, I have actually taken two examples. We are going to be discussing both of them. Okay. So here, like I said, we are creating one Singleton example. And one more thing, here I have written code in C sharp. Oh, sorry, here I have written code in Java. So if you guys want to try it out for different languages, first of all, you see if we have the support for design patterns for that language or not. And if it is there, after that, you just have to modify the changes in your syntax accordingly. All right. So here, what I have done, I have created a singleton class. Like I mentioned, we are actually going to be creating a private constructor for the same. So here, if you will see, generally, how do we create a constructor? Public class name. Here, if you will see, we are creating it like private class name. After that, like just for the understanding purpose, here I'm just printing a message, private constructor. Now, if like I said, what we will be needing, we are going to be needing a private member. So with the help of this private member, we are going to be instantiating our singleton constructor. Okay. So here what we are doing, we are instantiating it by new singleton example. Now if you will see, we have created a public method, and that method is going to be exposing this instance to the outside world. And here I have just created one message, one function which is for printing purpose. Okay. So that's all we have in our singleton exam class. Now from the main method, what we are doing, if we want to create instance, like generally how do we do? Class name, object name is equals to new class name, and that's like that object instance is going to be having that access to that class. But here, since it is private, you cannot do it that way. Even if you will try to do, it is going to give you some error. But how can we improve it? You can just simply do class name, then some instance name, class name. Since this was a static method, so what is the best part about static method? If you want to access it outside, you just want to do it by class name dot method name. So that is how with this instance we are having access to our print message. And here if you will see, the moment we are invoking this, we are also printing this private constructor. How it is actually coming? That is because this is the constructor, and that constructor was holding a message, that private constructor. And with this print message, this hello world is getting printed. So I hope you will have a little clarity across what singleton design pattern is. Okay, let's look into the another example. So here what I have done, I have created one class here. So this is class demo, and this is a public constructor here. Okay, where we are just printing a message, demo constructor. Now this is having another method for printing, which is just printing print demo. Now what I have done in this singleton, like another class I have created the singleton example, and in this one everything is same just like your previous message, except here I have made one change, that whatever message I'm going to be passing, that will get printed here. So I have this method which is print message, and the another one which is print static method. Here message will get printed like message, and here it will be printed like static message. Now when we are going to be creating multiple instances of the demo class, like for that first one, if you will see what output we are going to be getting, multiple times it has printed demo constructor, demo constructor. What does it mean? Even though that file was one, but since we have instantiated it 3 times, so the 3 times the constructor got called, and after that we are able to print the message print demo. But if you will see, like here we are creating multiple instances, but if you will see, with the help of singleton, what we are doing, we are restricting the object creation to only one. So with one instance, if you will see, even though we are creating we are invoking it 3 times, but the private constructor is only getting printed once. Why? Because we are actually having one invocation for that, because it is a private constructor, and after that we are able to print both of the messages here. Okay, so that's how we are actually going to be implementing the singleton design pattern. Now we will be seeing how we can realize it in different way. Now we will see how you can realize singleton design pattern in different forms. So the first one which we have here is your early loading, and people can also call it as eager loading. First, I am just naming all of these, and after that, we are going to be looking into all of them one by one. Okay. The next one which we have is lazy loading, and this can also be called as on-demand loading. The next one which we have here is your lazy loading thread safe. And the last one which we have is going to be your enum type. So these are the different ways in which you can go ahead and realize your design, a singleton design pattern. So now let's look into these one by one. Okay. Now we will be first of all seeing what is early loading. Early loading, like the name is saying, before starting the loading process, it is getting loaded. That is like before creating the object, like before utilizing the class, we are having the objects which are ready for us. Now what we will first see how this is actually a problem. So there is a problem with the early loading and how it is actually going to be there. So like, let us see, we have one person. Okay. Now this person is organizing a party. This person has invited one of the friend, and he told that the party is going to start at 8:30. Now certain people are quite early on time. So this friend thought, instead of reaching there at 8:30, why don't I reach there at 8 a.m. in the morning? What will happen if I'll reach early in the morning? I will be there on time. Like, this was the simple thought of this person. Now, what is the problem with the early loading here is that if you will see, even though the party was at 8:30 p.m., still the other person reached their house at 8 a.m. And he said that now I will be sitting here throughout the day. I will be interfering with your preparation. I will be eating your food. And like, if you will realize what is happening in this case, so whatever food the family could have eaten, now this person is also eating the same food. If you will link the same example with the world of programming, you will see that if you are having some early loading, now the variable will get loaded as soon as we are starting our program. So what will happen in that case? It will be eating up the memory and it will be ready for no reason. So what the problem for this problem is to have a lazy loading. So what you can do in our example, you can tell the guard that, like, in such a case, what you can do, you can have a guard here and you can tell that guard that, hey, the party is going to begin at 8:30. So before that, if any guest is coming, do not allow them to enter. But if the time is 8:30, then you are going to be welcoming everyone. So in the life of programming, this is what we call it as lazy or on-demand initialization. All right. Now I will be just quickly show you this with the help of some example. Yeah, now you can see an example of lazy loading on your screen. If you will observe the previous one, which we were doing, that was nothing but a early loading. Here, if you will see what we are doing, we are having a class. After that, we are creating constructor for that. Previously, what we were doing at this place itself, we were creating instance of the class. But here what we are doing, we are initializing it, because we are saying whenever we will need you, then only we will initialize you. So now in this get instance method, previously what we were doing, we were simply returning the instance from there, right? But in this case, what we are doing, we are first checking, is it null? Because the first time we are going to be calling it, it will be null. So instead of all the times creating the all the time initializing it, what we can do, for the first time when it is null, we are going to initialize and store it in our instance variable. But the second time when we will be calling it out, we will see instance is not null, and in that case we are going to be providing the value, like we are straight away going to be returning it out. The remaining code is same. The only change which we have here is only in this case. So that is how we are going to be implementing the lazy loading. So here if you will see this instance, this is a reference to the object of the class. And if you will see, what is this part? That is your private constructor. So that constructor is going to be restricting creating of the objects outside of the class. And if you will see, we have this get instance method. That instance method is going to be returning the reference to only objects of the class. And since this method is static, we can access it using the class name. Now, we are going to be seeing how we can do it in the multi-threaded environment. Now we are going to be looking into how we can utilize singleton design pattern in the multiple threading. So if you talk about Java, sorry, yeah. So if you talk about Java, so you know what a Java is. This is a multi-threaded language. Now, what is the meaning of multiple threads? Like you can actually be having multiple threads for the same, right? By default, if you talk about Java, so it is single threaded. It works in the main thread, but you can make it work even in the multiple threads. So if you talk about the singleton approach, which we have just considered. So that is going to work fine when there is a single thread, because that single thread is going to be creating an instance of that. And this will not work for multiple threads, as in such a case, we are going to be having a race condition. Because in this case, although we are having a private constructor, but that private constructor is ensuring that object is not instantiated other than that class itself. But if you are running multiple threads, in that case we can have multiple threads for the same class, and this can get invoked in the multiple threads, correct? First, I'll just show you the code for the same so that you can also understand it. So now we have the code in front of us, where if you will see, we have a singleton class. In that, we are having a private constructor which is straight away printing a message. Then we are having the lazy loading, because if you will see, we are initializing it to null. Then we are having a get instance method which is going to be responsible for instantiating the object. And after that, we are just having a print message. Okay. And now what we are doing, we are having a main method. Okay. We are having a program. Here, what we will do, we are just trying to have different methods. So we are having one method like print first message. The second one is print second message. So in this one, what I am doing, I am creating object of my singleton class, and I am passing a message to print. In the second one also, I am doing the same. I am creating another object. And the third one also, I am doing the same. So if you will see, I am trying to instantiate it from three different functions. Now, if I want to run it in the multiple threads, what I am going to be doing here, I am using executor service. With the help of executor service, I am trying to execute first, with the help of execute, we are first calling create first object, then second object, and then we are calling the third one. If you will be observing what the message, what the output we are having here, it is printing private constructor, then again private constructor. If you will see, because we are running it in the multiple threads, in that case, this one is actually leading to creating two instances of our singleton class. Now, if you will see here, the whole purpose of having single object is going to get defeated here. Why? Because we are still able to create instance of that class when we are running it in the multiple threaded environment. So if you will see, whatever, we can actually go ahead and achieve our thread safety in the singleton class. And how we can achieve it? When we are trying to do that, we are going to be creating the singleton class in our Java virtual machine during the execution of the method, which is going to give access to the object. So for the first time in the multi-threaded environment, it is possible, we are having the possibility of a situation that two threads might enter into the get instance method at the same time, which could create two instances of the singleton class, which is not required, which is like not better word is which is not desirable. Why? Because the whole purpose of singleton class is going to get defeated. So now what we can actually do here, we can try to see how we can go ahead and implement the same. So I will just be showing you how we can achieve. Now we are going to be seeing how you can maintain thread safety in the singleton class. So the first one is you can create instance variable at the time of class loading, that is through early loading. Now, what is the advantage of doing that? That is thread safety without synchronization. So even if it is not synchronized, then also the thread safety is going to get maintained. Plus, what is the another advantage of doing that? That it is easy to implement. Now, we have seen what the advantages we are going to get with this approach. Now, let's discuss what are the disadvantages for the same. So when you are creating early creation of the resources, of course what it will be doing, it is going to be like there could be a possibility that we are not even going to consume it. There could also be like situation when if we have created the resources, in that case they will still be lying in the memory, eating up the memory, right? So the client application cannot pass any argument, because here what we are doing, we are just instantiating. But because if you will see here what is happening, just we are doing new object from here. But if we would be doing it with this method here, from that client side, we can also have the flexibility of entering some of the parameters if required, and we can also make it to work in the different forms, so we can achieve the reusability, right? But in this case that reusability cannot be achieved. So if you will see, we have this get instance method. Now, what are the advantages of this get instance method? So this get instance method is going to be ensuring the thread safety. In this case, we are actually achieving our lazy loading, and the client application can pass parameters because this is a public method. If we want anything to get passed, we can go ahead and pass it from here, right? So if you will see, this instance is here. What we are we are creating our instance through here. What we are doing, we are creating new object like this, and we are having this get instance method. Now with this, what we will be doing, we are just checking if the applications are synchronized or not. So what we are doing, we are making use of the synchronized block, and that is going to be helpful for ensuring that we are having thread safety, we are having lazy loading, plus we are also ensuring that if the client application wants to pass some parameters, then we are able to ensure it, because this method can go ahead and take the parameters. Also, if you will see here, what we are doing initially, we are just taking that object here, then we are seeing like to this we are passing the instance, and then we are checking if it is null, then for the first time you are going to initialize it. For the remaining times we are just going to be passing it out. So this is how we are ensuring thread safety here. And if you will see, remaining implementation is same. And if you will see here, if we will look at the output, so the private constructor is getting invoked only once. Like the previously, if you have seen, there it was getting printed multiple times, but here it got printed only one time. So if you will notice here, the singleton example which I have taken here, this one. So this one is there to improve the performance of the code. So in cases where the instance is already initialized, which will be happening most of the times, then the volatile field is only accessed because of the statement, right? So here if you will see what we are doing, we are actually checking that if it is there or not. If it is not there, we are just returning. Otherwise, we can go ahead and initialize it, all right, inside our synchronized block. Okay, so I can just highlight it. So this is how we are ensuring thread safety. Okay, now the next one which we have is the, now let's quickly discuss what do we have in the singleton class of enum type. So here what we are going to be doing, in order to create the instance of that class, we are going to be using the enum block. And from that enum block, we are going to be providing the instance. So that enum block is going to be responsible for that. Now I'll just quickly show you the code for that. So if you will see here what we have created a enum, that is singleton enum and ex, like I have taken example. Okay. So in this, what I'm doing, I'm creating the instance like instance. Later on, I am going to be using this singleton enum class. And here, if you will see, what am I doing? I'm just creating like, private member for the message. And here I have set message. And we are also having the print details message where we will go ahead and print the message. And if you will see, this is the main method from where we are going to be calling it out. So if you will see what we are doing here, when we want to uh, use that instance, what we are doing, we are using that enum type uh, class dot the type instance type, then we are calling the message. So that is how we are going to be using. So here if you will see the enum type which we have used here, that is implicitly declared as the public static final field of the singleton enum example type for each of the constant which we have declared in the body of singleton enum, right? So in other words, what we can say, the Java virtual machine is considering that constants instance is of type singleton enum example, and that is also your public static field. So this is the behavior of the class instance which is required by the design of the singleton class. And the Java compiler that takes care of this implicit declaration, and it ensures that this is thread safe. So if you want to achieve thread safety, you can use the enum type for the same. So this behavior of the singleton, this we can achieve even with the help of enum or the thread safety. Now let's quickly discuss what are the real world usages of the singleton, because firstly we have covered what singleton is, then we have discussed what are the different types of singleton. Now let's quickly just see how we can consume it in the real world, and then we will just uh, close this module. Okay. So what are the real cases in you can use it. I gave you the initial example of logging. So you can use singleton so that you can go ahead and perform logging, and logging is something which is highly required in most of our projects, because we will surely be needing to log each and everything. Okay. This one can also be used for exception logging, because just now in the beginning itself I said that if it will result into any exception, you should be knowing where it resulted. This also this is also helpful for connection pool management, because when you are trying to build the connection, you do not want multiple instances of that connection, you just want only one to be there. It is also helpful for the cache management, because again for the cache we just need one instance to be there. This is also helpful for printer spooling. So whenever you require some device managements like printer spooling, because that printer is going to get addressed between access between multiple people, generally on one floor we will have one or two printers. So how people can do, from their system itself they can give print command, but those commands are going to get addressed one by one. Otherwise what will happen, one page of your request is getting printed, one page of another bit, like another one's request is getting printed, and that is not something which is desirable, right? You can also use it for file management if there is a file and if you are providing some read write access to that. Now what will happen, for the read anybody can come and read it, but if anybody is modifying it, at that time you will only be uh, preferring that only one instance of that file edit is there, so that we are not having rewrites or we are not losing some of the information. So that is how the singleton design pattern can be consumed. So that's all I had for the singleton. Now in the next module we are going to be learning the factory method, factory design pattern, and your abstract. Okay, so I'll see you there. Till then, happy learning. Bye bye. Hello everyone. In this module, we are going to be learning about factory design pattern. So you guys must have heard of this word factory in your real life as well. So what is the first thing which comes into your mind when you hear any word factory? So we say we have a plastic factory, we have a cloth factory. So what do we actually understand by that? That okay, this is where the production is going to be happening and that is going to be massive in number. So this factory always means mass production because in the factory we are going to be getting in the factory we are going to be creating similar kind of products, and from the factory they are going to get to the wholesalers, and from wholesalers the shopkeepers are going to be buying, and from the shopkeepers you go and get it. That is how it is going to be happening. So when you talk about factory, what does it mean? It means massive production of similar kind of products. Correct? So here, when you talk about factory design pattern, what is the one thing which comes into your mind? Since one place I am saying mass production of similar kinds. So if you talk about factory design pattern, so is it going to be something where we will be dealing with similar kind of objects? So yes. So when you talk about factory design pattern, so that is the one which will come to rescue when we will have to perform mass production of similar kind of objects. So let me just take example that okay, we have some car factory. Okay, now, when you talk about car factory, so what can be there? What this factory must be doing? So this can be creating some large number of cars, correct? Now, after having this car can act like this factory can be creating if you talk about factory, let's say we have a toffee factory, okay? Now in that it's not necessary, one thing is there. If you talk about the factory, so one brand is going to be having one factory. If you talk about the different products by that brand, so all of those are going to get manufactured in the same factory, right? What do I mean? If it is a car factory, it's not that that factory is only going to be creating some red cars, some blue cars or something like that, correct? But what it will be doing, it will be creating the different types of cars, but of the same brand, correct? So here we can have some basic cars, as well as this factory can be responsible for creating sports cars as well. So both of these cars are going to be getting manufactured at this car factory. Now, if you will have to apply factory design pattern, then there are the certain things which you will have to keep in your mind. So the first one is like what are the things which you will have to take care. The first one is you will have to use interface. Okay. So when you are going to be using interface, that is a concept of object oriented programming. So when you are going to be using this, along with that you will have to apply some inheritance, and along with that you will also be applying some polymorphism. So these are the two concepts of object oriented programming which you are going to be using here. Okay, now what you will be doing, like the first one is you are going to be using interface. The second one is you are going to be creating child class. All right, like you can say child classes, they can be more than one. And lastly, you are going to be creating some factory class as well. Create factory class. So basically, if you will see what we are doing here, we are making use of interface, we are creating some child classes, and we are also creating a factory class. So now we are just going to be understanding it even more, okay? Before jumping into the implementation, okay? So if we have someone let's we are going to be taking the real world factory layout, and accordingly we are just going to be understanding how these things are going to be coming into the picture in respect to the real world factory layout, okay? So real world factory outlet. All right. Now, now we will be like, whenever you will be creating any factory, you will have to see what category you are going to be covering there. Okay. So the first one is going to be what category you want. Now, after this, you are going to be focusing upon actual product. Like, let us say you thought that, okay, let's have a biscuit factory. So you thought some eatable factory. So the first one is you categorized, okay, I want to eat some eatable there. Okay. After that, I said, okay, in that I am going to be producing biscuits. So that is my actual product. And after that, like, once you have these two things ready in your mind, the third one is going to be, you are going to be establishing factory. So these are the three things which you are going to be considering before jumping into setting up a factory, correct? Now, in the world of programming, if you talk about category, so where it is going to be lying, the interface is going to be your category. Because if you will see from the code, from the coding perspective, what interface does, it is a lightweighted component where it will be providing a flexibility of inheriting and completing its implementation, correct? Now, what the actual product is, like I took the example of car. In the car, you can have basic car, you can have sports cars. So what the actual product is actually coming into the picture in respect with your programming, that is child classes. So if we would have taken the example of cars, one child class would be basic car, another one would be sports car, correct? And lastly, we are seeing establish factory. So what that is going to be doing, like how we are going to be linking it with the real life world. So that is going to be creating your factory class. So if you will see, with the help of all of these, I am able to relate a real life factory with our coding work. Now we are going to be just taking that car example here and putting all our understanding there. Okay. So if you talk about that car example, what I said, we are going to be having two types of cars, your basic car, and the second one is going to be the sports car. In our understanding, what we are like, if we have to implement this, what we are going to be doing, so we are going to be creating an interface for this car, and that interface is going to get consumed by both of these classes. What are those? Like, this is going to be our child class 1 and this is going to be our child class 2, and both of these classes are going to be consuming your car interface. After this, we are also going to be creating a car factory. So like I said, what this car factory is going to be doing. So this car factory is going to be for, like, this is going to be responsible for creating different types of car. So responsible for creating different types of, and like based upon this understanding, you will be able to understand what three things we require in our factory design pattern. First one is interface, second one is your child classes, and the third one is your factory pattern. Now if you will have to see, like, what we are doing in our factory design pattern, in this one we are creating objects, but we are not exposing the creation logic to our client. So what can we actually understand by that? Like, example, I'm the client and I want someone who can, like, and let us say I have some newspaper brand, okay? And I want someone to create me the website for that, application for that. I will not be interested into understanding what logic they have written for that. I will be only interested into having the end-to-end implementation of my requirements, correct? So what they are going to be doing, instead of exposing their entire code, entire logic to me. What they will be doing, they're just going to be providing me the access to the objects, and me as a client, I will be happy because I am not interested into what they have, what code they have written, what logic they have used there, but I am interested into making my application work as I desired. So what we have, if you are having a client, that client is going to be using this factory. We are not going to be exposing the entire logic there. So this client will be using this factory, and what this factory will be doing. So this factory is going to be creating the product and uh, product of the similar type. So that is how the layout is going to be there. Now we are just going to be taking one example here. First, let me explain you the little layout about it, and then we will be looking into the implementation. So like, let us say we are having some credit cards. Okay, so what we will be doing for this credit cards, what and all things are going to be there. So there is going to be, I'll just take two parameters, some annual fees, and apart from that, I'm also going to be seeing some um, monthly, some limit, because all the cards are going to be coming with the limit. Okay, so this is going to be my interface in my case, and this credit card is actually going to be like, I'm going to be taking two types of credit cards. It can be something like platinum or some titanium. So now let us see, by using this, how can we write down the code for this. So now we are going to be looking into this factory design pattern, and here what we are basically trying to do, we are trying to differentiate the two cards, the platinum card and the titanium card, and we are going to be segregating their annual fees and limit based upon the card type. So here, what I said, the first one which you are going to be requiring is going to be an interface. So here, what I am doing, I have taken one interface for the credit card, that is iCredit card. Inside that, I am taking three members. The first one is methods. The first one is going to be getting the card type, like if you have a titanium card or if you have a platinum card. The next one is to get the annual fees of that card. And the last one is to get the card limit. After that, I said that we are going to be needing the child classes. So here we are having two child classes. The first one is going to be your platinum class, platinum card class. The second one is going to be your titanium card class. So here, and they both are going to be implementing that interface. So here, if you will see, when we are implementing that interface, we are going to be providing the implementation for all those methods. So what we are doing for the card type, we are returning platinum. For the annual fees, I have just taken 100. Okay. And for the card limit, I have taken 10,000. Similarly, for titanium, what I have done, for the card type, I am providing titanium. For the annual fees, I am providing 500. And for the limit, I am providing 40K. I have just taken some rough values. After that, what I said, we are going to be creating a factory for this. So we are creating a credit card factory. So in this one, I am creating a method that is get credit card details. And based upon the card type, we are going to be providing the details. So initially here, what we will be doing, I'm going to be of that interface, I'm going to be creating an instance. Now, based upon this card type, like if it is platinum, we are going to be returning the instance of platinum card class. If the card type is titanium, we are going to be returning instance of the titanium card class. And if it is none of those, we are just going to be printing that this is a invalid card. Now, what we are doing, we are creating a demo class, and in this, we are just consuming the factory here. Okay. So here, if you will see, just formatting it for the better understanding. Yeah. So here what we are doing in the beginning, we are taking a credit card. After that, we with the we have taken a variable credit card, and after that what we are doing, of that credit card factory, we are calling the get credit card details, which method is taking your card type. So this one we are referring. Since this is a static method, we are able to just call it directly by the class name dot method name. Here I am providing that my card type is platinum. On the top of that, we are checking if our card is null or not. If it is not null, we are returning its annual fees and we are returning its card limit as well. So that is how we are able to make it work. Now, you have actually understood whenever you are going to be implementing factory design pattern, what is the one thing which we are going to be doing here? We are not going to be exposing the object creation logic to the client. In order to achieve this factory design method, we are going to be creating abstract class as the factory class, because that is going to be helping us in creating and returning the instance of the product. And here what and all we are going to be needing, we are going to be needing first of all the interface. Then we are going to be needing the after that we are going to be needing the child classes, and then we are going to be creating a factory class which is going to be which is later going to get exposed to our client. So that is how the factory method is going to be. Now we are going to be discussing abstract factory design pattern. So first of all, here we are going to be learning what abstract factory design pattern is. After that, we are going to be learning what are the advantages of using abstract factory design pattern. Then we are going to be also discussing what are the different usages of the abstract factory design pattern. And we are also going to be seeing how we can go ahead and implement it. And at the end, we are also going to be comparing what is the difference between your factory method and the abstract factory pattern, so that it will be easily understandable to you that if we will have to make a choice, which one to go ahead and use. Okay. So firstly, we will be just starting with what a abstract design factory pattern is. So this one is going to be helping you to provide an interface for creating families of related or dependent objects without specifying their concrete class. So here what we are doing, previously we were just taking care of one factory. This abstract factory design pattern you can consider like factory of factories. So here we are going to be having group of individual factories that will have a common theme, and we are not going to be specifying what their concrete classes are. Example, if e-tables, so like e-table is the broad category. Inside the e-tables, we can have a biscuit factory. We can have a noodles factory. We can have any number of factories under that. So that is how the abstract factory pattern is going to be there. So this abstract factory pattern, this works around the super factories. Like I said, like this is actually your super factory, or you can go ahead and call it as factory of factories. All right, so that is how it is going to be there. So this super factory is going to be creating your other factories here. So this type of design pattern is going to be coming under the creational pattern. Why? Because this pattern is providing one of the best way to create an object. When you talk about abstract factory design pattern, here we are going to be having an interface, and that interface is going to be responsible for creating a factory of related objects without explicitly specifying their classes. You need to be very clear here. We are creating factory of factories. We are creating different objects. We are creating factory of related objects. And we are not explicitly telling what their classes are going to be there. We are not exposing their concrete classes here. Here, each generated factory is going to give you the objects as per the factory pattern. And this must be somewhat clear to you that how it is different from the factory pattern. So you can say this is the subset of factory is a subset of abstract. Now, let's quickly discuss what are the advantages of abstract factory pattern are. Okay, so what is the first advantage? This one is going to be isolating the client code from implementation classes. Okay, but what does it mean? We are not exposing the implementation classes to the client code. Like there is going to be a what you can say abstraction in middle of that. Okay, so we can say how it is helpful because it is isolating client code from implementation logic. Okay, now this is also helping you in maintaining consistency among the objects, since here we are producing multiple objects of the same type. So when we perform such an operation, we also want to ensure that we have consistency among all the objects. It means all the objects should be same. So with this, we can ensure consistency in different objects. All right. Also, this helps in providing an extra layer of abstraction. Now we are going to be discussing what are the usages of your abstract factory pattern. So the first one is when you need your system is independent of how your objects are going to be created, composed and represented. In such a case, you should be going ahead and using abstract factory pattern when system is independent. Of objects, like how it is going to get created, how it is going to get composed, how it is going to be represented. Also, when you can be using the abstract factory design pattern, when you know your system needs to be configured with one of the multiple family of objects. So when you actually need like that level of hierarchy, when you actually need that, okay, on the top there is going to be one category, inside that there are going to be multiple categories, and inside that you are going to be having multiple family of objects. When you have such kind of system, for such a system, we are going to be using abstract factory pattern. When you want to provide a library of objects which does not show implementation, but it only reveals the interface. So if you want to expose the logic, you can only do it. If you want to expose the methods, you can only do it with the help of interfaces. You are only going to be revealing the interfaces, but you are not going to be exposing how it is implemented. So in such a scenario, using the abstract factory is going to be making more sense. Now we are going to be seeing what and all steps we are going to be requiring while implementing abstract factory. Also, I will be taking an example in order to show you how it is actually going to be working throughout. Okay. So let's see the steps involved. So the first one, we are going to be creating interface. Or let me just take the example first, and accordingly we are going to be seeing the steps. Okay, so let us say I am going to be having one interface animal. Now this animal can have methods, like if we have some animal, we can actually be having a method where the first one is going to be telling you speak, where we can get to know if your animal, like how your animal is speaking. The second one is the type. For the animal, it could be something like if it is a land animal or if it is a water one. So that is how you are going to be discussing the type. So in order to expose the interface for the same, the step one is going to be create an interface. Okay. Now we will be looking into the step two. Like what is going to be the step two? In order to implement it, we are also going to be needing some of the concrete classes, right? So we are going to have certain concrete classes which are implementing the same interface. So we will say create concrete classes implementing the given interface. So like let us say based upon the categories, we have divided the different types of like or first let's discuss what the concrete class is going to be here. Okay, first let's discuss that part. Later on we will be just moving ahead. So let us say we are having we are going to be having the different types for the animal. So let us say first we are having a cat. So we are going to be having a cat class. So the type is cat here, and how cat speaks, let us say meow. Okay. Now the next one we are going to be having, let us say lion. Now how a lion speaks, it roars. Correct. Now let us say we are taking something like shark. So we have taken two land animals. Now I'm taking some water animals. So shark. So if you talk about shark, how a shark speaks? So we will say does not speak. Correct. Now let us say we are taking octopus. Sorry. So when we are having octopus, how octopus speaks? So let us say it actually makes some squawk noise. Okay. So it squawks. Now, if you will see what we are doing here, for the animal type, for the animal interface, we have went ahead and created 4 concrete classes. Okay. Now what we are going to be doing, we are going to create abstract class, and that abstract class is going to help you in getting the factories. Okay. So what is going to be our step 3? The step 3 is actually going to be creating the abstract class. So create abstract class. Now what this abstract class is going to do, this is going to get factories. Okay. So what we will be doing here, we are going to be creating an abstract class. Let us say we are creating something like animal factory class. Now inside this animal factory class, what we will be doing, we are going to create animal factory. So like, let us say we have a method create animal factory. Now what this create animal factory is going to be doing, this is based upon the factory type. So we have some factory types. So based upon factory types, what it will be doing, it is going to instantiate the factories. Like, we are we can actually say create based upon factory. So what we are going to be doing, we are going to be broadly creating 2 sub factories. Okay. So what we will be doing, we have step 3 already, right? So your step 4. So what we are going to be doing, we are going to be creating factory classes, and that factory classes are going to be extending the abstract factory. Okay, so create factory classes. In our case, like I told you, based upon the factory types. So I have taken two types of animals, right? One is your land animal. So for that, I'm going to be creating land animal factory. The other one is your sea animal. So for that, I'm going to be creating sea animal factory. And what these both factories are going to be doing? So they are going to be extending your abstract factory. So extending. Now, what is the abstract factory here? So just now we have used animal factory. So that is going to be the abstract factory, and these ones are going to be extending it out so that they can go ahead and create objects of the concrete class. So to create objects of concrete class, and how, like, based upon whatever uh, animal we are going to be picking, like, we are going to be providing some animal type, and based upon the animal type we are going to be returning the information based upon the animal type. Okay, now after this, what is going to be our step 5? The step 5 is going to be, like I said, here we are going to be we are having some client, and if we want to expose it to the client, like here we are going to be writing down the logic, but we are passing it there, how the client is able to access it. So what we are doing here, we are going to be creating factory producer class. And what this factory producer class is going to do, it is going to get factories based upon what information we are passing to them. Okay, now we are just going to be quickly seeing how it is going to get implemented. Okay, now we are going to be quickly looking into what the code we are going to be having for the abstract factory. So the first step, which I said we will be requiring for the abstract factory, is going to be creating an interface. So here we have created I interface, and here we have defined two methods. The first one is speak and the second one is type. So this is going to be actually telling what type of animal we have and how that animal is going to be speaking. Okay. Now after this, we have created the concrete classes. So like we have discussed, here we are going to be having 4 concrete classes. One, we are going to be having cat. Second one, we are going to be having lion. Third one, we are going to be having shark. Fourth one, we are going to be having octopus. So these are the 4 concrete classes which we are going to be using here, and all of these classes are going to be implementing this I animal interface. So here, when the cat is implementing the I animal interface, it is going to be providing implementation for all the methods. So when it will be about speak, so how a cat speaks, it does meow. How, what is the type of that cat? That is cat only, right? Now for the second concrete class, that is lion, we are going to see how a lion speaks. It roars. So here for the speak, we are returning roar. For the second one, which is the type. So what is the type? That is lion. Now next one, we are going to be doing it similarly for the shark. So here, how a shark speaks, it cannot speak, right? And what is the type for that? That is shark. After that, we are going to be looking into octopus concrete class. So here, octopus squawks. So after that, the next one which we have is the type. So for that, we are going to be returning the type as octopus. After that, what was the next step which I discussed? What we will have to do? We are going to be creating the animal factory. Okay, that animal factory, how it is going to be helpful for us? That factory is going to be providing the access to get all the other factories. Okay, So here we are going to be defining two types of other factories. The one is going to be related to the land. So that one is going to be land animal factory. The second one is going to be related to sea, and that one is going to be sea animal factory. So here what we are doing, if you will see in this animal factory, this is the abstract class. Here I am creating the abstract method get animal. This one we are going to be consuming in the both of those factories. So here what we are doing, we are creating a static method which is create animal factory. So based upon the factory type, we are going to be invoking the respective factories. So you can see factory of factories. The base is animal factory. Inside this we are having land and animal, land animal factory and sea animal factory. Okay. So if your factory type is sea, we are going to be returning sea animal factory. And if your type is land, we are going to be returning land animal factory. So that is how this abstract class is going to be get consumed. Now the next one, we are going to be creating the factory classes which are extending your abstract class, which is animal factory. And here we are going to be generating objects of the concrete class. We have four concrete classes: the cat, lion, shark, and the octopus. So these are the four concrete classes, and here we are going to be instantiating those concrete classes based upon the information. So here what is the information which we are passing here? That what is the animal type. If it is cat, we are going to be instantiating the cat class. If it is lion, we are going to be instantiating our lion class. The next one is sea animal factory. So what we are doing here, again, we are extending our abstract class which is animal factory. After that, based upon the animal type, if it is shark, we are instantiating your shark class. If it is octopus, we are instantiating octopus class. And lastly, what we are doing, we will have to create some factory generator. We are going to be having some factory producer class. And what this producer class is going to be doing, this one is going to be getting the factories based upon the information which we are passing to them. So if you will see here what we are doing, firstly, we are creating animal factory based upon the animal type. Based upon the factory type, this animal factory is going to get instantiated. After that, if you want to get animal, here you are going to be providing the animal type. And later on, if you want to retrieve the information, like if you want to retrieve the methods written there, you are just going to be doing animal.type, animal.speak. And I have actually taken the example for all of the animals. You can also go ahead and run this code so that you can understand how it is actually going to be working. Now, let's just quickly discuss what is the difference between your abstract factory and factory method. So, when you talk about abstract factory pattern, so what it does, like I'm saying from the beginning itself, it adds another layer of abstraction at the factory method pattern. So, you can consider we have different factory patterns which are getting uh, executed individually, and if you want all of them to get executed at one level, we are going to be using abstract factory pattern. But before executing, it is also going to be adding another layer of abstraction, and for that abstraction layer only, we are providing all of these things. Like at one place we are instantiating the animal factory, then we are instantiating the animal. Why? Because we are having extra layer of abstraction there. Okay. When you talk about abstract factory pattern, so in this one we can have multiple factory methods, and here what we are actually doing, we are grouping all of those factory methods together. So if you will see what is abstract factory, that is factory of factories. This is a super factory. I hope you have understood the abstract factory as well as the factory pattern. Now we are going to be meeting in the next class. Till then, happy learning. Bye bye. Hello class. So in this module, we are going to be learning about observer design pattern. So in this pattern, we are going to be talking about some asynchronous communication as well as synchronous communication. So let me first of all tell you what asynchronous communication is so that it will be all easy for you to connect all the dots. Okay. So synchronous communication. Now, what actually happens in a synchronous communication? Let us say we are having two person, a person one, and we have a person two. Now they both want to talk to each other. So in order to have the communication, they have the different modes. For the synchronous one, let us say they are talking to each other over the phone call. So if you have observed, whenever we talk to anyone over the phone call, how does it go? If you speak something, the other person is actually going to be listen to that, and vice versa, right? Like whenever two person are talking on the call, at that particular time, one person is talking, another one is listening. Sometimes they also interrupt each other, but that is how it generally happens, correct? So when you talk about the synchronous communication, here you are just talking and you are not doing anything else, correct? Like, generally what people prefer, they say that, hey, I prefer texting more because with texting I can go ahead and do other things as well, because in that situation they will have the flexibility of doing multitasking. But when you talk about phone call, so generally what happens, if you are talking, in that case you cannot do anything else, right? So if you are on a phone call, you are just talking and doing nothing else, correct? But if you talk about in this scenario, what is actually happening? We are having a synchronous communication. We are having a blocking communication. Why are we referring it as blocking communication? Because if one person is talking on the call, if two persons are talking on the call, then they both are just listening to each other. They both are just talking. They both are just sharing whatever they have. On the other side, they are not at all doing anything, although some people can do, but most of the times if we have something important, what we will do, okay, let's just listen to it, and at that particular time we are not doing anything else. Like if you are in office or anything, let us say you are doing your office work, in the middle of that, if you are getting a phone call, you will just move out of your seat, go outside, talk to that person, come back on your seat. That is how generally it happens, right? So in that case, what we are doing, we are blocking our work because we are on the phone call, correct? I hope it is making all sense. Like you don't have to bring those exceptions here that, okay, we can do multitasking, but I'm just talking about if we will have divided attention. Of course, in that case, that divided attention is going to be impacting somewhere, correct? You are not able to either, like I do a lot of times this thing, if I'm talking to someone, I will be doing something else, and as a result I don't pay attention to what the other person has said. So I'm just asking you to assume this scenario. Okay, now let's talk about async communication. So what happens in async communication, if we are having two person one, and let us say we have a person two. All right. Now, if they want to talk to each other, they can actually follow other mechanisms as well, other modes of communications as well. What can be the other ones? Just now I give you the example. They can send messages, or if you talk about the old times, they can also send letters. And with this, we will have the flexibility of non-blocking, because in this case, if one person, like, this is non-blocking communication, or you go ahead and call it as async communication. Why? Because we are doing other things in parallel. We are not just stopping and doing only that thing at a time. Example, even if you talk about texting, okay, if a person one is texting something, at that time person two is not blocked. Person two is just roaming around or doing whatever
the person 2 has to do. When person 2 will receive the message, that time person 1 is free, right? Because now person 1's task is to wait for the reply, correct? Meanwhile, person 2 is occupied, but person 1 is free. So if you will see, only one person is involved here, not both of them. So that is what we go ahead and refer as async communication. Okay. Now we will take another example here. Okay. So what happens, let us say this is a live class, okay, or something which is happening in person, something like that. So let us say this is me and I am taking a class, and these are all the students present in this class. So what is actually happening, if I want to start calling everyone for the class, like let us say I have joined the class and then I will call this person that, hey, come and join the class. And I'm saying that let's have a conference call, like I have some group of all the students in the class and I'm calling there. So everybody will just join that class, correct? But before that, they will join the call. So if you will see that conference call, if I'm performing such a thing, so what we are achieving here in this case, this is going to be your synchronous communication because I am blocking everyone, correct? And after that, if everybody is just sitting here, sitting in the real environment, so they all are just being there in that class, and they all are blocked. So if you guys are sitting in a class, if that class is of 2 hours, that particular time you cannot do anything else. Instead, like, you are just going to be sitting there listening to me, making the notes. That's all you can do there. But could be the another solution for that. So let us say this is me, and if we will just talk about the system design course scenario, so this is our system design course recordings. So if you have all the recordings, like I am recording it, so at particular time period, I am blocking my time because I am sitting here and recording these videos for you. But at the same time, you all guys are free. You all are doing your different respective works, correct? But tomorrow, when all of these lectures will go live, what will happen based upon the availability? You guys are going to come and watch the recordings. But all of those things, if you will see, that is non-blocking, correct? So this is called as non-blocking communication, or you can call it as async communication. All right. I hope I'm making sense. Yeah. So now, like, one more thing, like, if you talk about sending messages, what generally happen? Like, if either I'm sending a message or if I'm sending a letter, what generally happens? You are going to get some notification on your phone that this message has been received. After that, you will open. So basically, with the help of that notification, you are getting notified that you have received a message. Similarly, when you talk about letters, so there also what happened? Some postman is going to come to your house. He will ring the bell. You will get notified that bell, and you will come outside to collect the letter. Similarly, if you talk about this class setup scenario, so one thing which I can add here, maybe like, you talk about YouTube. So there, what you will see the option subscribe. And even if you talk about any of these teaching platforms, what these guys are doing, so they are enrolling these students, and based upon the students' interest, they are like, through their ID, they are just making them subscribe to their respective courses. Like somewhere like that system they have followed there. So as a result, what happens? If you talk about the system design course, like I said, if everybody's like, if I'm recording it at one place, so what will actually happen? Since here everybody has subscribed to my course, correct? So what will happen once I will create a class? In that case, everybody will get the notification for the same. So if you will see, since they are getting notification, they can just go ahead and they can open the video. Okay, so here if you will actually see, there are two ways of doing the same. One way is if you will keep on checking the notification, or you will be getting the notification from the website. The second one which we have is called as your push model and pull model. Like if you talk about the old days, like let's talk about previously, like long back, what used to happen, if you're getting some email, we used to log into our email, then only we used to see, okay, this and that mail has come, correct? That is how the old things used to work. But nowadays, with our mobile phones, what is the advantage? We are getting notification for each and every mail. So as a result, what happens, whenever we are getting a new mail, we are getting notified. So here, what was the first thing which I said? You are going and checking if a new video has come or not. So that is the traditional way. Now, what is the new approach for doing the same? What if I will provide this push and pull method for the notification? So what will happen? You do not have to waste your time in opening the YouTube, or this platform where the classes have been uploaded. You will get notified either by a mail or by a mobile notification, whatever ways we want to pick. And that way you will get to know that a video has been uploaded, and you will schedule the you will schedule when you want to go ahead and watch it. So that is how it is going to be there. All right. Now, if we talk about this pull method, so what is actually happening? All the students are going to come and they are going to be checking if some class schedule is there or not. So everything, they are just pulling all the data every morning. So if you guys remember about the Gmail, correct? So what used to happen there, these are some mails, and if you are dragging it down there, or if you will see that Outlook, so there also we have this clear word pull only. So what it will do, it is going to be syncing, it is going to be pulling. So we are going to be pulling all that data every morning. Other one is, if I am scheduling a class, I am sending a, I'm pushing a notification to everybody's phone. And with the help of that notification, what will happen? Everyone at that particular time, they are going to get a notification that I have a class. So if you will see, what is all of these things, whatever we have just discussed, that is your synchronous communication. And when you talk about observer design pattern, so exactly the same thing which we do there. Let me just draw it and explain it further. Okay. So let us say this is me. Okay. Now I have to go ahead and, let us say these are the different students. Student 1, student 2, student 3, student N. Okay. So we have different students, and let us say I have decided every day at 7 p.m. I am going to be uploading the video. Okay. So if you guys, if I'm talking about both of the models here. So if you want to see if a class has been uploaded or not, so what you will be doing, you are going to come and you are going to be asking for the class. Correct? That is how it is going to be happening. And if you will see what we are doing here, we are performing pull here. We are applying polling here. So basically what we are doing in this approach, we are just pulling the data. We are going and checking if a class has been scheduled or not. So that is what is happening. If it is there, let us say the student one has pulled the data, and if it is there, then from me the data will get pulled and the student will get to see the latest video. That is how it will be working, correct? The other approach is the pushing one, correct? So if I have decided at 7 p.m. I'm going to be pushing the new video. So what will happen? If it is 7 p.m., I'm just going to be sending it across. So here what I am doing, I am just pushing my data. Or what you can say, I'm just passing the information, whatever the data I have, all of that I'm going to be passing here. So you can see this is how it is going to be there. So like, you guys must have understood how it is actually going to be working in the observer design pattern. So when you talk about observer design pattern, so that is a most important design pattern, and basically we are going to be using it for all kinds of asynchronous communication. We are going to be using it in all kinds of messaging systems. So whether all the messaging systems you are going to be seeing in the market, you talk about Kafka, RabbitMQ, AMPQ, which is your advanced message queuing protocol. So all of these active messaging systems which are actually involving your non-blocking system. So they all are going to be using your observer design pattern in the implementation. So basically that is how it is going to be there. Yeah. So like, when you talk about observer design pattern, so here what we are going to be doing, I have taken already example. On the top of that, I'm just adding some more theory. Okay. So here, like the word is saying observer. So here you are going to be maintaining a list of observers. Okay. And these observers, you can also go ahead and call them as dependents. So you are like going to be maintaining a list of the dependents and observers. And whenever there is some state change, so what it will do, it notifies for state change by calling one of their method. So if you talk about this observer design pattern, so there we are going to be having one to many dependency. Like how it will happen, I'll take another example. You talk about Amazon. Here you are seeing some product P1, and it is going to be having some availability there, if this product is available in their inventory or not. Correct? So let's see that this product goes out of stock. So generally in such a scenario, what these platforms do, they will be giving you the option of entering the email, and they will say notify. So what happens, the moment this product again comes in the stock, you guys will be notified. Now it's not that only one person is going to be subscribing for that, correct? There could be many. So that is why for one product we are having many dependency, correct? So that is what we are going to be saying, and why I am saying whenever there will be a state change. So here what is the state change? Previously it was out of stock, so the moment it is going to become available, we are going to be notifying the user that hey, the product you were looking for is back in the stock, you can come to our website and place the order for that. So generally for that we have different kinds of modes. These applications, some applications even prefer sending it on their phones as a notification plus the email. So based upon the different platforms, they are going to be deciding how they are going to be updating their dependents, updating their observers accordingly. So you guys are actually the observers. So we have one product and many observers for that. Okay. Now, if you talk about how we are going to be implementing the same. So in this case, first of all, we are going to be having three actor classes here. Okay. What and all those are going to be there. So the first one is going to be the subject. The second one is going to be the observer. And the third one is going to be the client. Now, what does it mean? Like, I'll be actually taking an example so that you can understand all of those things. But basically, you understand because with the help of example, it will be able for you to connect the dots. But for now, you understand, if we want to implement observer design pattern, we are going to be needing three actor classes. Where if we talk about subject, so subject is an object which is having methods to attach and detach observers to a client object. Like I said, for a product, so this subject is actually going to be responsible for subscribing and unsubscribing. Like you will have the option, okay, what generally happens, so if a product is coming back in the stock, only for the first time you will get notified that this product is back in the stock. So you have, like after you have received the notification, they are going to be unsubscribing you. So that is what we call as attaching and detaching the observer, just how we perform subscribe and unsubscribe. So here we are also going to be like, this observer, this is going to be your abstract class. Okay, and this subject is actually going to be your concrete class, which is going to be extending the observer. So here we are going to be creating some of the methods for which we are going to be providing the implementation in the subject class. Okay, now what are the advantages of using observer design pattern? So like in this case, if you will see what it is doing, it is describing the coupling between your objects and the observer. It is also providing the support for broadcast type of communication. So whenever you are requiring that kind of communication, like I said, for the messaging, we are using it at all the places. Apart from that, also we are using it for the subscribe and unsubscribe. Okay, and like where we are actually going to be needing the observer design pattern. So whenever we involve state change in one class, so that must be reflected into the another object, and that particular time we will be trying that we are not keeping both of the objects tightly coupled. At the end, we want everything to be loosely coupled. Also, whenever, like when we can be making use of observer design pattern, so whenever the framework which we are using, the framework we are writing, that needs to be enhanced in the future, because we are always writing the future proof application. So if you want that in the future there could be some new enhancements where we are going to be involving new observers, like sometimes even if some application is there in future, if they are bringing some new features, so at that particular time also we are going to be notifying the user, like whenever any app is getting updates. So if you will see, although they are not pushing it, but they are notifying the users that these and all are the new updates. And certain applications, the moment you are going to open it up, they are going to tell that, okay, these and all are the new updates which we have made in our application. Okay, now let's quickly discuss one of the problem statement, and then we will be looking into the implementation for the same. Now, like I'll be continuing taking the same example. So this is me, and I will be conducting a class. And what these are the registered students. Okay. The moment I am going to be adding a new class, for all the new class, I want to send a notification. And this notification will be sent to all the registered users, students. Okay. So for this, how I'm going to be proceeding? I am going to be taking one interface. Let us say I session. Now inside this, what I will be doing, like I said, we are going to be needing 3 actor classes. So here, what we are going to do, the subscribe and unsubscribe part, all of those things, like the notification part, the moment you are like, what we are going to do in this, we are going to be providing the methods like, first let's add register. So if a child, if a student is getting registered at that particular time, this will get invoked. Similarly, there could be a possibility that after a while a student is withdrawing his registration. So if that is happening, so we are going to be needing unregister. Okay. After that, if I am adding a new class, I want to notify all the students, correct? So for that, I am going to be also needing a notify method. And after that, like let us say a student is actually asking some update from the class. Like we are still providing the option of pulling as well. Like, certain times, if let us say there is some festival, student can come and take the update that is it going to happen or not. Like we are having the two-way communication here, all right. So if we want to provide support for that, we are going to have this method get update. Yeah. So the I session interface are going to be having these methods. Now the next one which we will have is going to be your I observer student. In this interface, we are going to be having certain of the methods. So the first one is going to be the update method. What this update method is going to be doing, so we are going to update the students about any of the information. So if you want to do that, we are going to be calling this update method. The next which we have here is your set class. So in the set class, what we will do, we are going to be informing the students about the class that, okay, at this and that time, we are going to be having a class. The next one, we are going to be having get name method. So in the get name method, we are going to be returning the topic name, which we are going to be discussing. Like generally, before starting any of the class, we are going to be telling that this and that is going to get discussed here. Okay. Now, after this, we are going to be creating a concrete class that is going to be your batch subscriber class. And this batch subscriber is going to be implementing your iObserver student interface. So in this one, what we are going to be doing, we are going to be initializing and providing information for all the methods which we have given here. Now, after this, we will be having another concrete class that is going to be your batch class. This batch class is going to be implementing your iSession interface. Here, we are going to be providing information for all the methods which we have listed in the iSession interface. Okay. After that, we are going to be having, like, if you will see, we are already defined our concrete classes. And after this, we are also going to be having our main method through which we are like, this is actually your client code. This is something which is going to get exposed to your client, and with the help of this, the client is going to get notified. Okay. Now I'll just quickly show you the code for this. So now here, if you will see on the screen, we have added the code for that. Okay. And I have actually added code for two of the examples, and we are going to be discussing both of them one by one. Okay. Like we discussed, here we are having iSession. Okay. And in this one, if you will see, like I said, we are going to be having four methods: the register, unregister, notify student, and get update. I advise all of you that after the class, please take some time where you are just executing all of these programs and you are seeing the output yourself. Because of the time constraint, I'm not doing all of that here, but I'm showing you the working code. Okay. So in this one, I am passing the instance of the iObserver student interface. In the unregister, I am again passing the same. For the notify, since it is only have to go ahead and provide the information, only have to notify the student. So we are not taking any parameters here. For the get update, again, I'm taking the student because we should be knowing which, like, which student wants that update and all. Okay. Now, after that, we have iObserver student. Here, if you will see, we have update. So this update is going to be updating all the students about the class. After that, we have set class. So if you are planning to inform the students about the class, so this is what you are going to be using. And here we are taking instance of the iSession interface. That is because when we are going to be notifying the students about the class, we also need to provide them the instance of session because they should be knowing about the class. Similarly, here we have get name. So this one is going to tell the topic which we are going to be discussing. So since it just needs the information about the topic, we are not passing any of the parameter here. Okay. After that, we have a concrete class, which is the batch subscriber. Here, like I said, we are going to be implementing the iObserver student here. Inside this, I have taken two private members. The first one is the string. The second one is the instance of our interface. Here in the constructor, we are initializing the name. Then in the update, with the help of this get update method, we are passing the instance of this class. So this is what we are doing, like, this will take the instance, like, the get update is actually going to be getting the instance of the iSession interface, right? So that is what we are passing here. After that, we are like, since here we just have to provide a dummy code, so here I have just printed fetch the session plan of the class. After that, we have set class. So here we are just setting the session, and this is what is going to get passed. Okay. After that, we have get name. So whatever name we have, the topic name which we are initializing here, this is going to get returned. After that, we have batch class implementation, which is going to be implementing your iSession interface. So here, if you will see, we are taking list of observers. When I was discussing the observer design pattern, I said that here we are going to be taking a list of the observers here. So here, what are the observers? Students. So in that, like, we are going to be creating a list, and we are going to be notifying all the students one by one. And here we are also taking a variable for the study topic, because we are also going to be telling the topic which we are going to be discussing in that particular class. Okay. Now in the constructor, what we are doing, we are initializing our observers. We are taking an array list here. Why? Because if you remember the whole explanation, what I clearly said here, what we will be doing, we are going to be having two things here. First one is registering a student. The second one is unregistering a student. So when we are modifying the collection, so then we cannot go ahead and use array there, right? So that is the reason I am taking array list, because that is going to be giving us the flexibility of modifying the list. Okay. Now after this, we are implementing our register method, which is going to be like, providing the information when we are going to perform the registration. Like certain cases, when we register, we provide some of the information that, okay, the student got registered. So what we are doing here, we are simply just printing that, okay, registering student, we are printing the student name as well. And once we are registering, then in the observer list, we are adding this student as well. Similarly, for the unregistered, what we are doing, firstly, we are just printing, okay, we are unregistering this student. At the same time, we are also removing them from our observer list. After that, we have notify students, because with the help of this method, we are going to be notifying all our students about the class. So here, what we are doing, if you will see, since we have list of observers, okay, so what we are doing, we are running a for loop on all the students there, and for everyone we are sending the update. After that, we have get update. So with this, the student is going to get information about the session. The student is going to get all the information about the session details. Okay. So here what we will be doing, we are going to check if, like, if that, for that particular student, first we are going to check if that student is registered or not. If he is registered, then we are going to send the study topic. Otherwise, we are going to send null, because it should not happen that all the students available there, everyone is going to get notified. Correct? We are only going to be providing the information for that registered student. Then we have add study topic. So this one is going to be adding a list of the topics. It is going to be sharing the topic name with all the students across. So here what we are doing, we are taking a study topic as a parameter. And like, since it is a dummy one, what we will be doing, we are just going to be printing it out that, okay, we have added this topic. At the same time, we are calling our notify students. So that is going to be notifying all our registered students. Now we have our client code. So this is going to be the code which will be exposed to our client. So here what we are doing, initially we are going to be creating instance of our batch class, because that batch is going to be having, like, a, a institution can have different batches, and all the different batches are going to be having some set of students. Out of that, some are going to be registering for a course, some are not going to be registering. Correct? So here what we have done, we have initialized our batch class. After that, we have created instance of our students. And here basically what we are doing, we are creating list of observers. So for dummy purpose, I have created 5 observers here. After that, what I am doing, out of 5 students, what I have done, I have only registered 4 students. So in order to do that, I am calling the register here. After that, what I want to do, I want to assign a teacher for all of these students. So in order to do that, I am doing set class. So what I will be doing for all of these students, I am setting a class and I am going to also provide the batch information there. Later on, what we will be doing, I am just adding a topic there. I am telling that, okay, for this particular batch, we are going to be teaching observer pattern. So now if you will run it, the output which you will see on your screen, although we had 5 observers, but here in the output, you will be seeing only 4 observers got registered. After that, we have also added a study topic. So that also got printed here, right? And later on, what we have done for all of these students, we are also fetching the study plan. So when we were doing that here, this set class, so that is why here we are seeing this information fetched the study plan of the class. So that is how we are performing it in a classroom setup. Now we have another example for the same, which is related to the phone availability. Let us say you want to buy a phone and it is, let us say, listed on Amazon. For now, you may see, okay, the if you have seen on these websites, sometimes they will just mention like only 2 left in the stock, or sometimes you will be seeing out of the stock. And then they will be letting you have adding your email so that they will notify you once it is back in the stock. So although if you have seen your email is already registered on their platforms, still they are asking for your email. And why they are asking for it separately? That is because for the registering and unregistering for the notifications, only for that particular product. That is why they are asking for your email again. Okay. So here what I am doing, here first of all, I have taken I subject, like basically I have given those standard names only here. Inside this I have called 3 methods. I have declared 3 methods: register, unregister, and notify observer. Observers are going to be those people who want to buy that phone, who are waiting for that phone to become available. Now what we are doing here, we have defined our concrete class, which is implementing that interface. Inside that, what we are doing, we are creating list of our observers. So whenever a person is going to enter their email and clicking on the notify button, then here we are going to add them in this observer list. Okay. Later on, we are having 2 private methods, which is your product name with having the information about the product. The second one is the availability, which is going to tell if a product is available or not. Now in this constructor, what we are doing, we are initializing the availability as well as the product name. Then we have the get availability method. So whenever anyone is going to call this get availability, so this is going to be returning if it is available or not. Similarly, we have set availability. Like let us say they have now more phones in their inventory and they want to update the availability. So they are going to be calling this set availability so that they can let, they can update the availability of for the same. And once the availability gets updated, we are going to be notifying our users that it is back in the stock and you can proceed ahead by placing the order. Next, we have register, where we are just going to be registering our observers and unregistering. Then the notify is just going to be calling the update for all the observers available. Now, what we have done, the step 2 is creating our observer class. So for this, I have created iObserver, where I have taken update, which is going to be taking the availability, and the second one is get name. Then we are creating our concrete class observer, which is implementing the iObserver. There we are taking username, and in this constructor we are firstly setting the username, and after that we are calling the register. And in the update we are just printing this message like hello, let us say the username is ABC, hello ABC, product is now available. So this is what is going to get printed here. Then what we are going to be doing, we are going to be creating the client logic. So here what we will be doing for the phone, we are just initializing our class, and we are going to be telling that okay, for the mobile it is out of stock, for the TV it is out of stock. Like I have taken two items here, and for both of them I am providing that okay, these are out of stock. Now we have different observers. If you will see, out of these different observers, some users are subscribing for phone, some users are subscribing for TV, and there are certain users who are subscribing for both of them, because that can also be a possibility, correct? Now what we will be doing, we are simply going to be printing the phone's current state, if it is available or not. After that, what I am doing, like this one is simply going to be printing the current state which is out of stock. Then I am saying okay, you set the availability as available, like the phone is now available. After that, I am printing the TV's current state, and later on I am also setting the availability that it is now available. Okay, now let's clearly see the output, what is happening. Since I have added initially 5 observers for TV, for the mobile. So you can see we have 5 observers which got added for the mobile. After that, we have added 2 more for the TV, and these are the existing users only. So that is why 2 users got added for the TV. Then if you will see here, what we are doing, we are printing the phone's current state. So what is getting printed? Current state is out of stock. After that, what I am doing, I am setting the availability for that. I'm setting the availability for the phone. I'm not setting it for the TV right now. That is why it is saying availability changed from out of stock to available. Then we are notifying all our registered users, and that is how it will get notified to all the users that hello user 1, product is now available. And here you can also, like, instead of just product, you can also customize it by providing all the exact product name. After that, I have done the same, like, since we had 5 users who registered for that, so all the 5 users got notified. Then I am updating the TV's current state and setting it to available. I am changing the availability from out of stock to available, and then it is printing TV is now available, notifying all the users. So since only although we had 5 users, but only 2 registered for the TV, so only 2 got notified that product is now available. I hope with the help of these examples, it will be clear to you with how we are going to be proceeding with the observer design pattern, like when to use it and how to utilize it. The next one is strategy that we are going to be covering next, strategy design. Now with this word strategy, what is the one thing which is coming into your mind? That we are going to be following certain steps in order to achieve that. Like you are going to be planning what you need to be doing for that, correct? So like, the question is, when you are actually going to be using such kind of design pattern, like, this kind of design pattern is used when you have some problem statement, and for that problem statement, you have more than one solutions available. Like for this given problem, these are the different solutions available to you. Now this solution could be having some different steps. This solution could be having some different steps, this also and this also. But if you will see, what is the end result of all of these solutions? That they all are intending to solve the given problem, correct? These all solutions are using different strategies in order to solve the given problem. So that is how we are going to be consuming it. Like wherever we feel that okay, we have the need of, like, we have such a problem which can be solved in multiple ways, or we can apply different kind of strategies in order to solve it. So there we are going to be using strategy design pattern. And you know what actually happens? So every time you are going to be solving your problem, you are going to be having two parties for that. So one which you know, you go ahead and call it as client or the customer, correct? And what is going to be the end need for this client or customer? So they are going to be needing the solution for the problem, and the other party is going to be the developer. So what this team is going to be doing, like developers like you or me, so these ones are going to be providing the solution for that. Now what can happen, like let us say they are telling that, okay, design a login page. Now these developers, like we can have many developers even in the same organization, correct? Now, let us say I'm just giving this vague question. I want you to design a login page. I'm not giving you any specification about where I want the text box to be there or where I want a button to be there. Like, I'm not giving you any requirements. I'm just straight away saying I want you to design a login page. So each of these developers, since every developer is a different individual, so they are going to be having different approaches for doing the same. So although problem statement is one, but all of them are going to be designing it in different forms. This may be designing it with a blue background. This may be designing it with blue text. Anything can happen, correct? So for one problem here, everyone is going to be having a different solution. So strategy design pattern is that type of design pattern where you are the solution provider. You as the application developer, you are going to be providing the solutions. You can provide more than one solution to the client for the given problem. We are going to be like, when we are going to be providing the solution, we are also going to be using different kinds of strategies to solve the problem. Now it is in the hands of like hands of the client that which solution, which strategy they want to follow in order to solve the given problem. So typically these kinds of situations are solved by strategy design pattern, because you are providing multiple strategies for the same solution, correct? So like problem is one, but for that problem we are having multiple approaches, so different solutions are going to be there. Okay, so when we talk about strategy design pattern, so in this what is actually going to happen, we have one problem statement and we are following different strategies in order to solve that problem. Okay, let me just take you give you one example here. Like let us say this is you, and you are planning that, okay, I want to travel to some city. So travel is your problem. Like example, you want to travel to some XYZ city or country. Okay, so what you will be doing, you are going to go to some travel agency, let us say travel triangle. So what these guys do, example, you want to go to a destination, so you are going to go to travel triangle, and after that what they will be doing, they are going to provide the itinerary for that place. They are also going to be providing some different set of itineraries from which you can go ahead and choose. So if you will see, for the same city, for the same country, they are providing the different itineraries, where the changes could be like, you can be having more, like if it is a beach destination, it could be something like you are spending more time at the beach, or it could be something like relaxing, or it could be something like exploring the city. So these itineraries are going to be differing in providing you, although we are going to be covering the same destination, but we will be having different itineraries in order to cover it out. Okay, so that is how it is going to be there. So here you as a customer is the client for that company, correct? And you sent a request to them that I want to travel to this destination. So that is your request. And this travel agency, this is actually taking care of your request. So they are going to be providing you all of these itineraries, and later on you are going to be picking one among them. Okay, I hope it must be clear to you. In order to understand it better, let's take another example. Okay, so I'll be taking the example of scenario of the interviews, because that is what we are targeting, right? So let us say this is you. Now you are giving interview for some of the company. Okay, and this is the interviewer working in certain company, correct? So now what will actually happen in the interviews, we are going to be having this person who we call as interviewer, and then there is going to be you, which we can also call as interviewee, correct? Now what will happen, this person is going to ask you a question. Now, in order to for that question, in order to solve that question, there could be multiple approaches of doing the same. It depends upon you how you are solving it out, correct? So that is how it is going to be there. Let us say they are asking you a question. What you are doing, you will say that, even for a problem, we will have a brute force, we will also have optimized approach, and in order to even come up with that brute force, we will have various approaches. Let us say you are following one approach and you are providing them a brute force solution. After you provide that brute force solution, they can ask you that, okay, can you go ahead and optimize it further? So you can see that for the same problem, now they are expecting you to provide a different approach. Let us say they are saying optimize in time, correct? When you are providing that approach, they can ask you further more questions on the top of it. They can say that, okay, you have optimized it. Now, can you optimize space complexity as well? So you can see, although they have given you one question, but even in that question, they are asking you to optimize it further. And whenever you're going to be optimizing for same problem, you are providing a different set of solution for all of that, right? So, if you will observe what we are doing in this case for a given problem, we are providing various strategy, and any of these strategies, be it the brute force or be it optimized in terms of time or in terms of space. So any of these strategies can be used in order to solve the given problem, which has been asked in that interview. So if you will go and implement the same thing in the world of programming, that is what we go ahead and call it as strategy design pattern. Okay. Now let's take another example so that you will understand it even better, so that we can just make it more technical. So if you will go and see any of the uh, checkout page of the shopping cart. So most of the companies, like let us say we are talking about something like Amazon or Flipkart. Okay, so what will happen there, if you will see, what will happen after you're checking out your shopping cart, you will see we can have the summary of your order. Now the problem which we have, the problem statement which we have here is we want to make the payment for all of those items which are there in the shopping cart. Now how you are going to be making a payment for that in order to place the order? So for that we will have some various options, right? So but and all could be like they are going to be providing the various payment gateways. So it could be like you can pay through credit card, you can pay through debit card, you can pay through net banking, you can pay through wallets. So all of these are already all of these options which you are going to be seeing on the payment option, correct? So these are all the different solutions for our given problem. And what was the problem? That we want to make payment for our order. So have you ever thought about how it must have been implemented initially? They must be using strategy design pattern here. Now let us just take the problem statement which we will be implementing. So I need to design the payment gateway for the customer in the Amazon checkout page. So if the interviewer is asking you to design the payment gateway, so you should know what the first question is going to be there. So you should be asking them that what and all are the payment options which you want to offer to the customers. In the system design round, you should not be assuming anything. Like here, although I have shown you what and all options are there, but if I want to implement the same in any of the company, or if I'm doing the same in any of the interview, I am not going to be assuming all the payment options. I must be asking them that what and all options do you want to offer to your customers. So I am going to be asking them, like, even in the wallets, what and all wallets do you want to provide? Maybe they will say, okay, I want to add support for Google Pay. They can provide the option of phone pay. They can also provide option of cash on delivery. So all of these options are going to be there. Now let us say how initially it must have been there. So initially for the checkout, maybe they have only implemented the cash on delivery. because in that case, they do not actually have to involve any payment gateway. All they will be doing is collecting the payment at the time of delivery of the product. Now, let us say once they are growing in their growing the application, let us say they want to add the support for credit card or debit card. Now, what will happen after they will add this? We should be knowing that we also have to follow open close principle. What does that mean? It means it should be open for extension but closed for code modification. So when we will be adding extra support for the credit cards and debit card, we should be knowing that we are not going to be touching the existing code. Rather, we are going to be adding that one here. Correct? Also, you must be seeing that one more scenario which can happen. Like let us say initially we just had Amazon, where we were making payments for the products which we are doing there. Later on, you know what they have done. They have also introduced Amazon Prime. Now, from the Amazon, you can go ahead and place order for the products which you have. Also, you can go ahead and buy the Prime membership. So when you will be doing either of the things, this was the extension. Prime was not initially there. You have added it later on. But if you will see, when we have added the support for that, we also need to follow open close principle here as well, where both of these are actually going to further go to your payment gateway, right? So that payment gateway is going to be same. It's just we need to provide additional support for that. So whenever you are designing any of your product, where initially you do not know how the future of that product is going to be there, because every product is going to be futuristic. Nobody in the Amazon thought that any later on they are going to be coming up with something like Amazon Prime or something like that. Correct? So all of those are the futuristic products. Like back then when they started it, they had no idea about what and all are going to be there, but they made themselves future proof. And we can say this Amazon Prime or other products by Amazon. So all of these are the extensible products. Initially it was just an application. Later on they came up with different products, they have extended them. So whenever we will be having such a requirement where in future we are going to be adding support either in the terms of payment or in the terms of the products, so if we will have such a scenario, so what I will be doing, I am going to be making use of the strategy design pattern. Even if you will see for the payment, let us say for the two wallets I have provided support for now. Tomorrow if I want to add support even for Paytm, so there also I will be just adding a new wallet support. So if we will have such a thing, if we want to add one more solution for our problem, the problem is to add the payment option. So in such a case, we are going to be using strategy design pattern. And at the same time, we are also going to be keeping our open close principle in our mind. So that is how it is going to be there. Now we are just quickly going to be discussing what and all are the benefits of using strategy design pattern. Also, we are going to be discussing what are the usages for the same. So when you talk about strategy design pattern, so what we are doing here, so it is defining each behavior in its own class, and that is eliminating the need for conditional statement. What do I mean by that? When I talk about payment gateway, so if I want to have different payment gateways, so instead of adding it into one class where I'm adding some nested conditions, some if else condition or something like that, so that is going to make our code tightly coupled. Instead, what we can do, we can define each of these behaviors in a different class, and hence we are also going to be eliminating that complexity, because everything is going to be following a open close principle. At the same time, we will be making things lightly coupled, that if we want to modify it later, it will be easier for us, because in such a case we are only going to be touching that particular class. We are not going to be touching the entire code. Also, when you talk about strategy design patterns, so since I am saying I'm going to be keeping everything separate, so this makes it easier for us to extend and incorporate new behavior without changing the application, because everything is going to get added separately. So in future, if I want to add some new things. So we do not have to add it at one place. We're not going to be touching our core concept. Instead, what we will be doing, we're just going to be adding support for that separately. Now, when we should be using it, whenever we will have multiple classes and they all differ in their behavior. Like one payment gateway was credit card, another was debit card, another was net banking. If you will see, all of these, they are different in their behavior. In terms of credit cards and debit cards, you are going to be entering the card information. On the other side, for net banking, you will be selecting your bank and you will be logging into your banking portal. That is how you are going to be approving that payment. Correct? So all of these are the different behaviors. And here you this one you are going to be needing when you know that for your given problem, you are going to be having different variations in the terms of solutions. So when you have such a thing, it is a wise decision to go ahead and use strategy design pattern. Now I'll just quickly show you the code for this. Okay, and I'm going to be showing you the code for this payment gateway for the Amazon only. Okay. So what is going to be my step one here? The step one is going to be creating an interface. So since here we are talking about the strategy I will be using for the wallet. So here what we will be having, we are going to be exposing a method which will be initiating the payment. So here if you will see, we are talking about pay and there we are passing the amount that in order to make the payment, this is what you will have to pay so that you can buy the product. The next one which we have here is your concrete class. So we have created a concrete class, like in order to make the payment we are going to be using different payment gateways, right? So let us say one among them is your Google Pay. So I'll be creating a concrete class for the Google Pay where if I have to pay, we are going to be writing down the logic how it will get directed to your Google Pay from where you can go ahead and complete the transaction. Similarly, let us say I even want to add the support for phone pay. So what I can do, I can go ahead and create another concrete class which is going to be implementing your interface, and here we will be just writing down the logic. Here, in order to just keep it a dummy project, I am writing only the print statement, but in the actual code, you are going to be writing down the exact logic which you will be needing there. Okay. Now, after this, we are going to be creating a context class. So here, for like, what is the context here? We have to buy a product. So that is our context. We want to make the payment for the same. So what we will be doing here, we are going to be taking the two variables. The first one is going to be the product name and the second one is going to be the product price. Now inside the constructor, we are going to be initializing the product name and the product price. Later on, we are having get product name. Like, later on, it can happen that you just want to get a product name. So that is where this get product name is going to come. And let us say you are adding a product. So for that, you want to set a name. So that is where this set product name is going to come into the picture. After that, we have get product price. So we will have some get and set for the prices as well, where we are going to be setting the price for our given product. After this, we have another concrete class, which is your Amazon cart. So here what we have done, we have taken our product. We have also taken the instance of your wallet strategy. And here what we are doing, firstly, inside this constructor, we are initializing your product and wallet strategy. Later on, we are defining our pay. Through this, we are actually calling our pay to get the product price. So that is how the logic is going to be there. After this, we are going to be writing the context where we are going to be where we are going to be writing our client code, which is going to get exposed to our client. So here, if you will be seeing what we are doing. So if you are having any of the product, for that, I am setting a product name and I am also setting a product price. So here for a phone, I am setting a price here. After that, if I want to make the payment, what I am doing here, what we are doing, in order to make the payment, I am selecting Google Pay. If it was Phone Pay, I would be calling that logic here. But here I want to pay through Google Pay because no matter how many payment gateways you are going to be providing, only one we are going to be using in order to complete the payment. So here I'm using Google Pay. The moment we are using it, what we are doing, we are calling the pay. So what it will be doing here, it will go to this class. And when we are doing pay, so this one is going to get called where we are going to be passing our amount. So if you will see what is happening here, the moment we are calling the pay, so what will happen, it is going to take this amount, the product amount, and later on it will print a message that paying by Google Pay and this is our amount. I'll also show you one more example so that, like, that is something which you can implement it in your free time so that you can understand it better, because strategy design pattern is something which is commonly asked in most of the interviews, so you should be well versed with how you can go ahead and implement it. So I'll just show you the problem statement. I'll draw it down for you. In your free time, just go ahead and try. Now I'm just going to be explaining you another problem statement. So let us say we have a client. Okay, and this client is going to be having a problem. So this one is going to be asking you to design a calculator. Now, initially, let us say, like I said, initially we do not go ahead and implement everything. But instead, what happens for that calculator, let us say this client said that, okay, you provide me three supports. You provide me addition support, you provide me subtraction support, and you provide me multiplication support. Tomorrow, let us say this person is coming and he is saying that now even I want two more supports. He is saying that I want some division support and I want to even calculate exponential. So if you will see, my initial implementation is only going to be having these ones. And what is my major problem here? I want to perform some calculated operations, correct? But in order to perform all of those operations, I am going to be using different kinds of strategy. And these are actually going to be telling us what and all strategy I want to use here. If you will see, this is clearly open close principle, like following open close principle. Like previously we just had these operations, now I am adding more. So please go ahead and try these out. Now we will be meeting in the next class. Till then, happy learning. Bye bye. Now in this module, we are going to see what a web crawler is, and if you will have to design web crawler, then how you are going to be doing that. Okay. So when you talk about web crawler, as the name is saying, crawling, what does it mean? It is going to go from one place to another. So when you talk about web crawler, so that is that type of a software which we use when we will have to browse the internet and we want to collect all the data from all of those websites automatically. Now, what is the main purpose of the web crawler is? That is to visit the websites and then download all the data from all the websites on the internet. Like let us say we are on our website 1. Now from there it can be having link for the other websites, some website 2, website 3, website 2 can have another website link and so on. So what the web crawler is going to be doing, it is going to go from one place to the another and it is going to be collecting all the data. So that is how a web crawler is typically going to be working. Now we will see like how a web crawler is going to be working. So like, if you will talk about any of the website, okay, like let's just take the example of Microsoft.com. Now let us say I am at this website and I want to start crawling. So what I will be doing, firstly, I am going to be visiting a specific website. In this case, I am visiting this website. Now what it will be doing, it will be downloading all the content. So it will download all the content from here, right? So on this website, what it will be doing, it will see what and all other links are there. So this website can be having link to the other websites such as your LinkedIn. It will also have the link for your Google. It can also have link to your Wikipedia. So all of those links are also going to be there. So what web crawler is going to do from Microsoft, it will first download all its data. From here, it will first go to LinkedIn. It will download all the data. Then it will go to Google. It will download all the data. Then it will go to Wikipedia. It will download all the content. And if after this, if we have something else, so it is going to be downloading all of that data as well. So this process is actually like, if you guys remember, some time back we had that coronavirus. So what that was actually doing, so initially one person was having that, correct? From one person it got infected to other persons. Like this person infected 3 person, from 3 it got spreaded even more. So that is how that virus got spread all everywhere, correct? So you can actually link the web crawler with this example for your better understanding. Okay, so similarly, like, when you talk about web crawler, so what we do in this one, we are going to be initially having one URL. From that URL we are going to go to the different URLs, and from there we are further going to go to the different URLs available to us. So that is how typically a web crawler is going to be working. So this is what the major purpose of web crawler is, and that is how it is going to be collecting data from different websites. Now we will see why web crawler are important. Like, we understood what it does, but this is also going to be a question that why they are even important. So if you talk about companies like Google, so what they do, they use web crawler so that they can download and organize data from the internet. So this is going to be helping them so that they can build a searchable index of all the websites, so that if you want to search for something, like let us say on the Google you are writing something like Apple, you must have seen the moment we write something and we press enter, what it does, it will be quickly showing you all the results related to that. All of those things happens within fraction of seconds. And how Google was even able to build that, so in their search engine what they have done, they have used web crawlers so that they can collect the data from all over the internet, and later on they are indexing them so that whenever we are going to be searching something, it will be very easy. It can provide you results in the less amount of time, but at the same time, if you will see, they have saved a lot of amount of data in their uh, servers, correct? Now, what is the goal of web crawler? So when you talk about web crawler, so its major goal is visiting different websites, as many websites as possible, and download their content. So now we will just be discussing how a web crawler is working, how Google is using them, and how the resources, like, what and all are the resources which we need so that we can save that much amount of data, like a vast amount of data. Okay, so like let us say I am giving you a task. You as a user is having a task that you will be going and download all the data. Like, we will be like I'm asking you that download all data from internet. So this is your task. Now in this particular one, what we will be doing, Google is going to be like, Google is actually using this web crawler thing only so that it can go ahead and perform this. Like what Google does, like basically it crawl all the websites, collect their data, and save it there. Okay, and exactly the same task I'm giving it to you. So like, have you ever thought, like, the moment we just do enter on Google, how we are able to even see a lot of search results, that too so quickly. Like, if you have used database, so you must have seen when we have less amount of entries and then we try to retrieve some of the information, it is quicker. But the moment we add more data to our database, eventually the the queries are taking longer time. But if you will see, Google is storing huge amount of data, but still it is able to deliver all of the search results in a fraction of second time. So have you ever thought how the Google is even able to provide search results to you so quickly from such a vast amount of data? So Google has actually perform this web crawling so that it can visit the different websites, download their content, and organize them into a indexed database. Now, whatever the downloaded data they have, they are further indexing them so that they can allow users to search from their information quickly. So this process is ensuring that Google can provide results in fraction of second, even from a massive data set. Now, you have understood what the problem statement is. Now, your next requirement is how, like, you need to even determine, when I was initially telling you what and all decisions you need to take here, you also need to determine what amount of storage you are going to be using, how you are going to be computing all that data. For this purpose, what and all you are going to be doing. Okay. Yeah. So now you will first thing which is there is, if you want to download all the data from the internet, you should be knowing how many websites do you have. So how many websites are there in this world? So the number is approximately 2 billion, correct? Now, with these many websites, if you will see, a quick Google search will show you results which are close to 2 billion, correct? Because from all of those websites only, it is searching and providing you the results. So this number is expected to grow over the period of time, because if you will see, with the advancements, with everyday arising needs and the requirements, if you will see, the websites are something which are increasing every day. So if today we have 2 billion websites, tomorrow we may have more than that. Okay. Now, if you talk about any of the websites, so these websites are going to vary in size. Some are going to be a single page websites. Some are going to be like Wikipedia, where we will have thousands of pages, and many will have some few pages, like 2 or 3 pages. Now, let us assume that total average number of pages, average number of pages per website, let us say it is 100. Okay. Now, if you will see, how many pages are we actually covering? So we have 2 billion websites, and every website is having 100 pages. So total we are going to be having 200 billion pages, correct? That is what we are going to be having. Now let's assume the average size of each page. Average size of each page is, let us say, 100 KB. Okay. Now what will happen? We will have to see what is the total size of the content. So if you will be seeing, total we have 200 billion pages, correct? And every page is of 100 KB. So this is going to be the total size of the content, right? You can also go ahead and write it something like 2 into 10 power 4 billion pages, or like, since we are talking about memory, let's talk about KB. So this is the total size which we are going to be having. Now, since it is in KB, let's convert it into bytes. So we will be having 10 power 3 bytes, correct? Now, so total, the total size of the content, how much we are going to be having? So that is going to be 2 into 10 power 7 bytes. So this is going to be the total size of the content which we have. Now, when you talk about 2 billion bytes, so what is that? So that is somewhere like now we are just calculating it. So if you talk about 1 gigabyte, so how many bytes you are going to be having in gigabytes? So that is going to be 10 power 9. Right? Now, if you are going to see, we initially had this 2 billion into 10 power 7 bytes, correct? So let me just, one second. So what we will be doing, let's just convert this even from billion. So if you are just going to be removing this billion, so this is going to be something like 10 power 9 into 10 power 7 bytes, correct? Because 2 billion bytes are equivalent to 2 into 10 power 9. And this is something which we are using directly here. Now, if we talk about 1 GB, so that is going to be having 10 power 9 bytes. So if we are going to be further dividing it down, so how it will be there? So this will become 2 into 10 power 9 into 10 power 7 divide by 10 power 9, and then from bytes we have now converted into GB. So if you will see here, we are having 2 into 10 power 7 GB. Now, if you want to further divide it into TB, so how you will be able to do that? 2 into, since 1 TB is going to be equivalent to 10 power 4, correct? Sorry, 10 power 3, 1024, right? I'm just using some rough values here, okay? Approximated. So if you have this, so this will get converted into 2 into 10 power 4 TB. So this is the data. Now if I want to further convert it into petabytes, so petabytes. So how I will be doing it? 2 into 10 power 4 divided by 10 power 3. So if you will see, this will be becoming something like this. So we have 20 petabytes data. So you can see from 2 billion websites, this is the total amount of storage which we will be requiring in order to save all our data. So if we are having machines, so if each machine can store 1 TB of data, like, if we have a machine storage, let us say it is 1 TB, like that is again pretty much high only. But if if one machine can store 1 TB of data, so how many total machines we will be needing? So that is going to be 20 petabytes divided by 1 TB. So roughly we are going to be using 20,000 machines. So that is like, we are going to be needing so many websites in order to store all the data which is available all over the internet. So if you will see, if we want to collect all the data, how much total data we will be having, that is going to be approximately equal to 20 petabytes. And how many machines we are going to be using? Approximately 20,000 machines having storage of 1 TB each. So that is going to be the total amount of storage which we will be requiring if we will try to web crawl all the website data. So now you have seen that in order, like, if Google is storing all that data, so they need some massive infrastructure in order to store that amount of data from all over the internet. So with this setup, only Google can deliver such results at the lightning of speed. Now, like, we have actually taken care of three things here. We have done requirement gathering. What was our requirements? That was to collect the data from all across the internet. The second one is scoping, where we are dividing the entire task into smaller tasks. The third step which we have taken care is estimating the data size. And here three things which we are taking care. So the first one is the storage, how much storage you are going to be needing for storing the entire data. Now after storage you are going to be further performing some of the computation, and later on you will be needing some network so that all the devices can interact with each other. So these things which you are going to be requiring. So now once this is done, the next step is going to be breaking the entire system into smaller components. So this approach is actually inspired by a real life scenario. So let us say you are actually hosting a party. Okay. Now, if you are the host and if you want to have a party, for that you will be like, if let us say you are some 3 or 4 members of family. So now what you are going to be doing, you are going to be splitting the work among everyone in that family. So what you will be doing, to one person you are going to be assigning a task. Like let us say you will say, okay, you go and you welcome the guests. To the other one, you are going to say that you go ahead and you take care of the food. To the third one, you will say that you go ahead and take care of what gifts to give it to them. And to the last one, you will say that you take care about the comfort, that everyone feels comfortable there. So let us say this is how you have split it up. So instead of you single-handedly taking care of all the things, what you are doing, you are assigning specific tasks to each of the functions. So by dividing the work, everyone knows what their responsibilities are, and they know that whatever task they have, they can carry it out in a streamlined and efficient manner. So this is the same principle which when we apply to a bigger system. So instead of solving the entire problem in one go, what we can do, we can break it down into smaller components. And how that is going to be helpful? It is going to be helping us in order to organize and manage the process effectively. So similarly, when we build a large project, instead of creating one big monolithic application, if we try to break it into smaller manageable components, then it becomes easy for us. Okay, let's take the example of Amazon. So when you talk about Amazon, let us say you're working on a feature which allows user to buy an item. So this is your task. So instead of writing down code in single massive application, what you can do, you can split the functionality of that into smaller services. Each one is going to be handling specific part of the process. Like here, you can create one placeholder cart. What this cart is going to be doing, this cart service is going to be managing the user's cart and all of relate like and all other related information there. The next one is going to be the checkout service. What this checkout service is going to be doing, this one is going to be managing the payment, and here we are also going to be taking care of the purchase process. We will be handling the checkout process here. The next one is going to be inventory service. So what inventory service has to do? This one is going to be keeping a track of all the available items. The next one is authentication service. So you will also have to ensure that the user is logged in and has the proper credentials. Then only it will be possible for you to have all the information related to that person stored. The next one is going to be the payment service. And this payment service is going to be taking care of all the payment transactions. The next one is going to be the shipping service. So once you have placed the order, the next one is going to be ensuring that you are processing the shipping and you have all the delivery related details handy for you. So by dividing all the system into in these smaller and focused applications, you can easily manage development process more effectively. You can make your approach, you can make your system more scalable, and you can even simplify the maintenance. Like you will not be like if you are just making some changes at the cart level, you are only going to be modifying that code. You are not going to be touching the entire code base. So this modular approach ensures that each part of the system can work independently, and still they are even though we have this big application, all or even though we have broken it down into smaller ones, but they all are actually contributing to this big project only, this big functionality. Now we will be seeing how, like if we want to buy anything, how that buying process works. So what will happen, if you want to buy an item, so if a user wants to buy an item, this process is actually involving several smaller components which are working together, each with a different responsibility. So what is the first one is going to be doing, let us say you want to buy a product. So once you have finalized that this is what I want to buy, the first thing which you will do is adding to the cart. So here what will happen, user is going to be adding that product to their cart, and who is going to take care of this? Here I have already specified different services we are going to be using here. So out of this we are going to be using your cart service. Now the next one is going to be initiating checkout. After you have added it, the next one is going to be checkout. For checkout, what we are going to be using, we have checkout service. So after taking care, like, what will happen? This card service is actually going to be communicating with the checkout service so that it can go ahead and start the payment and the buying process. So here we will go ahead and call the checkout service. Now, after this, what is going to be the next one? If you want to buy something, we always need to go ahead and go to the authentication. Like if you want to buy some item, they will ask you that either you buy it as a guest, or if you have credentials, go ahead and log in. So the next one is going to be the authentication. For authentication, we have this authentication service. So what will happen? This checkout service is going to be like going to be calling this authentication service, that first you authenticate and then you proceed ahead with buying your item. And this one is also going to be verifying the user identity, and this will ensure that the customer is valid and they have some valid credentials. Yeah. Now after this, what we will be doing before proceeding the checkout, we will be going and checking the inventory. Because if some item is available, like sometimes you must have seen, even if some item is there in your cart, but by the time you go ahead and buy it, it will show that now the item is out of stock. So adding an item to your cart doesn't guarantee that you will be able to buy it. It all depends upon the inventory. And in order to perform the inventory check, here if you will see, we have one associated service, that is your inventory service. So this one is going to call your inventory service. This one is going to check that if item is available or not. If item is not available, it will just let the person know that it is out of the stock. Once it is available, then only you will be directed to the payment process. So then we will be processing the payment. In order to process the payment, we have one associated service, that is the payment service. So what will happen? The checkout service is going to be communicating with the payment service so that we can handle the payment. If the payment is successful, then the process will move to the next step. And what is the next step? The next is going to be shipping part. So when you talk about shipping your order, so here, what associated service do we have? So for that, we have some shipping service available. So here we are going to be using shipping service. So finally, your checkout service is going to be calling the shipping service to arrange the shipment and delivery of the order. Now, if you will see, what are we actually achieving here? Although we have written down all the services and all, but what is the thing which we are achieving here? So you can see we had a single problem statement, that is to buy an item. We were just doing that task, but what we have done, we have broken down the entire task into smaller and manageable components. And each of these services is actually focusing upon a specific task. And later on, all of these services are communicating with each other to complete the process. And what actually happens when we perform it in this way? We make our system more organized, more scalable, more maintainable. So by breaking down the problem and defining the clear interaction between the components, the overall functionality becomes more streamlined and efficient. So when you actually so far but and all we have done, we have gathered the requirements, we have done the scoping, we have also done the estimation, and we when we are doing this estimation, at that time we are performing this planning, and this planning is going to be breaking it down that what and all service we are going to be needing so that we can achieve our target. So when we build any of the large projects, so instead of creating one big application, we try to break it down into smaller components. Okay. So when you are working on some feature like buying an item, so at that particular time, instead of writing all of that code in one place, what we do, we try to break it down. And how we do, these are the different services which we are going to be using here: the cart service, checkout service, inventory service, authentication, shipping. All of these things are going to be taking care of different responsibility. Your cart service is going to be taking care of all the cart related information like adding or removing items from the user cart. The checkout service is going to be managing the checkout process, where we are going to be summarizing your order. We are also going to be confirming your purchase details. Your inventory service is going to be taking care of availability of the item and what the stock levels are there. Sometimes they will also be telling that okay, only 2 items are available in the stock. Like all of those things are taken care by the inventory service. Then we have authentication service, which is going to be verifying the user's identity. If it is a if we are entering the correct credentials only, it will let us proceed ahead with the purchase. After that, we have payment service, which will be processing the payment securely, and this will also confirm the transaction status. Then we have shipping service. So this one is going to be taking care of the order shipment, and it will also be taking care of the delivery to the customer. So by dividing the system into smaller components, each service can focus on a specific task. These services can later on interact with each other so that we can complete the delivery operation. Now, what is the benefits of this approach? It makes our system scalable. So individual services are there which are scaled individually, independently. We are not if later on if we want to make changes at one level, we can just do it individually. It's not tightly coupled, it is loosely coupled. Next is maintainability. So if you want to debug and perform any of the updates, so all of those things are easy because every service is isolated. There is zero dependency on each other. Next one is flexibility. So here developers can work on different service. We will have different teammates and we can just assign each and all responsibilities separately. Like one individual can work on one service, and that way there will be zero conflicts. They all can work down separately. So by breaking it down into smaller and interconnected solution, we can simplify our project management, and we can also ensure the delivery of this feature correctly. Okay. Now we will quickly see that for buying an item, how all these services are communicating with each other. Although I have told you verbally, but with the help of a diagram, we will see how the communication is going to get made. Okay. So for the Amazon, like what our task was there, that user should be allowed to buy an item. So that is our task. So for this, what and all services we are going to be having, we are going to be having a card service. The other one, we are going to be having checkout service. Next one, we are going to be having authentication service. Next, we are going to be having inventory service. When we need payment service. And we are also going to be needing something called as shipment service. So these are going to be the different services which are going to get involved if a user wants to buy an item. So if we have a user here and this user wants to buy an item, so these are going to be the different services involved. So how this entire buying process is going to be working. So this one is the user. So what will happen when the user wants to buy an item? The process starts with adding an item to the cart. So for that, we are going to be making use of our cart service. So firstly, the user is going to use the cart service. This cart service is going to be responsible for taking care of the task of adding an item to the cart. So this one is going to let the user add items to their cart and also manage the cart's contents, like what and all items are there, how many quantity we are adding there. So all of those are going to get add there. After adding the items there, the next one, like this cart service, is going to be calling your checkout service. And this checkout service is actually going to be taking care of all the checkout process. This will be taking care of the payment, and this is also going to be helping you to proceed ahead with buying this item. Now, after this, what will happen? This checkout service is going to call the authentication service. So it will go to the authentication service and it is going to be verifying the user. It is going to be authenticating the user. If, like, if we are having a successful authentication, if the user is entering the correct credentials, so what will happen? This authentication service is going to reply back to the checkout that yes, I have authenticated this user, this has a valid credentials, and after this you can move ahead. So once this is done, once the authentication service approves the user, then it will come back to the checkout service, and after that checkout service will perform the final check to ensure if the item is available or not. So in order to perform that, checkout service is going to be calling the inventory service. This is going to be confirming whether the item is there in the stock or not. Now, once the inventory service is confirming that the item is available, then what will happen? It will reply back to the checkout service that yes, the item is available, you can proceed ahead, and this will let the user to complete the process. So after this, the checkout service is going to be calling the payment service. So after this, we will come to the payment service. In this, we are going to be processing the payment for the given item. If the payment is successful, then it will be calling the, it will reply back to the checkout that yes, the payment is successful. Then it will call the shipment service that okay, now we should proceed ahead with initiating the shipment process, and this will also be taking care of the delivery of the item. So what we are doing here, if you will clearly see, we had a single problem statement that was allowing the users to buy the item. So what we have done, instead of doing everything in one go, we have broken it down into different components, and this process is also like giving a clear uh, design layout that how this task is actually going to get performed. So what we have done here, we have clearly broken down the everything into this format. So, if you will see, whenever you talk about any of the theories which you have already covered as a part of your curriculum, so there they will be telling you what and all are the different steps which are involved whenever you are designing any of the system. Now, I'll just quickly tell you how does it even happen here. Okay. So, when you talk about system design. So you know what and all are the two components which are involved here. The one is your low level design and the other one is your high level design. Also, what and all are the different steps which are going to get performed here. Yeah, now what and all are the steps which are involved here while designing any of the system. So the first one is going to be the requirement gathering. Once you have gathered the requirements, the next one is going to be the scoping, where you define the timelines about when you are going to be delivering which component, when you are going to be performing the testing for that. So all of those things are like, how you are going to be scoping down your work. So all of that is going to be coming here. After this, the next step is going to be estimation. So this estimation is going to be performing three things here. It is going to be calculating the data size because you are going to be storing it out. So first one is storage. The second one is compute. The third one is network. So all of those things are going to be coming here. After this, you are going to be discussing the components. Like here we have discussed what and all services we are going to be requiring. So after this, the next one is going to be the components. Then once we have finalized the components, then we step into the implementation. So you have seen we have followed 4 steps and so far we haven't done any implementation yet. Once you have finalized your components, you will go ahead and start the implementation. Once you have implemented your code, the next one is going to be the testing process. You are going to be sharing your code with the testing team that you go ahead and test it out if it works correctly or not. If there are going to be certain bugs, we are going to be addressing them. Otherwise, we will be moving to our next step. And what the next step is, that is going to be your deployment. So if you will see, these are the different steps which are going to get involved here. And now, since I said in the system design, we are having 2 levels of designing. So how we actually break it down? So these initial 4 steps, where you are gathering the requirements, where you are scoping it out, where you are performing the estimation, where you are determining the components. So all of those things are a part of your high level designing. And if you will look at the remaining steps where you are implementing it, where you are testing it, where you are deploying it, so all of those things are going to be coming as a part of your low level designing. So this is how it is going to be there. That is why when we talk about low level designing, here we generally talk about design principles and design patterns. On the other side, when we will be discussing about high level designing, there we are going to be talking about how we can scale our system, how we can make the performance better, how we can perform the partitioning and other things. So that is how it is going to be there. So that's all I had for this module. Now we are going to be meeting in the next module. Till then, happy learning. Bye bye. Hello everyone. In this module, we are going to be discussing interview preparedness. Like if you have any system design round, how you are going to be prepared for that. So, first of all, we should be understanding that what happens in a low level system design interview. So first of all, you should be understanding that this is not going to be the first round of the interview in any of the company. Now, let us say that you are planning to apply for some of the good company. So what will happen then initially, like, let's say you are applying for some of the company. So what will happen initially, that company is going to be conducting some set of rounds. Like, it depends company by company. Then initially there are going to be some 1 2, like, either 1 round, 2 round or 3 DSA coding rounds. All right. Now, these rounds are going to be all across coding. So this is going to be checking the basic abilities of you, that how you can be writing the code. So here everything goes around how to code. And once you are through this line, then you will be seeing something like low level system design round. Here they are going to be checking that how well versed you are with writing the quality code. So that is what, like, once you have this round, the other one is going to be your system design round. And basically in this, we will be having LLD. So this one is going to be ensuring that if later on, if you're going to be joining that company, how well quality code you are going to be writing. So, like, when you talk about the coding round, so everybody must be aware that it goes around only data structures and algorithm. But you all must be aware that after joining any of the company, is data structure something which you are going to be using? So that is something which you are going to be using there, but you should be not writing the direct code. Like, you are going to be using graphs, you are going to be using array list, but on the top of that, what is the thing which is that which will be required? That is how is the quality maintained when you are going to be taking a decision that, okay, here I want to take some abstract class, here I'm going to be defining it as a field. How you are going to be taking all of those round? How do you are taking going to be taking all of those decisions? So all of that is going to be determined. So when you talk about the DSA coding round, so these rounds are basically there to check how good you are at problem solving. But problem solving is not the only thing that you need to put. Other things are also required in order to make a good company. If you are trying to create some good applications, so in order to make it, so you will be first of all knowing what the user requirements are, and based upon the user requirements and all, you are going to be designing your system. So this is where your low level system design comes into the picture. Okay. So whenever you're going to be working for any of the organization, you're also going to be working on some real life problem. And for that, you're going to be designing an application for the end customer. So this is something in which you should be extremely good at, because this is something which you will be doing on a day-to-day basis. So once you are done with this, the organizations are going to be testing you if you are a good fit for the company or not. So if any of you, if you are a student, then you should be understanding that your interviews are very different from the vivas and your semester exams. So when you talk about semester exams or vivas, there we just have to check if you pass or fail that particular exam. But what is the idea of the interview? That is not going to be revolving around if you are able to solve the problem or not. If they have given you some system, then you are going to be able to design it or not. So that is something they are going to be checking, if you are going to be a good fit for the company or not. So in the interview, if they are going to be asking you some questions, so basically they are going to be checking about your psychology towards that problem. They are going to be checking what are the logic which you are going to be using in order to solve the given problem. They're going to be seeing that how good you are towards that problem approach. When you talk about the system design down, so these ones are always open ended, and when we talk about open ended, that means it is not going to be correct, it is not going to be wrong. So you are not going to be realizing that your system design round is actually going good or bad, because there is no straight answer for that. So throughout the interview, the interviewer is not going to be checking if you have made the correct design or not. He is going to be checking that tomorrow, when you are going to be a part of his team or his company, then how you are going to be approaching towards a problem and how do you solve it. So if you are solving a problem with a pattern, which is a standard version of how you should go and solve it, that is what the interviewers are going to look into you. So see, the major intent behind the system design rounds is to check if you have that good logical thinking, if you have that logic building to solve any problem for the customer. So this is the main reason behind system design interview. Okay. And one more thing, if you talk about this example, like where I'm saying in the interview, basically in the DSA coding round, they're going to be checking the basic ability. Like example, you want to cook some food. So this round is going to be checking how you are going to be cooking that food. And when you talk about the low level design, here they are actually going to be seeing that how well versed you are. If it is only about cooking the food, so that is something which involves the basic abilities, and that is where this much information is going to be required. But let us say you see some profession in cooking. So this low level design round, if we are going to be linking it in the same example, so this one is going to be actually checking how to make cooking as your profession, how to become a chef. So all of those things are going to be coming here. I hope with this example, it must be clear to you about how the distinction is going to be there. Okay. So now, when you talk about this candidate only, right? So this candidate is actually applying for some interview. Now you need to see that in the interviews, what generally happen. So you need to, first of all, you need to understand that you are going to have very lesser time to solve that problem. You're going to be getting somewhere around 45 to 60 minutes to solve that problem, and in this limited time you will have to impress the interviewer that your logic is correct and you're competent enough to work for that company. But all you need to see, you only have 45 to 60 minutes for that. So, when you talk about this time, since you are only going to be getting somewhere around 45 to 60 minutes, so you will have to ensure that you are going to impress him by using the correct approach to solve the given problem. You need to understand that competition is extremely high in this industry, right? A lot of people are going to be applying for the same job, and everybody is going to be preparing it in the same manner. So if you want to get selected for that particular post, you need to understand that you are going to be like, in that particular case, you are actually going to ensure that you are not going to give him any chance of rejection. So in that case, you are going to be using the correct approach to solve the given problem. Because here you are not going to get a second chance. Of course, you can apply for the same company, but for that you will have to wait for some cool off time. In some companies it is 6 months, and in some of the companies it is even more. So we should be actually using some systematic approach to solve the problem. So, if we are going to be getting some different sources of lectures online, in that you're going to be seeing that everybody is using different approach for solving the given problem. I will be telling you the solution which has worked for me. Also, I have seen students getting jobs based upon that approach in all the different companies like Google, Microsoft, and so on. So basically, what I'm trying to say, there are going to be different solutions in the system design round, and all of those approaches are going to be correct. You should not be determining that is this correct or is this wrong. So all of the approaches which I'm going to be telling you is going to be logical. Okay, so now we are going to be just mimicking a system design round question here, so that you will be able to understand that if you have such a scenario, how you should be answering. Okay, so like, in the interview, people are asking you a question that you will have to design a movie booking application. So, movie booking application like Book My Show. So, this is what the problem statement is. So, here if you will see that the interviewer has given you a question that design me a movie booking application like Book My Show. And he wants you to implement the class level code. He wants to know that what is going to be your class level design approach. So this interviewee, like, this candidate, he has learned all the system design patterns. So as soon as he reads the problem, his brain will start working on solid principles and all the creational, behavioral, structural design patterns. So this guy started writing the code for the different classes, but he thinks that it should be there for the moving booking application, and he continued doing that for the rest of his interview. And also the interviewer is not stopping him. So after the interview happens, the candidate, this guy is going to come outside and he will feel that yes, I was like, he is satisfied that yes, I was able to give him all the classes which were supposed to be there, and the interview went very simple, and the interviewer was not even asking questions in the middle, so it went super smooth. So what do you guys think? What must have happened? Did he get selected or not? So this candidate got rejected because this is not a college level problem that you are going to be getting. You are just provide, like, it's not that they have given you some question and for that you have to provide the solution. This is a system design round. So the main idea behind the system design round is to understand how well you are able to understand the user problem, how you are going to be implementing it. Here, if you will see, the candidate has not even taken the requirements from the client. And who is the client here? Our interviewer, who has given this requirement to him. So, like, whatever understanding this guy had, Based upon that, he started implementing the same. Obviously, if you talk about the time, like let us say 60 minutes, so that is something which is not enough to write a fully functional code. So if you will understand, he could not even complete the code in 60 minutes, and his entire interview, he could not even tell, like, how he is going to be approaching towards that problem. So whatever efforts he has made in order to crack the initial few rounds, that also got wasted, because I said it's not going to be the first round. Before that, you need to go through some of the DSA rounds. So like, you should be able to you like, you should be understanding that how you are handling such kind of problem. How you do such kind of things in a real life is pretty much same, like, how it will be going in the system design round. We just go ahead and try to, like, see how it is going to be working. So like, whenever you are going to be working for some of the company, you are going to be taking the requirements in order to implement that problem. So these requirements are going to be getting from your company people, right? And who these company people are? Somewhere like product managers. These are going to be giving you the requirements, right? So what actually happens in the system design round, they try to mimic the similar situation there. So most of the time, the problem statement is vague. It is not even going to be complete. It is not even going to be providing you all the important parameters which you should be considering. So how do you solve that problem? There you cannot go ahead and jump into the implementation of the problem because your bandwidth is limited. You should be checking on what is the priority of that problem. Also, you cannot build the entire problem in a day. So what you should be doing, first of all, understand what the requirements are. And among all of the requirements, you should be understanding the scoping. Like I mentioned, if you are having some of the problem, so for that, you are going to be scope it down. Correct? You are going to be determining what should be going in my phase 1. You are going to be determining its phase 2 and so on. So these are going to be the different phases. So you need to understand, and you are going to be scope it down, and you are going to be determining what should be going in the phase 1 of your implementation. So if you will go and determine what is going to be in the phase 2 of your implementation and so on. Similar way, if you talk about your system design round, the time is also going to be limited. The time is going to be roughly around 45 to 60 minutes. So in that time, it is not possible to provide a fully complete code. So same thing you should try to do in the interview also. As soon as you are getting the problem, you should like, let us say the Book My Show app. So it's always better to read the mind of the customer. And who is the customer here? Your interviewer. He is your customer. So once you get the problem statement, then you should tell him that I understand that what Book My Show application is, but can you tell me what requirement which you are looking for? So first of all, you should be having a requirement discussion. So initially, 5 to 10 minutes should be going across understanding the requirements. So your initial 5 to 10 minutes of your interview should be across understanding the requirement, because a lot of times it can happen that you do not know what that product is all about. So let us say he is asking you to design a web crawler. And if you do not know what a web crawler is, or if you do not know what a web crawler does, so in such a case, designing is going to be difficult, right? So you know exactly the same thing which we are doing in our industries, in our organizations. So if you are going to be designing something and if you are not fully aware about what will happen, in that case, we are going to be having a discussion with our product managers. We are going to understand the requirements. If product managers are not going to have the answers, in such a case, they are going to be having a discussion at their level, and then they will be communicating the same to the entire team. Now, the problem statement is to build a movie booking system. So for this, first of all, you should be asking about the use cases. So it is okay to ask him questions across the given problem, that what is going to be the use case, and if you understood the problem statement, then you can propose your own use cases. You can ask him that this is my understanding. Now, can like, and these are the use cases which I have. Can I go ahead and use it? Like, you should be always having an interaction throughout. Just put what your understanding is and validate them, because We should be well versed with what the interviewer is actually looking into you. If you're going to be asking him any question, so that is going to become +1 for you, because they will feel that you are curious to know about the problem. At the same time, you're also going to be having lots of pointers which will lead you to a correct solution for the problem. If you're not going to be asking any of the question, that can actually go towards a negative direction. They may feel that you are little ignorant. You should also be like, sounding like a curious guy and not like the ignoring guy. So this is what we call it as interview awareness. So I will tell you some of the questions which can actually be aligning with the curiousness about the question. So see, they have given you a question and let us say you have no idea about that. The way you can sound ignorant is that if you go and say, hey, I do not know about this problem, can you give me some other problem? Because here you are trying to escape from the problem. So you are going to get referred as an ignorant person, because when you will be joining any of the organization, there will be a scenario when you do not know the problem statement, when you have not worked on the similar problem statement in the past. In that case, if you are going to get such a problem, how you are going to approach towards it? Basically, this is what they try to look in a candidate. Now, like, I'll tell you how you can actually sound like a curious guy. You say that I do not know anything about this. Can you tell me some detail about it, some context about it, how customers will be using it? So here you are indicating that you do not know about it, but at the same time you have the willingness, you have the curiosity to know about it. So you can put your 100% at the time of implementation. So I hope now you know, like, if problem statement is known to you, then how you will be responding to it. At the same time, if you do not know the problem statement, then how you can get more context about it. Okay. Now, when you talk about this movie booking application, so let's discuss what are the things which our users are going to be looking for. Like, they can be searching for a movie in his city, searching for the theaters, searching for the movies in the theater. A user should also be able to book a movie in the theater. Users should be able to see the booking history. So basically, these and all are the things which we can do, right? Then, like, once we have written it, then we will start writing code for the movie booking application. So these are the points which we are going to be considering. These are going to be the features which we are going to be supporting in our application. So these are the requirements which application should have from the customer perspective, and in our case, it should be according to the interviewer. Now we are going to be looking into the requirement from the admin perspective. What and all requirements he can have? Something like adding a movie, removing a movie, adding a theater, removing a theater. Since this is a movie booking application, so there are going to be multiple theaters. We will be having someone who is going to add or remove movie theaters from the list. And the same person is going to be responsible for adding or removing a movie. And that special person, we call it as admin. In our application, we have to kind of have same, we are going to be having three kind of people we are going to be having. One is going to be the user or the customer, two only, and the other one is going to be the admin. Now, since this is a low level design, so we are not going to be worried about the parameters which we should be considering at the higher level. Like, we are not going to be looking into how we can scale our application, how we can add performance to that. We are not going to be looking into all of those things. We're only looking on the low level design. So for a lower level design, once we have finalized the requirements, then we move towards the implementation. When we move towards the implementation, first of all, we need to identify the entities which we will be having there. So since if you talk about this, what we have movie booking application. So what and all entities a movie booking application can have? Yeah. So now we are going to be identifying what and all entities we are going to be needing here. So if you talk about movie, so for that, we need to understand what and all are going to be the attributes for that. For a movie, we can have attribute like ID, we can have something like name, we can have description. For a movie, we can also have something like duration. We can also have something like when it got released. We can also have information related to the cast of the movie. We can also be having information like language of your movie. Now these are the attributes which we have finalized. Corresponding to this, we are also going to be seeing what kind of data type to use. Okay. So if you talk about ID, this ID could be of long type because we cannot just bound it to some limit, correct? So if we talk about long, in that case, we will not be having a limit. Okay. The next one is name. So for the name, we can actually go ahead and use string. Now for the description of the movie, again, we can go ahead and take string. When you talk about duration of the movie, duration could be in decimals, right? So for that, we are going to be using double. When you talk about date, so for that, we have a data type of date time. So that date time is going to get used here. Now for the movie cast, we are going to be taking names of the actor and the actresses. So for that, we are going to be using string. Then for the language, what could be the data type? So, for language, like, we can actually define a enum, and that enum is going to be listing down the different languages which we can have here. So this enum can have different languages like, English, Hindi, Spanish, Telugu, whatnot. Okay. So that is how we have defined our movie entities. Like, when you talk about this entity, so entity should be defined by the use cases which we will be having. So like, when you talk about like, let's just consider like when we take the assumption that one theater is only running one movie, one show at a time. So later on, maybe we will be adding a support for the multiple movies, multiple shows. So like, in this case, interviewers intentionally give you such a basic requirement in the beginning because they want to check if you're able to add more features. Like, if you are actually adding the ability to add more features, if you are able to apply open close principle or not. So for this, they are going to be adding more requirements at the later phase of time. And then you will have to decide the attributes for these entities. So understand our basic requirement in the form of real world entities. And what do we have to do here? We have to define the attributes of these entities so that we can represent them in the object oriented programming. After determining it for a movie, let's just quickly see that for the customer, what attributes could be there. I'm just listing few. I'm not listing all the attributes. You can anyway like add more. So for the customer, we can have something like ID. We can have something like name. We can have address. We can have phone number. So for now, I'm just taking these attributes for the customer. After that, like I said, we are also going to be having admin here, right? So for the admin, we are again going to be seeing what attributes we can take. So here we can take ID, we can take name because admins are also going to be a human person. They're also going to be having address and they're also going to be having phone number. So if you will see so far, all the attributes are same, but you need to understand these admins are the employees. They are also part of the organization. So on the top of it, they will also have something like employee ID because that is how we are going to be distinguishing them. Now, what the first approach is going to be there. So in this case, let us say we are having a user class, like, we are going to be determining a user class where we are going to be defining all the user attributes like the ID, name, phone number, address. So all of these I have defined in a user class. Now you can see that just now I have told you what attributes are same. So everything is same in the customer and admin except the employee ID. So what we can do, we can create an admin class like that is going to be separate. In this class, what we will be doing, we are going to be extending our user class and we are just going to be adding the employee ID here. Correct? So this actually makes sense. You do not have to write your code again. You're just making use of the existing one. Similarly, there is going to be another user, which is going to be the customer. So the customer is again going to be having all these details. So the customer is also going to be extending your user class. But here we can actually have something like, for the customer, we keep on we can actually go ahead, just to have customers, we provide some coupons. Okay. So if applicable, if it is going to be there, we are going to be providing. But you can say that, okay, this is something which we have not thought as of now. This is something which we could have in the future. So in the future, we are going to be providing support for that. So I hope it must be clear to you how we are progressing in our approach one. Let's quickly discuss another approach for doing the same. Okay. Like I said, here nothing is right, nothing is wrong. It all depends upon the approach. So let us say you are creating a user. So for this user, you're going to be adding ID, you're going to be adding name, phone number, address. So all of these things you have added here. Now we know we have two types of users. So here what we can do, we can mention something like user type, and this you can define as enum. So inside this you will have two types of values. The first one is going to be customer, the second one is going to be the admin. So you can see we had two ways of solving this problem. Now we will have to decide which approach is extensible one, which is better one. So if you will see the first one, we have the more flexibility. Let us say we want to add some more attributes which are specific to the entry. Certain things are extremely easy, right? So if you talk about this approach, like here for the customer, I just have coupons for now. But tomorrow, let us say I want to add something like referral ID as well. But if you talk about it's very easy for me to go ahead and provide support for the referral ID in future. But if you talk about second approach, this is little tightly bound. Here, even if I want to add it, it's not going to be the easy one because it is tightly bound. So if you talk about the second scenario, so if we are going to be adding any attribute inside user, then all the user types will have to provide a value for the same. So in such a case, we are making that class as a fat class, and this is not obeying that single responsibility principle, right? So here you have seen that if I wanted to create a user, how I'm going to be approaching. These are the two approaches which I have listed. There could be other approaches as well. Similarly, if you want to do any other approach, any other we are taking any other problem statement here. Let us say about searching a problem. So how you are going to be doing it? You are going to be taking care of the different approaches. For everything, the approach is going to be different. Now I'll just quickly tell you what the global standards are for the system design round, because that is something which a lot of people generally ask. And that is something which is going to be this is one of the very something which everybody wants to know, and that is also going to be relevant for everyone. So for that, let us say you have somewhat we basically have three categories here. So if somebody who is having less than 2 years of experience, the second one is 2 to 7 years of experience, and the other ones are which are having more than 7 years of experience. So if you have less than 2 years, in that case, majorly it is going to be revolving across your coding skills. So 70% is going to be coding, and 30% is going to be your system design skills. But if you talk about 2 to 7 years, here 50% of your coding skills are going to be there, and 50% of your system design skills are going to be there. And if you talk about someone who is having more than 7 years of experience, then very less coding skills are going to be required, because they assume that by now you are well versed with coding. So only 30% coding skills are going to matter, and 70% of your system design skills are going to be mattering, because after reaching to that uh, level of experience, they will be expecting you to be involved more in the system design discussions. Now, one more thing, like, if you have less than 2 years of experience, the mostly system design round is going to be revolving across low level design. For 2 to 7 years, it will be more low level design and less high level design. But for someone who is 7 years of experience, it is majorly across high level design, because with that level of experience, you should be capable enough to take the decisions like how to scale the application, how to improve the performance, how to index it, what kind of database to use. And like, so far we have covered the low level design. Now, after this, we are going to be starting with the high level, where you are going to be covering all of these core concepts and you are going to be understanding all the systems around you in a better way. So when I learned system design, after that, when I was looking into any of the application, I just tried to understand what logic they must be using there, what concept is behind that, what approach they must have followed there. So all of those things, like, with the help of lot of examples, we are going to be covering. Now I will be seeing you in the next module. Till then, bye bye. Hello everyone. So in this module, we are going to be learning what your high level design is. So, whenever you are learning anything, like I have said previously as well, you should be actually having three questions in your mind. What is this? So, here you should be knowing what is high level design, why are we learning high level design, and how we are going to be doing it. So, all of that we are going to be covering. Okay. So, like, everything we are learning on this platform that has one ultimate goal, that is to get a software developer job. Correct? Now, where do you want the software developer job? Like, of course, you are going to be targeting some tier one company for that. Correct? Now, if if you talk about why these companies are even asking system design round, why they are asking some coding rounds. So the reason companies ask coding and system design rounds in the interviews is that these are the tasks which you will be encountering once you join the company. So let us say you're giving interview for some company, let us say X. Okay. Now what this company is actually going to be doing. So this company is going to be making softwares, correct? And for whom they are going to be doing it? For the customers, correct? And what they are going to be, like, what softwares they are going to be building it. So these companies, they are actually trying to be solving some real life problems. In order to solve these real life problems, they are going to be building some softwares which are going to get consumed by the customers. So software is the solution that IT companies are building so that they can address the real life problems. And what examples we can take here? If you want to buy medicines, you can use the application like Practo. If you want to buy groceries, you have the applications like Zepto, Blinkit, Big Basket, and so on. So these are the solution for the real life problems which we guys are facing. And these companies are just trying to help you by building the solution for that. And those solutions are ultimately getting consumed by us either for our benefit or we are directly going to be consuming them. So now let's talk about the software development lifecycle. So that is something which you guys must have already learned about it in your colleges. Okay. Software development lifecycle. So while you must have already learned about this in college, but the reality, how a software is exactly built in the organization, that could be little different. So in this discussion, I will be focusing more on the practical way in which a software is developed in the real world companies. So from there, we are going to be taking a dive into what the concepts of these how we are actually going to be taking a dive into all of those components. We are going to be seeing what and all are actually essential while building any of the software, how we are going to be making them efficient and scalable. Okay. So, but and all, for a system design, we have some low level design and we are having some high level design. We have already covered the low level designing part. Here we are going to be putting more focus on the high level designing part. So in the low level, first let's discuss what and all steps are going to be there in order to solve any of the problem. So the first step is going to be the requirement gathering. These requirements you are going to be gathering from the different people. If you are having a startup, you can have it by collecting the requirements from the customers, either by doing some polls, quizzes, surveys, something you can do so that you can gather what solutions they are actually looking for. And if you're already working in some company, then you will be having some product managers who are going to be telling you that, okay, this and that are the requirements which they have gotten them from their clients, and you are going to be working on solving those. Okay. But after gathering the requirement, the next one is going to be scoping, where you are going to be defining your work. You're actually going to be coming up with a timeline that for this given time period, for this given task, this is the time frame which I'm going to be referring. In this quarter, I'm going to be delivering this part of the work. In the another quarter, I'm going to be delivering this part of the work, and so on. You're also going to be planning when you are going to start the implementation, when you are going to put some of the feature into the testing, when you are going to be putting that feature into the deployment. All of those things you are going to be discussing as a part of this step. After scoping, the next one is going to be the estimation. In this estimation, you are going to be determining the data size. Like you take the example of Snapchat or WhatsApp. If you will see, if you want, generally when you talk about anything on a smaller frame, you do not realize how much memory it is going to be consuming. Like if you talk about Snapchat or WhatsApp, let us say one message is taking 1 KB. You can see we have millions of users. All of those users are going to be roughly sending some 100 messages in a day. I have taken average. So how much memory it is going to be taking. So all of that we need to estimate before the implementation so that we can have that amount of storage available for us. In the estimation, we are going to be taking care of three things: your storage, your compute, because after having the data, you are also going to be performing some computation on the top. And later on, you will be needing some of the network so that all the servers can interact with each other and the data can flow from one place to the another based upon the requirement. After this, the next one is actually going to be the components. Here you are going to be deciding the architecture. You're going to be deciding what and all components are going to be there, how you will proceed ahead, how you will break it down into smaller components. Once you have finalized your components, the next one is going to be the implementation. In the implementation, you will go ahead and start implementing each of these components one by one based upon the priority. After that, we will have testing. So this, once that component is ready, we will go ahead and test it. And if it is working fine, we will go ahead and put it into deployment. So if you talk about these four, all of these things are going to be taken care by your high level design. And if you look into these three, they are going to be taken care in the low level design. And when you will be implementing it at that particular time, you're also going to be requiring something like design principles and design patterns. So for the high level design, we are actually going to be discussing some of the components which you are going to be needing in all of these four steps. So let's discuss all of them and I will be seeing you in the next module. Bye-bye. Hello everyone. In this module, we are going to be covering web applications and their architecture. But before jumping into web applications, we will first of all be seeing what is the difference between web applications and websites. Are they even same or are they different? So you should be knowing the difference between both of them. So websites versus web applications. All right. So when you talk about websites, so typically they are going to be having some static content. So when you talk about some static content, what does it mean? It means that content which is going to remain same and that is not going to change unless we are doing some manual updation or that. And in this one, we are only going to be providing the access of read. If you talk about some newspaper website, so those ones are majorly static because they are going to have some news and all you will have to do is to go through that. So I hope it must be clear to you that what do we actually mean by static content. All right. Now the next one which we have here is web application. So when you talk about web application, here we are going to be having some dynamic content. When you talk about dynamic content, it means whatever the content we have here, that is going to change in the real time. And this is also going to be user interactive. So here we are going to be providing the read plus write, both of the accesses. So that is how the web applications are going to be there. Now I'll just list some of the examples for both. So when you talk about websites, just I took one example, that is going to be something like newspaper. Example, Times of India or any other. Okay. The other one could be something like Wikipedia. Although you can go ahead and change the content, but for that you will have to make a request. You will have to add a page there. That is how it is all going to be working. But in general, Wikipedia is all about reading the content. Also some blog posts. So blog posts were also quite popular, and in that one what people were doing, they were just writing down everything there. So as a user, what you were doing, you were just going through that, reading, going through the pictures. So all of that was static content, you were not modifying it. So that is the example of your websites. Now let's quickly discuss some of the examples for the web applications. So it can be something like Gmail. So here if you will see, you will be having the flexibility of composing a mail, sending a mail, you know, based upon like, if you are composing and the moment you are going to send, in the real time itself, it will get sent. Other example, if you talk about some social media like Facebook. So there in the real time you can see who is posting pictures there, you can chat in real time, you can like the statuses and posts in real time. So all of those things are happening in the real time and that is user interactive, like you are also interacting with that. Okay. Another example could be something like LinkedIn. So in the LinkedIn, what happens, you are going to be having the flexibility where you will post about your milestones, you can see what other people have posted, you can interact with the recruiters, your friends and whatnot. So that is how it is going to be there. So here, like, if you talk about static content, what we actually mean by the static content. So static content is going to be that information which is read only, and this does not change based upon the user interaction. For example, some text or images on the web page that remains constant until the page is updated by the website owner. So typically that is how it is going to be there. Also, like, if you talk about creating a basic web page using HTML, so that is also somewhat similar because there we will be putting all the static contents like image we are putting, table we are putting. So all of that is going to be coming inside your static content. On the other side, if you talk about the dynamic content, what will happen? You will be having access for both read and write operations. You can read the content as well as you can interact with it. You can update it. You can also add new content. So based upon the requirement, you are interacting with that. So that is how your web applications are going to be there. And majorly in today's state, we are using web applications. Although we are still using websites, and like, they are still going to be there because of the use case. Like they offer a different use case, and for all of the scenarios, like we are not going to be having always the dynamic content. Correct? So if you talk about the past, like, websites were primarily static only. Initially, when internet came and all, majorly we were using static content there. mostly we were performing some read operations. So whatever the content which was available to us, that was read-only content. If you talk about the early websites, so majorly those were informationals and you could not interact with them beyond reading. You were just extracting the information, reading, and just that's it. So that's how initially the concept of websites were introduced. However, if you see today, most of the websites have evolved into web applications. So these are dynamic and they allow for both reading as well as writing. So if you take the examples of like Gmail, Facebook, LinkedIn, so they all are allowing you to read the content, to post status updates, to share pictures, and perform many other interactive tasks. So if you talk about any platform where you can dynamically change or contribute the content, that's what we call as web application. On the other side, like if you talk about websites, so these websites are primarily used for reading purpose only. So if you take the example of Wikipedia, news websites, blogs, so here if you will see, the main interaction is consuming content rather than creating it or modifying it. So these are typically read only platforms. That means the user cannot significantly alter the content. User cannot change the content and they are categorized as websites. Now we can actually have a question that in future, can I replace all the websites with web application? Now you guys can actually think about it. The answer is yes. In future, or if you talk about present, we can replace all the web applications, all the websites with the web applications. But ideally, we should not be doing that. So technically, like, we can replace websites, but that is going to be overkill in many cases. Websites are often simpler, static, and they serve different purpose as compared to web applications. So example, like, if you only need some read-only content, like writing poem, blogs, or displaying some static information. In such a case, a website is more suitable. A dynamic web application is not necessary in such cases. In such cases, a website is sufficient, more efficient, and ideal for showcasing the static content without requiring some real-time data or it in complexing the making the entire user interaction complex. So that is how it is going to be there. When you talk about websites, so websites are actually serving as a digital repositories for the information. So think about a piece of paper. Like, if you are storing some of the information on a piece of paper, over the period of time, it may tear, it may fade, it will get damaged, it will become unreadable, or it may even get lost over the period of time. On the other side, if you talk about websites, since it is a digital repository, we have the option of preserving the information for long term. And considering this, websites are still going to continue. They are still going to exist in the future for the situations when we only need static content, when we only need read-only content. When read-only content is going to be sufficient, we are going to go ahead and use websites only. Now, we should be knowing when to use a web application. Okay, this is what we are going to be discussing. So when you talk about web applications, so web applications are needed when you want to solve some real life problem. So if you are going to be solving some real life problem, so that is also going to be involving some dynamic interaction. Correct? So if you talk about, like, let us say some web application is there and that web application is letting us perform some of the actions based upon our inputs and based upon whatever our requirements are there, but that is something which you cannot do on some static websites. Example, if you want to buy something, where you will go? You will go to platforms like Amazon, Flipkart, right? If you want to travel, where you will go? You will go to Ola, Uber. If you want to buy medicine, where you will go? you will go to 1mg Practo. If you want to communicate with someone without leaving my home, so there you will have some dating websites. If you want to interact with your friends, so you are going to be using Facebook, you're going to be using Instagram. So all of these things you are going to be using. So you need to understand what your problem statement is, and accordingly you are going to be taking a decision on the top of that. If you talk about the today's world, so everything can be actually done by web application. Be it your shopping, communicating, traveling, managing tasks, anything. So for everything, we are actually interacting with the web applications every day. As the internet continues to evolve, web applications will always remain central to how we live, how we work, how we interact online. So today almost everything that everything we are doing through web application, which is letting us interact, transact, solving problem in a way that static websites cannot. Now you need to understand why web application is essential. So let us say you are planning, if you are already working in some tech industry, it is very important for you to understand that most of the companies are building or maintaining web application. So whether you are working as a front end developer, back end developer, or a full stack developer, you are going to be contributing to the development of these web applications only. So that is why understanding the architecture of web applications is very important. Okay. So when you talk about web application, so every web application has a front end and a back end. When you talk about front end, so that is your visualization layer. All right. So this is where the user is going to see and interact. Here, what and all you are going to be using? You are going to be using something like HTML. With the help of HTML, you are going to be if you want to structure out something, you are going to be using HTML. If you want to add some styling, you are going to be using CSS. If you want some interactivity, so with the help of JavaScript, you are going to be adding that. When you talk about some of the JavaScript frameworks like Angular, React, so what of these frameworks are actually doing? So they are helping us in building some interactive and dynamic user interface. So when you talk about front end, so front end is actually all about creating some engaging, responsive experience for the user. So that is how it is going to be there. So if you talk about any of the web application, here broadly we are going to be having three things. Okay, any of the web application is broadly going to be having three things. So the first one is going to be the front end. This is also called as your visualizing layer. The second one is going to be the back end. Back end is going to be the business layer. That is where you are going to be putting the core logic. And lastly, you're going to be having some data storage layer. So whatever data you are going to be requiring, all of that you are going to be storing and managing here in this layer. Okay. When you talk about front end, just now I have listed some of the technologies. So what and all you are going to be using here? Let us say HTML for structuring out, CSS for the styling. You're going to be using JavaScript in order to have the interactivity. You're also going to be using JS frameworks like your Angular, React. So that is all you are going to be using here. And in this case, like there is going to be someone, like this person is going to be there who is going to take care of all these responsibility, and we generally go ahead and call them as front end engineers. Okay. Now when you talk about back end, so here what and all responsibilities we do, we build the core logic. and we build that in some of the languages like your Java, C Sharp, C++, Python, and so on. And for doing that, you will be having some set of person who is going to be taking care of all these responsibilities. And that one we go ahead and call as backend engineers. Then for the data storage layer, we are going to be making use of like file-based storage system. We are going to be having database management system. We are going to be having relational database management system. We are going to be having NoSQL, and the guy who is going to be taking care of all these responsibilities, that we go ahead and call as DBA, database administrators. Now you have seen, like, we have three different layers and we have three different person who is taking care of all these responsibilities. We have one more, that is something which we call as full stack engineers. And these are the ones who take care of the responsibilities which a front end engineer does, as well as the responsibilities of back end engineer. So that is all this person is going to be doing. Okay. So, like, when you talk about any web application, you should be knowing that here we are actually going to be taking care of the visualizing part, the backend logic, and the storage part, because we are going to be also, like, this data is something which is getting very, like, this data is something which is evolving every day, and for that we actually need to find out some procedures so that we can go ahead and store them and compute them efficiently. When you talk about backend layer of the web application, so that is where you are going to be, like, this is something which we also call as business layer, and this is responsible for writing the core logic. The data management of that application is also important, and that is where, like, you are actually going to be taking care of this data storage layer. So this one is going to be performing all the complex computation and all the other processes which we require to run the business. It's that part of the application that the user does not get to see. Like, if you are, let us say, opening Gmail, so all you can see the front end. There you will be entering the username, the password, and you will just click on login. What is the logic, the core logic that has been happening behind that? That is something which you are not going to see. So backend is something which generally a user is not going to be seeing, but this plays the most important role in its functionality. So this layer is basically responsible for crunching and munching of the data. And this one is going to be providing all the necessary information that your back front end needs to function properly. Like, after computing, it is going to be providing you the value, and we are going to be displaying that on our screen. So this, like, whenever you talk about the front end, so this one is going to be requiring some data, some text, some images, some news feed, and that data is going to get fetched and delivered by the backend only. So we are going to be writing the core logic in the backend. So this backend, we also call it as brain of the application, because it is actually processing the user request, it is running the business logic, and this is also serving the data need for the front end to display. What technologies which we use in the backend, like, we have various programming languages, various frameworks. You can go ahead and use any like any of the applications based upon the requirements. Some of them I have already listed, and some other are also there, like Ruby, Node.js, and so on. So these languages we are going to be using so that we can build APIs, we can handle database operations, and we can manage the overall business functionality of the web application. And all of those things are possible with the core logic which we are going to be building by using these languages. Correct? Now, this data storage layer, right? So when you talk about the data storage layer, so in any of the web application, data storage is going to be the critical component. Without having it, the application is going to be incomplete. So there are various approaches for storing your data, like file-based storage. So like, what happens, like the name is suggesting here, we are going to be storing our data in the forms of file. And we generally use this kind of storage for our simpler or smaller data sets, where we can store our data in files, some flat files, logs, something like that. Okay. Then we are having DBMS, RDBMS, like your relational database management system. So we are going to be having systems like, MySQL, Postgres, SQL, Oracle. So these are going to be storing our data in the structured table. So this is also going to be enabling your complex queries and relationships. Now the next one which we have is NoSQL database. So here we are going to be having systems like MongoDB, Cassandra, Redis, and all of these things are going to be handling unstructured, or you can say semi-structured data. This one is going to be providing you a lot of flexibility and scalability. A lot of people also get confused by the term NoSQL. They feel NoSQL means something which is opposite to SQL, but that's not the case. What NoSQL does, like, we have certain capabilities of the SQL, and whatever SQL cannot do, that we are doing with the help of NoSQL. So we can say NoSQL completes SQL there. In this one, we can have some unstructured data, like you talk about, let us say Flipkart. So there you will be seeing we will have multiple products listed there. All of those products are going to be having different set of parameters. If it is some beauty product, so we will be having some different attributes there. If it is some electronic, we will have some different attributes. If it is some food item, we are going to be having different attributes for that as well. If you will see, all of the attributes are going to be different in the terms of count as well. So that is something which we refer as unstructured data. And in order to implement that in the coding, we are going to be using NoSQL there. Okay. So I hope this must be clear to you. Now we are going to be discussing the different architectures for the web application. Now we are going to be discussing the different architectures for the web application. Different architectures for web application. So, here we are going to be having different architectural approach, which we are going to be using for creating your web application. And the first one, which we have here, is going to be called as monolithic architecture. So let's discuss what monolithic is. Okay. So like, here if you will see, we have, like, when you talk about this word monolithic, so this is actually made up of two words. The first is mono, and what is going to be the meaning of mono, which is going to be telling one or single. Correct? So when you talk about one or single, that means here everything is actually going to be defined in one unit. So in this one, like I said, we have three major components: your front end, your back end, your DBA. So all of that is actually going to be there as a part of one single unit. So that is what your monolithic is actually going to be meaning. So when you talk about web applications, like, if you talk about in the context of web applications, so monolithic architecture means a design where all the components, your front end, your back end, your DB, all of those things, all of those things are actually going to be there in one application. So here if you will see, these all are tightly integrated and they all are actually going to be running as a single unit. Okay. Now, when you talk about monolithic application here, what will happen? Everything is going to be part of one code base. All of the layers, your front end, your back end, your database. So all of these layers are going to be existing together in the single application. This means your front end, your back end, your data storage, all are going to be bundled up together in a single application. So this application is typically going to be deployed together, and this is going to be running on the same machine or server. So when we are going to be having code, so the code for all the parts of the system is going to be as a part of one code base. So that is going to make it easier to develop and maintain it in smaller applications. But here, if you will see, it is harder to scale the application as it grows because everything is there in one code base. So it's not going to be easy for us to scale when your application is growing. In monolithic architecture, everything is going to be together at one place. So what we can say here, we are going to be having single code repository. Okay, what can that mean? There can be different files, but the repository is going to be same. And in this one only, we are going to be putting all of the front end, back end, and data storage at one place. Now let's take example of some monolithic application. So, let's take some of the well-known application. So let's take the example of, let us say, LinkedIn, or you talk about PayPal or the Facebook, like any application. So, initially all of these applications were actually built using monolithic architecture only. So even if you talk about Facebook, so initially, if you know, the Facebook was initially built on PHP, and this PHP was providing support for your front end and the back end, and also the DB. With the help of PHP only, we were trying to do all of these things. So in this setup, we can say PHP handled everything in one integrated system. And that's how it made Facebook as a monolithic architecture. So all of those things were actually taken care in single code base. So similarly, if you talk about Java. So Java, if you want to create front end, you have something which we call as JSP, Java Server Page. If you want to use the back end, for that you have Java Beans. There you can write down your core logic. And if you want to have the data storage, so for that you will have relational database. So this way we can say that if you are like building any monolithic application, there if you will go ahead and use Java, then also you can go ahead and achieve a monolithic application. So Java can also be used to create monolithic application where everything is going to get handled within one environment or one framework. I hope this must be clear to you. Now we are going to be seeing the advantages of the monolithic applications. Plus, we are also going to be discussing the scenarios where monolithic is actually going to be making sense. So the first, so whenever you are going to be starting any new application, so you may not be knowing what architecture to choose or which one will be the safest for the long-term success. If you are having that level of uncertainty about the future of the application, or if you have limited resources, in such case, monolithic architecture can be a great choice because initially when you are setting up any of the application, you do not need some complex architecture. You need everything which is very simple and everything lying at one place so that it will be easy for you to maintain. Now what is the first advantage of using monolithic architecture? That is fixed boundaries. And you can say along with the fixed boundaries, this is also helping you in allocating the resources in a simpler manner. So okay, so when you talk about monolithic applications, so in this one, we are going to be having fixed boundaries. With that, it makes us easy for us to manage the resources. Let's just, I'll take some examples so that we can understand this concept. Okay, so like, if you talk about PM of some company, PM of some country, okay, Now, this one is going to be surrounded by various guards for the safety. Okay. So now, uh, if let's say that we are having different other PMs as well. So every PM is going to be surrounded by different guards, right? If this is PM1, different guards. If this is PM2, this is different guards. If this is some PM3, some different guards. Okay. So now let's imagine, here we are saying this is the PM of the country. This PM of the country is surrounded by team of some security guards. So if there is only one prime minister, it is easy to ensure the safety because there are fixed boundaries and we have a single point of focus, because we just know that, okay, we have one person whom we want to safeguard. We can deploy our entire security on one place and we will just be putting our major focus there. However, if we are having multiple prime ministers, correct? So in that case, managing security is going to become complex. In that case, we are going to be needing more guards, and dividing the security forces is actually going to be compromising the safety of each prime minister. Like here, if you will see, like let us say here we have 6 guards. Okay. So if you will see in this case, what is happening for one PM, we have 6 guards. And if you will take this, we have 2 guards each PM, correct? That is what is having. So if you will see in this case, what is happening? We are compromising the safety of each prime minister. So, if we will just take this in the form of our application, so you can consider this PM is nothing but our application only. And when you talk about security guards, so these are nothing but our resources. These resources are like something like developers, your time, your infrastructure, it could be anything. So if you have multiple separate applications like the microservices, in that case, you are going to be needing more resources to maintain and secure each one of them individually, correct? Just how we have seen here, like if everything was at one place, everything was only focused at one place. But when we are having it for different prime ministers, everything got divided, correct? In that case, security got compromised. So similarly, if we are having separate applications for everything, so for every every application is going to be requiring some of the resource, and it will become difficult to maintain and secure each one of them individually. However, if we are having monolithic application, if everything is going to be there in one place, in that case, we can put all our focus, we can put all our resources in one application. And then it will be easier for us to even secure and maintain it. So when we talk about monolithic applications, so these are generally more secure because there is only one system to monitor and protect. So rather than multiple, where everything, every component is at different place, instead of that we can keep everything at one place, and that is where we can put our all resources. Okay. Now, what is the second advantage of monolithic application? When you talk about communication, so for there we are going to be needing latency. So monolithic application offers lower latency and faster communication. All right. So what actually happens here, we are going to be having everything at one place. Our front end, our back end, our data storage. So all of that is at one place, right? So what will happen, since all the components are hosted on the same machine, so this will allow direct communication between the front end, back end, and database. In this one, if we want to interact with all the services, we do not need network for that. without the need of network, we can still go ahead and communicate between the separate services. So this, here, what we are actually using. So we are using method to method communication, because in that application we are going to be having separate methods, and every method are just going to be calling each other. And this is also called as IPC, where it stands for inter-process communication. Okay, that is how it is going to be there, because here what is happening, everything is in the same system. So that is going to be reducing the overhead of network calls. And if there are no network calls, so if we are going to be retrieving some data, if we are going to be processing some data, so all of that is going to be extremely faster. So certain times we create some applications which are latency sensitive. What do I mean by that? Sometimes we have some of the applications where we require lower response time. We want responses very quickly. So in such a scenario, monolithic application is ideal. This is going to be serving our purpose, because here there is no network latency between the different parts of the application. We are not going to be requiring network in order to perform the interaction. Since everything is at one place, so interaction is going to be quicker, and that is going to be making our monolithic applications well suited for those applications where performance is critical. So for the performance critical applications, we should always be preferring monolithic applications, because these are going to be giving you results extremely fast. Here the results are going to be super fast. Now let's discuss the next advantage of monolithic application. So the next advantage is easier integration testing. So since here everything is at one place, in this we are going to be bundling our front end, back end, everything at one place. So in this case, whenever we will have to perform integration, that is going to be a very straightforward process, right? And when we will have to perform some integration testing, so that is also going to be straightforward. In this one, we are going to be testing interactions between your front end, back end, and the database. And all of that can be actually done at one place. We do not have to worry about complex inter-service communication or any of the network failures. Generally, when we are hosting our entire code base on different machines, what happens, we are going to be involving network, and in such a case, if network is not up, if we are facing any of the network failures, so in such a case we are not going to have our application in the working state. But here, if you will see, we are not involving any network, so the network failures are not at all going to be there. So this is going to be making our testing faster, simpler, and less error prone as compared to our distributed systems like microservices. So here, when you perform integration testing, so that is going to be just like involving different components, like all the different components written in that same application, in that same code base. So it will be easier for you to go ahead and perform the integration testing. The next one is going to be less confusion for developers. So this is something like we generally do not put more attention to it, but this is one of the major advantage of using monolithic application, that it reduce confusion for developers, especially in such a team where we have varying level of experience. So if you talk about the real world, so not all the developers are going to be equally skilled, or not necessary that they all are going to be staying up to date with the latest technologies. Some may be less familiar with the modern practices or the new architectures, and this can actually result into slower deployment or more mistakes. In such a situation, like what will happen, like let us say we have our front end written in some other tech stack, backend and some other tech stack, and let us say not every developer is well versed with all of those things. In such a case, it will be little difficult for them to cope up with all the requirements, right? So in such a scenario, mistakes are also going to be there, right? But if you talk about monolithic architecture, so that is a practical solution because it is simpler to understand. Since everything is part of one application, so developers do not have to worry about learning multiple systems or technology. They can just focus upon one code base and they can understand entire application more easily. Plus, when you talk about monolithic application, so it is more accessible. So develop, like, if you have developers and if they have less experience or if they are not keeping up to date with the latest trends, still they can contribute effectively because the learning curve for the monolithic systems is typically lower as compared as complex architecture, correct? So if you talk from a productivity perspective, so if developers are spending less time getting up to speed with the system, so they can deliver features and updates more quickly. And this can especially be valuable for small teams or organizations where we will be having some limited resources. Understood? Now we are going to be discussing what are the disadvantages or the challenges of monolithic applications. So here, like, when you talk about monolithic application, where everything is actually built in a single unit, so they can have some benefits, but they will also come with some of the challenges because here, when you are going to grow as your application, in such a case, it will become hard to manage. So let's see what and all are the disadvantages. So the first one, which I have just said, that it will be difficult to maintain. Okay, so like, when you talk about your monolithic application, as they are growing in size and complexity, it will become harder to maintain. So when you talk about multiple developers, so when these multiple developers are working on the same project, they might accidentally make changes that conflict with each other. Example, we have some, sorry, yeah. So example, we have some developer A here. Okay, this person is actually making some changes in the backend. Okay, now we have another developer here, developer B. This person is making changes in the backend, sorry, in the front end. So if these changes are not working together, what will happen? In that case, we may have certain problems, we can have certain conflicts as well, right? Now, if we will have more people working on that project, so that is going to be creating more conflicts, and then it will become very difficult for us to manage and fix that code. So this is a code conflict, and this is a very common problem when we will be working in a big monolithic application. So this is essentially common when we will have different parts of the application which are tightly coupled. So in that case, tracking dependencies, maintenance, and understanding the entire code base can become difficult because what will happen, like, we will be having one project. For that project, we are going to be having multiple people. And if all of them are contributing to it, then we are going to be getting code conflicts, right? So that is what is going to be there. Now let's discuss the next disadvantage of monolithic application. So that is going to be slow deployment. Now, how are we concluding that it is going to have a slow deployment? Like, when you talk about monolithic system, so everything, be it your front end, back end, database, so everything is going to be there in one big application. This means even if there is a small change, like, changing the color of the button, so that is going to be asking you to redeploy the whole application. Let us say for this application, you are in the CSS, you are just changing the color from blue to red. So even if you will see, this is just a small change, but for that also, you need to redeploy the entire application again. So this can take a lot of time. Like, generally the deployments are going to be taking somewhat around 30 minutes of time or even more. So even for a single change, even for a very, like, one word change, then also you are spending your 30 minutes, right? So what will happen? This is going to be slowing down the entire process of releasing updates. And especially when your application is going to grow bigger, in that case, it will be even difficult for us. Now, the next disadvantage is going to be your longer time to production. Or we can call it as less flexible. Okay. So what happens, like, when you talk about a monolithic application, so here your front end, your back end, your data storage, all of that is going to be there at one place. And what will happen? It is actually going to make your entire system tightly coupled. Correct? So what will happen if applications are tightly coupled? This means the small change in one part of the system can create issues in the other part. And because of this, every time something changes, in that case, you will have to test the whole system in order to ensure that nothing is broken. Correct? Let's just take one example here. Let us say this is a developer A. Okay, and this developer A is working on the backend. Then we are having a developer B, and this developer B is, let us say, working on front end. Now, this developer B wants to make some change, but he is waiting for the developer A to complete the change. That can be like, vice versa as well. So they are kind of waiting for each other to finish off their work. Now, there can also be a situation that developer A needs something from developer B, but developer B is busy. So developer A might be stuck waiting for that. So what will happen? This is going to be slowing down the development process, and this will make it harder to quickly make changes or release new features. So as a result, we can say monolithic applications are usually less flexible and they are harder to adapt to the new requirements. That is why we can say monolithic applications are going to be less agile. Now, what is the next disadvantage? That is going to be the single point of failure. Single point of failure. Now, what does this mean? Since everything here in the monolithic application that is going to be running together, if one part of the system breaks, then entire application will stop working. For example, let us say there is some issue with the database or there is some issue in the backend. This can make the whole application crash. Even if the other parts of the application like front end are working fine, but the system will go down because everything is linked together. So this is a big problem, especially for those applications, those are up and running all the time. Like example, payment system or some banking application. So in such a case, if one thing goes down, the entire application will be down, right? But will it be okay? Like, if I want to use some banking application and it will say, I am not available and I don't even know for how long it is not at all going to be available. That is something which is not desirable, right? Similarly, for the payment system, if you are outside and if you want to make payment, but that is down, that is not something which anybody would be liking. So, for such places, monolithic applications are not good. But here, if you talk about microservices, where application is split into smaller independent parts, they are better at handling these kind of problems. Now we are going to be discussing, can we scale monolithic applications? So the question is, can monolithic applications be scalable? So just everyone pause your video and think about it. What do you think? Can we scale monolithic applications or not? Since here everything is bundled up at one place. Okay. I'm sure you guys must have paused the video and tried to think about it. So the answer is yes, monolithic applications can be scaled, but there are going to be certain challenges. Those are going to be coming with scaling. So let's break it down. Let's take the example of Times of India. Now you know this Times of India is a monolithic application. Correct? Now, when it was first built at that particular time, this app was designed to publish some basic news. All right, and that is like you're just printing some logical news, and that is something which is limited to a small audience. But in early days, not many people use that application, so it all worked fine with a smaller user base. But now, if you will see, like even if everything was at one place, so it was all okay because previously we had less number of users for that. But if you talk about, like let's say some intern is joining the Times of India. Okay, now let us say this intern has some great idea. He's saying let's add some spicy news as well. So previously we just had some basic news. Now he's saying let's add some spicy news as well. What do we mean by spicy news? Something like some gossip, some sensational stories. And he also said that okay, like previously we just had some of the basic news. Now let's add some images as well. And let's try to just make some content more engaging. So this idea was something which everybody in the organization liked. So this idea quickly became popular. And initially, like if let us say previously we just had a smaller code base, smaller user base. Now that grew with time. So now we are having more number of users. Now, what actually happened when more and more people started subscribing to it? Times of India saw huge growth in users. As the number of users grew, Times of India started facing problems. The application was not built for that level of traffic. It was designed for a much smaller user base. So the application could not handle the increased load. To handle this, Times of India moved from using one server to using multiple servers. So previously we just had one server where everything was deployed. Now they are using, sorry, now they are using multiple servers. So we are using multiple servers so that we can share the load. And there is absolutely no problem with this approach in the monolithic application. So previously, when this place had all of those three components bundled up at one place, your front end, your back end, your DB, everything was there on one machine. Now, instead of keeping it only at one machine, we started using multiple servers, which means now you're having multiple machines. And like, when you perform such kind of splitting, like instead of keeping everything at one place, now we are making use of multiple machines. So this is what we go ahead and call it as horizontal scaling. So when you talk about horizontal scaling, what does that mean? It means spreading the load across the different servers. And when we try to do that, what we do, instead of keeping everything at one place, we are now going to be keeping it at multiple places. So this is definitely going to be helping with scaling the application, especially if the number of users are growing. But there is a catch. While horizontal scaling helps, but selective scaling is not possible in monolithic application. Selective. Okay. So why that is happening? If you talk about Times of India, so that is mostly read-only application. Here, the content means the news that does not change much after it is loaded on the front end. So even though we have more number of users, even though we have increased in the number of users, the backend part where we are writing the business logic and the data processing logic, so that part and the database, they are not getting any bigger load because that is still going to remain same. The load was mostly on the front end because more users were reading the news. So ideally, Times of India, they would have only scaled the front end so that whatever the increased traffic is there, they can go ahead and handle that while keeping the backend and database same. But since this is a monolithic application, so everything is bundled together. So even if you want to scale one part, that is the front end here, you are scaling the entire application, including the backend and database. So even though we were not having heavy load on the backend and database, still we were scaling the entire application. As a result, what will happen? Here we are going to be experiencing higher cost and complexity. So instead of scaling that part where we needed it, we are scaling the entire application. So what is the main challenge here is that we cannot go ahead and scale the monolithic application. Like if you want to do only one part of the application selectively, like if we are selecting that, okay, I want to scale the front end, or if I want to scale the back end, that is something which is not possible in the monolithic application. With the monolithic application, everything is tightly coupled. So you need to scale everything together. So even if only one part needs more resources, then also we are scaling up the entire application. So what will happen? This is going to be resulting into inefficiency and higher cost. In order to solve all of these, we are going to be coming up with the another architecture. So the first architecture which we have discussed is the monolithic architecture. Now we are going to be discussing another. So that is going to be the SOA. SOA stands for service oriented architecture. Now what happens in SOA? So in this one, we are going to be here our application is going to be having a clear separation. So here we are going to be having one part which we call as service requester. And the other one we are going to be having, which we go ahead and call as service provider. So these are the we are actually having two things here, the service requester and the service provider. So when we are designing service oriented architecture, what we are doing, we are designing our applications in such a way that they can communicate with each other over the network. Like the service requester and service provider, they both are going to be there on the network and they both are going to be communicating with each other. So if we want to perform any of the operation, so they both are there. These are the key components of our key components of our SOA. Okay, and if they want, they are going to be communicating with each other over the network. So here, if you will see, if you want to have any kind of communication, this is the setup which we are going to be using here. Now, what is the service requester? So, this is actually going to be requesting for a service or some functionality. So when we talk in the context of service-oriented architecture, the service requester is going to be sending a request to the service provider over the network. As a as a request, it is going to be sending it out. And what service provider is going to be doing, it will receive the request and then it is going to be providing the requested service or the functionality. So after receiving a request from the service requester, the service provider is going to process it and send the result back to the requester. So when we talk about the SOA setup, so both your service requester and the service provider, they both are going to be having their separate code base. So we are going to be having some different set of codes there and they are going to get deployed on the different machines. That is how I have even represented it here. When a service requester is going to be needing something, it is going to send a request to the service provider over the network. The service provider is going to process the request and it is going to be sending the response back to the requester again over the network. So if you will see, both are communicating with each other over the network. So if you talk about it, so what it is, this is a system where we have two separate entities which are communicating with each other in the form of request and response. And how that communication is happening, it's all happening over the network. So if you talk about SOA in real life, I'll just give you one example here. You guys can also think what and all it could be there. So if I talk about me. So right now, if I talk about this scenario where I am a teacher, you guys are the students. So me, I am actually providing you a service. So I am the service provider. I am explaining you this concept to you, correct? And you guys being the students, you guys are actually going to be the service requester. Correct? So if you will see, you guys are requesting for a service. What is that? You want to have knowledge on the system design from me, and I am providing that knowledge. Means I am providing that service back to you. So we all are connected over the same network. In this case, internet. Correct? So we all are connected over the internet, but you can just see that. Okay. Here, this is the scenario. But if you talk about the another scenario where let us say this is me and I am having a house help here. Now, in that case, if you will see, I will become the service requester and they are going to become the service provider. Now, how it is actually going to be there? So when my house help is going to arrive at my home, I will become the service requester because I need their help. And they are going to become the service provider because they are providing service to me. So depending upon the situation, the same entity can act both as a service requester and the service provider. Now we are going to be discussing some impact of SOA. So when you talk about SOA, what impact it is going to be leaving on some web application. So when you talk about web application, how the layout is actually going to be there. So you are going to be having some front end, you are going to be having some backend, and you're going to be having some data storage. Now, all of these things are going to be connected over some internet, correct? But we can say they are going to be connected over some network. That is how basically it is going to be there, right? So when you talk about a typical monolithic architecture, so what will happen in that case? Everything is going to be bounded together in one single unit only. Here we will have our front end, back end, and data storage. So that is how your monolithic is going to be there, correct? So if you will say here, what do we have? We have some tight coupling, correct? Because here everything is bounded in one single unit. So in this case, generally, that is not something which is encourageable. Nobody advises you to keep everything in that form because tightly coupling is something which nobody prefers. So in this one, everybody will say that instead of keeping everything at one place, why don't you break it down? So what SOA said that let's just separate out the front end. So whatever the user is seeing, keep that part separate. How the application is working, the core logic, the backend, keep that one separate. The placeholder where we are keeping our data, the data storage, we are going to be keeping that one separate. So all of these three things we are going to be keeping separate. And each of these part are going to be having their own code, and we are going to be deploying all of them separately. So these are going to be independent from each other because we are keeping every part separate. Now, what is actually going to be happening? So this is going to be making it easier for us to update or change one part without affecting another. If here I want to make some change in the CSS, if I want to change the color from red to green, if I want to modify this change, in such a case, what will happen? I will only be redeploying the front end part. I am not going to be touching the back end and data storage part. So if you will see here, we have different layers and these layers can communicate with each other over a network. So that is how we can go ahead and scale our application. When we are going to be separating these layers, we can still work on all of these things, correct? And when we are going to be working on all of those things, that is going to be independent of each other. We, let us say we are getting some load on the front end. So instead of scaling the entire one, we can go ahead and selective scale only one part. So if we will have to scale the front end, we do not have to worry about the backend or the database. So this is going to be reducing dependencies, and this will make it easier for us to make some changes or add some new features. Now, if you talk about it, here all the layers are independent, correct? And they can communicate over communicate over network with each other. Now, the backend service which we are having here, that can be reused by the other applications also. Like, let us say in our application, front end is something which is mostly used. And backend we have written some of the logic which can be used by different applications, not just by that application. So that is something which we can do, right? Similarly, let us say in the data storage, we are storing some data which can be consumed by two different applications. So what we can do, we can go ahead and share it. We can reuse it. So in simple terms, we can say that SOA is going to be making the application more flexible, scalar, and easy to maintain by separating it out into different parts, and we can allow each of these parts to work individually. Now, let me just quickly take that example which we have discussed when we were talking about that Amazon cart, right? So let me just quickly take that part. Yeah, this is the one which I was talking. Let's just go and take it. Just saving time so that we don't have to draw it all over again. Yeah. So now, if you look here, what we were actually doing, in this case, we had a user and that user was making use of this entire service. So now with the help of this example, we are going to be understanding why do we have to use SOA? What are the advantages of that? So here, I'll list down all those advantages as well. Now, what is the most, just now I told you one thing, like let us say you are getting more load on the front end. So what you will do, you will go ahead and scale that part. So what is the first advantage which we see here? That is selective scaling. So with SOA, you can just go ahead and make one part of the system bigger, or you can say you can just go ahead and scale one part if it is getting too busy. So if you talk about this entire setup, so like let us say in this one, this payment service is actually getting so many requests, because it can happen, like let us say it is some sale time, and in such a case people will be placing multiple orders. So in such case, this payment service is something which is going to get too consumed. So if this payment service is getting too much request, in that case you can go and make just that part scalable. In that case, you are not going to be touching the remaining services, we are only going to be touching the payment service. So this way we can go ahead and save our money and resources as well. The next advantage of this is, like, here we are keeping all the three components separate. So if we will be keeping all of the components together, in that case we will be having tight coupling. But if we are going to be keeping all of these components separate, then we are going to be achieving loose coupling there. So when you talk about SOA here, we act like, the different parts, the front and back end and data storage. So they do not depend upon each other. If you are making some changes in the front end, so only front end is going to get impacted. The rest one are going to be untouched. So that is how we can say that if one part or one service is going to change, like in this case, let us say I only want to make some changes in the checkout. If here something is like, or let us consider here something is breaking, it is not working. So in that case, it is not going to affect the others. It is just like a team where everyone is just playing their own game without worrying about others. I can also take the example of a classroom setup. Let us say you guys are watching some video online, some online classes there. Let us say one person is losing its network. In that case, it will not happen that everyone will stop watching the video. Only that person will be impacted. So that is how it is actually going to be working here. Yeah. Now we will be looking into the next advantage of SOA. So the next one is faster deployment. Now, like I said, that let us say I want to only change the CSS part. In that case, only front end is going to get redeployed. We are not deploying the entire application, since in this one we are dividing our system into smaller services. You can go ahead and update or deploy just one service instead of the whole system. So that is how it is going to be making all the updates faster and easy. The next advantage of SOA is more flexibility. So when you talk about SOA, so here it is going to be letting you use different technologies. Here you can go ahead and use different programming languages or tools for the different parts of the system. Like if you talk about let's come back here. If you talk about one service, like let us say we are talking about authentication service. Let us say here I want to use Python. If you talk about inventory service, let us say here I want to use Java. If you talk about shipment service, let us say here I want to write the code in C sharp. So that is how, if you will see, even though this is one project, but I am breaking down all the services into different languages based upon my requirement. That is how I'm adding a flexibility. So this flexibility is allowing you to pick the best tool for each job. If I will feel that, okay, in the authentication, I will be running more scripts and Python is making more sense. So we can just go ahead and implement that service in that programming language. So that is how it is going to be there. Now, the next advantage is your agile development. If you remember, when we were discussing monolithic, I clearly said that here you cannot go ahead and apply agile here. And that is because of the tight coupling. But here, if you will see, what we are doing, we are breaking the entire system into smaller services. So different teams can work on different parts at the same time. And this is also going to be helping the project to move faster and be more flexible to the changes. Now, like, if you talk about all of these advantages, so these were typically the disadvantages which we had in our monolithic system, and because of those disadvantages, we came up with SOA, which actually overcame all of those challenges which we were facing there, and it turned all of those challenges into its advantages. But again, this is also going to be having some of the challenges. So let's discuss what are the challenges of SOA. So what is the first disadvantage? That is overkill for small applications. Now, let us say I even took this example, like let us say you're building a small application. You are only doing the POC, proof of concept. In such a case, SOA might be too much, because in such a case, you are going to be setting up multiple services, multiple networks, connections, and all of those things are going to be adding some unnecessary complexity and cost for the small project. So whenever you are building a small project, in such a case, if you are proceeding ahead with monolithic architecture, so that is going to be making more sense. Okay. Now here we are going to be having high latency. Or we can also go ahead and say that here we will be having some slower communication. Now what will happen, like if your application is actually requiring some fast response and low latency, in such a case we should not be going ahead with SOA. Now why? Here I told you we are going to be having some different components which will be interacting with each other over a network. So if a client needs some data from multiple services, they will have to talk to each other over the network, and each service has to send some requests and responses across the network, which can be slower as compared to a monolithic application, because in monolithic everything is in one place and they can communicate with each other more quickly. So here the extra communication which we are building between the services, because they are at different locations and we are communicating over network, so that can increase the time it is taking to process a request, and that is actually going to be resulting into higher latency and slower performance. Now the next disadvantage of this is complex security. So if you talk about security, if security is something which is your top priority, where security is utmost important, in such a case, you should not be using SOA, because here, generally, you will have some limited resources, and with those limited resources, it will be difficult to manage everything, correct? When you talk about SOA here, we will be having multiple separate services which are going to be communicating with each other. Now, every service is going to be secured individually, correct? Now, this is adding complexity because each service requires its own measures, just like everywhere we are performing some authentication and authorization. So if we are having more services, that means we are going to be having more points to secure. It means we are going to be getting more chances for the things to go wrong, and more security risks can also be there. So this is going to become complex, time consuming and expensive to manage. So because of this, we can actually have some security breaches as well. So if security is your concern, please avoid SOA. The next one is difficult to test. Now here, like let us say we are having one application and that application is requiring some deep testing, some thorough testing, some simple testing. If such a case is there, in that case, we should be avoiding SOA, because when you talk about, in SOA, what exactly we are having? We are having a distributed system where all the services are distributed, all the components are distributed. So in such a case, testing such a system is going to be complicated and challenging, because SOA is going to be having multiple services which are going to be running on different servers or machines. So it will become harder for us to check if everything is working perfectly or not whenever we are going to be testing. Now we are going to be discussing, one example based upon the challenges which Instagram faced. Okay. Now I'm just going to be discussing one of the scenario. I don't know how many of you actually noticed, but this is something which happened sometimes back. So if you guys remember, there was a time frame where Instagram was down and it was all over the news. I guess this was back in 2021. I vaguely remember, but it was quite it was down for quite a lot of hours. Now I'll be discussing what exactly happened and why we encountered such a situation. So Facebook is a global leader in the technology. And what Facebook did, it acquired Instagram. So when they acquired Instagram, they faced some unexpected testing challenges. So even though if you talk about Facebook, so here also we use SOA, and in Instagram also we use SOA. So even though both of the companies are using service oriented architecture, so Facebook is still is a top leading, you can say, a large scale, a global distributed organization that already developed some of the custom testing engine. Okay, so the Facebook already had some custom testing engine. So why they were using it? Because they knew that we are growing in our size and they wanted to ensure that they have stability of its system. So that is why they came up with this custom testing engine. This Facebook testing engine was developed so that they can perform integration testing across their distributed system. This tool was intentionally, with the help of this tool, what they were doing, they were intentionally bringing down one machine down at randomly. And with that, they were testing how well the system is handling failure. So if we have some multiple machines, so out of that one, they were intentionally putting it down and then they were saying if that is happening, how the rest two are going to be handling that failure. So what Facebook did, Facebook deployed its service across multiple machines, and all of those machines like these ones, so they all are connected over the network. So during testing, the engine randomly shut down one machine just to ensure that even if one server fails, the rest of the application should continue to function smoothly. And why they were actually doing this? So the primarily aim, the primary aim behind this was to make sure the application still remains operational even when individual parts of the system is failing. So this was helping that is Facebook highly available or not. And why we were checking it, if you talk about the social media applications, what is the one thing which we look in such applications? That they should be highly available. If we are bored, we just want to open the application, we just want to scroll down there. So what we want as a customer, that it should be always available. So when we apply this kind of testing, so that is going to become a complex testing framework, which correct, because it is quite complex. Generally we do not do such things, but here we have introduced that complex testing framework so that we can maintain high availability and we can minimize downtime. We can maintain high availability and we can minimize downtime. Now, what actually happened when Facebook acquired Instagram, he thought that whatever custom testing engine we have here for the Facebook, let's apply the same testing engine to Instagram infrastructure as well. Because they thought that they both are using the similar architecture, so it will be pretty much similar to apply the same testing engine here as well. But it did not go smoothly as expected. When Instagram also used SOA and had global presence, it had not developed a similar robust testing infrastructure. So what happened once the Facebook testing engine was applied to the Instagram, it randomly took down several nodes in the Instagram network. So here we were only doing it down for one, but in Instagram, more than one got down. So as a result, what happened? Instagram was down for 4 hours. You can say more than 4 hours. Okay, so because of that, we had that huge downtime, which actually became a major embarrassment for the company. And why it actually happened? So the root cause was that Instagram had not properly tested their distributed system in the same way Facebook had. So even though Instagram followed SOA, testing a distributed system, especially with multiple services and nodes, is quite complex. So without an effective testing setup, issues can easily arise that might not be caught or easily go undetected until they affect live production system. So all of these things can actually happen even in SOA. Okay. And here, we have discussed this difficult to test. Now the next disadvantage is more confused developers. Now, previously in the monolithic, we were only using one technology across. So every team was just focusing upon one technology. But here, if you will see, we are using multiple technologies. So when your team has less experience, or if your team is not familiar with a lot of technology, in such a case, we should be avoiding SOA. Because in SOA, different services may be built using different programming languages and technologies. Like I said, it can happen that one service might be using Java, another one might be using Python, another one can be using C Sharp. So this can be confusing for the developers who are not familiar with all these technology. So if your team is not experienced in managing multiple tech stack, it can be hard to keep everything running smoothly. Now, another disadvantage which we have here is constantly changing communication protocols. Now, let us say you do not want to deal with the complexity of evolving technology. In such a case, you should not be proceeding ahead with SOA, because what happens in SOA, you are going to be having some front end, you are going to be having some back end, you are going to be having some data storage. Now, if this back end wants to communicate with the back end, how it will be doing over the network, correct? But here, what initially people were using in order to have this network communication. So previously they were using soap there. Okay, because what they have seen over the period of time, the ways in which services were communicating with each other, that has changed. So previously we were using soap means simple object access protocol. All right, but this has been largely replaced by REST. This REST actually stands for your representational state transfer. All right. And eventually, this got even replaced by gRPC. So, in this one, like what gRPC is, that is your Google Remote Procedure Call. So like everything is evolving, even how we are going to be making the communication, that is going to be also be changing with the time. And recently this GRCP is gaining more popularity for its performance and advantages. So if you are using SOA, in that case, you will need to keep up with these changes in the communication protocol. Whenever we are going to be making some shift in the technology, that is going to require you to adapt your system and possibly update your code so that you can stay compatible with the new standards. So if you are having some of the projects that do not require this level of complexity, or it is not going to be involving some constant updates, in that case, the frequent changes in the communication protocols can be a headache. So the efforts which we are going to be needing here to keep up with the evolving changes, that can become difficult. So I hope you must be clear with all the disadvantages. Now I will be quickly discussing what is the difference between the microservices versus the monolithic architecture. So, when you talk about microservices, so that is something which is becoming a buzzword. That is something which is becoming a hot topic because that is something which everybody is just talking about. Everybody is just hearing about it in the tech industry these days. So people will be mostly like, talking about them like they are the like, these microservices are the next big thing. So they talk about that it is the future of the software development. And people will also be asking questions like, are you working on microservices? Or are you still stuck with monolithic? Like people are going to be asking certain questions as well. But trust me, you do not need to feel that microservices is the good choice and monolithic is the bad choice. It is important to remember that both microservices and monolithic architectures have their own strengths. We have just only discussed what are going to be the strengths of SOA and what are the strengths of the monolithic. Like we have also discussed what are the disadvantages for the same. So depending upon the use case, we are going to be picking that. Okay, so there is nothing to feel like microservice is the best solution. Each approach works well in different scenarios. So both architectures are going to be useful in the different scenarios. So is microservices really something new? So let's check if it is something like, a new term or something. So let's check if it is worth the hype or not. So when you talk about microservices, this is what? This is nothing but the more advanced form of SOA. You can say the SOA got evolved and it turned into microservices. So is microservices really a new technology? So microservices are not a brand new idea. It is nothing new. So in fact, like, these are the advanced or the evolved forms of SOA. In order to understand this, let us think that how human civilization has evolved over the time. We started from somewhere and over time we are evolved and developed new ways of doing something. Like initially, if you talk about the human civilization, so initially we had monkeys, then we had some early mans, then we had some humans. So you can see over the period of time only the human civilization has happened. That is how this human civilization has happened over the period of time. Similarly, if you talk about this situation, so this microservices, so that was also something which has already been there in the form of SOA, and then SOA has evolved into microservices. Now, the main goal of SOA is to break the application into smaller and more manageable parts where each part had a single responsibility, just like how we have our single responsibility principle. So, microservices are simply more granular version of SOA. It means they take the idea of SOA, break it down into smaller and more independent services, because what generally happens if you have a bigger application, of course that is going to be adding more complexity. So what we do, we just try to break it down so that it is going to be more usable. Now we are just going to be seeing how microservices are different from SOA. So like, let us say that in SOA we are having three services: service 1, service 2, service 3, and these services are communicating with each other over network. All right. So here, if you will see, since they are communicated over network, so this is also going to be adding some dependency there, correct? And because of that, like, if you will see in SOA, what we say that we are going to be having different services and each services should have a single responsibility. And they, like, if they want to communicate, how they will be doing over the network, correct? So when you talk about SOA, what we have done here, like we tried to add some flexibility. We said that a service one might have its own database, like, we'll be just extending this only. Like, since we are having three services, this part is still, like, they are communicating this way. Now what we will say that it can happen that these both services are going to be using same database, and this service can have its a separate database. Now, even though each services are independent, they can still share a database. So if S1 and S2 are sharing a database, we can say that they can have, like, if S1 is writing, they can actually have some performance issue. How? Like, let us say if S1 is writing something to the database. In such a case, S2 can experience some slowness. S2 can experience some performance issues because they are somewhat dependent on each other. The shared resources means there is still some coupling, correct? And even though they are separate, but still they are going to be having a dependency there. So this is where microservices take a different approach. Yeah, so now let's see what happens when you talk about microservices. So in the microservices, the rules are going to be little much stricter. So if we have three services, S1, S2, and S3, they will be 100% independent of each other. Every service is going to be having its own database, like no sharing. And every service is going to be having its own lifestyle, and that should not be dependent upon the life cycle of another service. So this means that each service should be able to start or stop or update without affecting the others. So when you make services that is independent, you achieve a higher level of granularity. You achieve flexibility. So microservices would require that each service should be fully isolated with no shared database or dependency. Each service can be scaled, updated, or deployed separately. Here we actually have complete independence. With the help of that, we ensure that there is going to be no impact between the services. So if S1 is going to go down, in that case, S2 and S3 will still run to continue smoothly because they do not rely on the same database and resources. And here, like, everything still they are connected with each other over the network. But the major thing is they are not sharing any of the resources. They all are acting like mini applications. Here we have three mini applications. So here we can say that although they are connected, but these three are actually going to be separated from each other. All right. If you really want to understand it in the terms of some real life example, what you can consider when you talk about SOA, let us say you are having two siblings and each of one them is given a toy by your parents. Like, for both one item we are giving, okay? Because since they are siblings, so parents usually think that they can share that toy. But what happens if one person is using it, the other one has to wait. If the other one is doing, the first one has to wait. They can even have issues there. They can even fight over that, correct? Similarly, when you talk about the same in SOA, services might share a shared database, and one service action can affect the performance of the another. So that is how SOA is going to be there. Okay. Now, if we talk about microservices, what will happen even though you are, let us say, you are twins, you and your sibling, you both are in the same class. But if you talk about school, generally schools are very strict in these terms. There the teacher is going to be expecting that both of you will be bringing your own notebook, your own set of materials. So every student should be having its own resources and nothing is going to be shared. In similar way, if you talk about microservices, so each service is going to be having its own resources and it is going to be independent from each other. So I hope this must be clear to everyone. Now we are going to be meeting in the next module. Till then, happy learning. Bye bye. Hello everyone. In this module, we are going to be learning about distributed system. So firstly, we'll just quickly discuss how we perform the communication between applications in the SOA. So when you talk about SOA there, if we have some application and if you want to communicate, if you want both of them to communicate with each other, we are going to be using a lot of services. We are going to be having some set of services and they are going to be having that interaction over the network. Okay. So when you talk about SOA, every application is going to be considered as a service. And we are actually going to be having two types of services which is involved in the communication. So the first one which we will have here is going to be your service requester. You can also call it as data requester. And the other one is going to be the service provider, or you can say data provider. So that is how it is going to be there. Now, when you talk about service requester, so this is going to be making a request for the data. So it will make a request for the data and the service provider is going to reply back with the requested data. So that is how it is going to be there. And all of these things is actually going to happen across a network, right? So that is how it is going to be there. So whenever these services are going to interact, the primarily function is to transfer the data between them. And this data transfer can be in two ways. We can have it in unidirection or we can have bidirectional. Now, what do you mean by unidirectional? This means you are going to be transferring your data in one way. And when you talk about bidirectional, here you are going to be having two-way data transfer. So like I'll just quickly take one of the example of each so that you can understand what I am actually meaning by that. Now, let us say you are you are one service and there is another service S2. If you want to send some notification, so that is what you can do in one direction only because you are only sending a notification. You are not actually involving any reply there. But if you talk about bidirectional, like let us say we have two services and let us say some cricket is happening, some cricket match is happening. So what S1 will do? So this one is going to be checking the score. And what will happen? The S2 is going to reply back with the score. Because generally if you have seen if any match or anything happens, so generally on the phone and all people will be just keeping an eye on the scores. So here if you would have understood what we are doing, we are performing a two-way interaction because in this case your S1 is requesting the information from S2. S2 is processing the request and it is sending the data back to S1. So this interaction is essentially the core how your SOA is going to be interacting with each other. So if you talk about today's world, here data is everything, correct? So if you talk about your mobile phone, if you talk about your laptop, if you talk about any software application, everywhere your data is going to get involved. And what these applications are basically doing, so these are processing some data in forms of some crunching and munching. So they are taking the data, modifying it, and then providing you the reply there. So that is how it is happening. So when you talk about the software oriented architecture, so if you will see that we are actually performing transfer of data only. So in this one, what is happening? We are performing transfer of data only, correct? Because this one requested for the score, requested for some data, this one replied with the data. So if you will see what actually happened overall, some transfer of data only. So this is how the communication is happening here, correct? This SOA, like, when you talk about SOA, so this is actually built up upon transfer of data only. So when we will be having some communication between the application, that is going to be some sending and receiving of data on the internet. So when S1, is requesting some data from S2, and when S2 is sending it back to the S1, so there what is happening? There is some data transfer. That is what is happening here. So when two services, if they are communicating with each other, if they want to communicate with each other, if they want to talk to each other, they are going to be using some set of protocols. Those are going to be involved so that they can send some data back and forth. But what were the main challenges? That was in figuring out how services are going to be built with different technology and they can still communicate. So one solution for such a problem was RPC. So what RPC is, that is your remote procedure call. So what was exactly happening here? So in this one, we are providing you a way so that you can go ahead and run your code on different servers. So even if server is far away, but still you will be able to run your code there. But there is a downside of RPC as well. That is, both of the services need to be built using the same technology. For example, if you are having some service, let us say SA, if that is built using Java, and if you are having another service SB, so that also has to be built with Java in order to make them work on RPC. That is what is the one of the setback about it, the downside about it. In order to solve the problem of services not being able to communicate across different technologies, SOA introduced SOAP. What is SOAP? SOAP stands for your simple object access protocol. So, in order to solve the problem of services not able to communicate with each other, we came up with SOAP, and SOAP was a game changer. SOAP was a big improvement because it allowed communication between services written in different technology. It kind of acted like a translator between the application. So, what exactly happened? Let me take some real life example. Like, let us say this is you, and let us say you're traveling to Japan. It doesn't matter that you know Japanese or not. You can still have the option of either you can hire a person who can act like a translator so that whatever you want to tell to this guy, you will first tell this to him and he will tell it to this guy. Otherwise, you can make use of translator app. So you are going to be writing it here and showing it back to this guy. So that is how the translation is going to be acting. So similar way, when you talk about SOAP, so that is also acting like a translator between application, and that is also making it possible for different applications to communicate with each other even if it is written in different programming languages. So even if you talk about the same, this translator example in the world of programming, so there also if you will see what SOAP is doing, SOAP is acting like a translator. So let us say we have our service A, which is written in Java. If you have a service B, which is written in .NET, what is happening? Here we are using SOAP, and with the help of SOAP, we are exchanging data. And how that is happening? We are converting our data into a common format, which both of these services can actually understand. So generally, in order to perform that, we are going to be using some language like XML. XML stands for Extensible Markup Language. When you talk about XML, so that is technology neutral. It means that it can be read. It can be understood by different programming languages. So SOAP is going to be using XAML to make sure that services, like, if we are having services which are written in the different languages, still they are able to communicate with each other. Still they are able to understand with each other. Now we will see how SOAP is actually going to be working. Although I said that if we have two services and if they both are using different languages, still they be able to communicate. So what is going to be the step one here? So here, if S1 is sending a SOAP request, like, since I want to communicate, so what will happen? The SA is going to send a SOAP request. Okay, and now how the request is actually going to be there? So this is going to be there in the form of XML document. Correct? Now what will happen? This request is going to get received by S2. So S2 is going SB is going to be receiving the request. And how they are going to request it? They are going to be receiving it in the form of XML document. So if you will see, in both of the cases, we are using a sorry. S2 is going to receive a SOAP request, which is there in the form of XML, correct? Now what S2 will actually have to do, S2 is going to be sending a response back, okay? And when it is going to be sending a response back, it is again going to be using XML document for the same. So if you will see what is exactly happening, if we are having some services SA, SB, if SA is sending a request for something, if some request is going, so it is going in the form of some XML document. After that, if a request got received here, if it wants to send a response back, to send the response back again, we are going to be making use of XML document. So what these services are basically doing, they are receiving the XML document. All right, and after that, what they are doing on that, they are performing some processing. So that after the processing, we are going to be getting the data which we were initially looking for. So that is how it is going to be working here. So when you talk about SOAP, so what SOAP is doing, it is simplifying the complexity of making different applications interact. It is handling the technical details so that developers do not have to worry about the differences in the system. Like, you do not have to manually send a request in XAML. The SOAP is taking care of that. So SOAP is enabling a seamless communication between the services regardless of the programming language, the technology in which they are going to be built. SOAP provides a standard way for the services to exchange messages using XAML, making it possible for the systems to communicate across different platforms and technology. So if you talk about any communication, we are going to be using some networking protocol. Okay. So when we are going to be using this networking protocol, like, why are we going to use it? So that we can establish a connection between the services. And what are the common networking protocols which we will be using? One is TCP, where it stands for Transmission Control Protocol. The other one which we have is your HTTP. So this HTTP stands for Hypertext Transfer Protocol. The other one which we have is your UDP. UDP stands for your User Datagram Protocol. So when you talk about all of these protocols, so these ones are going to be operating on the network layer. So where these ones are going to operate on the network layer. Okay. And these ones are going to be ensuring that your data is transferred over the network. However, the actual communication between the applications such as SOAP messages or other data formats are going to occur at the application layer. So when you talk about the protocols like your TCP, HTTP, UDP, so these all are your networking protocols. And at the end of the day, when we are performing some communication, then first of all, we will be needing a protocol to establish that communication, to enable the applications to interact with each other. And at the end of the day, we are going to be needing something which we call as networking protocols. So, however, networking protocols work at the lower levels, dealing with how data is transmitted over the network, that is the network layer. So, what we are discussing here is how two applications communicate with each other at higher level, how the two applications are going to be communicating with each other at application layer. So, when SOAP was first introduced, it was a big breakthrough. People were very excited. They were very happy that with the help of SOAP, it got all possible for us to make different applications written in different programming languages communicate, because there we were just only using XML and that was working fine. So at first it worked well, but over the period of time, people began to notice some problems with. So they started complaining, just how when we meet a new person, initially we are not going to see any of the issue in them, and we are going to like them for each and everything. So similarly, like, when any product is launched or when any technology is launched, so people are only going to see what problems they are solving, how they are good, but eventually they will start complaining about them as well. We will start noticing, like in the human, we start noticing some shortcomings. Similarly, with the technology and the gadgets, we also start seeing some shortcomings and we start complaining about it. So when you talk about soap, so soap was very heavy, soap was very complex, heavy, soap was very complex, soap was very slow. Why it was all of that? Like I said, in SOAP, we are going to be using XML. So if you know, in XML, we create our own tags based upon the requirement. So what you will do, you're going to be creating, like, just taking some dummy variables. So like, let us say you want to send uh, some message. So then you will be selecting something like to sender. You will provide some information, then closing tag. Then from, then again, you are going to be putting some data, then some value, here it will be there, some date and time, you are going to be putting date and time. So if you will see, in order to process some simple information, this is the information, and if you will see, we are adding some starting tags and some closing tags. And this is actually going to make our class go heavy, because here we are having a lot of opening and closing tags. So that's how you can understand why I'm saying it is heavy, because we are actually going to be adding a lot of unnecessary information. Similarly, I'm going to make it complex. Why complex? Here, if you will see, for every opening tag, I have a corresponding closing tag. And if I am going to be skipping one of the closing tag, in that case, it is not going to work correctly. So I'm adding the complexity, because these things are not even going to give you any error. If you are going to build, it is going to build successfully. Last one is slow. So since it is heavy, if you are sending, like, if you talk about some heavy data, so if you are sending that out, it is eventually going to become slow over the internet, right? Why I'm taking this reference? So like, let's talk about some old times. So previously we had RAM of somewhere around 256 GB. MB, sorry. Like, talking about extremely old times. So that much RAM we were having, and that time it used to be fast. But if you will look at today, so even if you are having some 16 GB, like, in my laptop, I actually have 64 GB. If you talk how much transition this has happened, previously we had it in MB, still that was working so much fine for us, but now it is becoming slow for us. Similarly, if you talk about mobile phones, so previously they all were coming with certain amount of MBs. I even remember I bought one phone which actually had 128 MB only as the storage. But if you now look at today, I have 256 GB phone, and that also looks like lesser in storage, because these days the data is evolving. We have a lot of things to keep in our phone. Yeah, so when the data started growing, even the phones with lesser storage started causing problems. So similarly, when you talk about soap, so why I actually took this example, so that we can relate it with soap. So initially when soap was introduced, so at that particular time, although it was using multiple languages, still people were happy using it, because initially it was quite fast. And that was because less number of peoples were using it. When more people started using it, of course, we were also transmitting more data, and that particular time we started seeing that it is slow. Now better I'll represent fast with less users, and this turned slow with more users. So that was the thing why soap actually became slow. So people started complaining that soap is slow. At the same time, we say soap is slow. At the same time, it was complex. And why it was complex? That was because we were involving XML there, your extensible markup language. So in this one, this is your uh, this is actually going to be involving a lot of your tags. So if you are not going to be ensuring that you are having correct opening and closing tags, in that case you will be facing some of the issues. So that is why your XML is actually complex, because if you are missing one of the tag, the whole XML is going to lose its meaning. At the same time, since I said we are going to be dealing with a lot of tags, so that is going to be eventually making your soap heavy, because we are actually having a lot of data. Like it will be having, like here we have discussed, it will be having less data which we want to transfer, but it will be having a lot of tags which are also getting transmitted for no reason. So because your soap is so much dependent upon XML, because it has its entire dependency on XML, so that is why soap became slowly it became unpopular, because here what we are using XML. And when we talk about XML, here we are going to be having a lot of tags. And also when we talk about XML, so XML is your language neutral tag. Like by what do we actually mean by that? If we talk about any other languages, C sharp, Python, Java, so there we are going to be following a specific syntax. And even if, like, let us say you are writing some string like this, or if you're writing with S capital, so they both are going to be having a different meaning. And if you talk about list, so generally we define it like this, but even if you will write it like this, so this is going to throw error, because here we are going to be dealing with a lot of tags, and we want it in that specific manner only. So that is why we say XML is your language neutral. And when we talk about language neutral, one thing also which we add there, that is it will be easy for anyone to read and understand. Here we are going to be using XML so that we can read and process our data. So initially when SOAP was introduced, it relied on XML so that you can have communication. And when you talk about this communication, so here we are going to be having different applications, and all of those applications are going to be interacting with each other with the help of XAML. So even say, like, let us say you have some of your application one, and that application is built in Java. Let us say you have your another application, let us say application 2, and let us say it is built in Python. Let us say you have your application 3, and let us say this is built in C sharp. So if you will see, all of these applications are different. Still, if we want to provide a communication, how we will do? With the help of XAML. So XAML is going to be providing communication between the applications. And if you talk about interoperability, So SOAP also allows that, because what is the core concept behind that? That no matter in which language your application is going to be written, we should be still providing the support across different languages. So even if we have one of your application which is going to be written in Java, and if you will have your another application which is written in, let us say, C sharp. So even though the languages are different, but still they both can interact with each other over the network. And how it will and how all of that will happen? This application is going to be using your XML file, and this application is also going to be using your XML file, and this is going to just like be able to process and transfer the data. So that is how it is going to be there. Like, whenever we will be having any two applications just like this, application 1 and application 2, and if they want to communicate in SOAP, like if we are making use of SOAP system, so at that particular time when we will be having communication, that is going to be involving several steps. Like, I'll also be telling you what and all steps are going to be there, and we are going to be making use of all of those steps if they are going to be using XML as the format for data exchange. And here we are going to be using XML only for the data exchange. So what and all are going to be the steps? Let me just mention it here. So firstly, we are going to be creating and sending data. Now, what is the actual meaning of this? This means, like, if you must have heard of a word, serialization. So basically what we are going to do, we are going to be like, basically like, if we are going to be having some of the data, before sending it across, we need to create and send it in a format which the other application can understand. If, like, let's take this example only. If we are having two application and if they both are in different languages, and if your application 1 wants to communicate to the application 2, if application 1 wants to send some data to the application 2, so first application 1 is going to create that data, and it is going to be converting it into XML format. Now when you talk about XML, so XML is easy for different programming languages to understand, like Java, Python, and many other languages, correct? However, when you talk about XML, so XML is a text-based format, and computers usually send data in binaries, zeros and ones. Like everybody knows about that, right? So here, if I'm saying I am going to be making use of XML, which is making use of which is going to be making use of your text-based format. So what is going to happen? So before sending the data, application 1 is going to change XML into a binary formatter. So if this is your application, and if this application wants to send some data, how it will do? It is going to be making use of XML. And what is XML? This is going to be using some text-based format. Now, your system is going to be understanding the zeros and ones. So in order to perform that, like in order to convert into zeros and one, we are going to be making use of binary formatter. And this entire process is actually called as serialization, because what we are doing, we are converting our data, like, what we are actually doing. So here we are converting an object or your data into a byte stream, so that, like, whenever you will be having some network, it can easily be transmitted over a network, or if you want, you can also store it on a disk. So when application is serializing that XAML, it is converting it into a format that can be transferred across the network. Like here, if you see, your application is actually converting that data into a binary byte string. And later on, what will happen, like in this one, this application 1 is actually making, like, they are actually making use of XML, and we are converting it into a byte stream. And later on, these byte streams are sent over the network to your application 2. So what will happen? This is your application 1. Here we are writing it in XML. This is your application 2. This is also going to be using XML, right? So XML is going to be used for transferring your data. Now what will happen? Since like we said, we are going to be like, when you are going to be providing that communication, so your hardware is going to be using the network, and that network is going to be using your data, which is written in some binary. Yeah, so when your application 1 wants to send some data to your application 2, we are going to be sending it over network, and that network is actually going to be making use of your binary stream. Here we are going to be making use of some binary language, and that binary language is going to be written in the zeros and ones. Now, in order to perform this operation, we are going to be using, like, we are going to be converting this one into a byte stream and this also into a byte stream. So this is your step one where we are performing serialization. Okay. Now, the next step is like, here your application 1 was actually sending it to your application 2. So these were the steps which your application 1 performed. Now, like, let's say your application 2 has now received it. So after receiving, what is going to be the step which we will perform here? So the next step is receiving and reading the data. And this is what we call it as deserialization. So here what is going to happen, like I said, we are going to be having like, let me just take example. So like, let's say we are talking about application 2 and let us say this is written in C#. So now this one is going to be receiving byte stream from application 1. Correct. Now, like, although we are sending it in the form of zeros and ones, but this application can only understand C#, right? So what will happen before performing anything? This one is actually going to get deserialized. And why that is important? So that this application can understand. So deserialization is opposite of your serialization. What it will be doing, it is going to be converting, like, we are going to be having some byte stream. So it is going to be converting your byte stream into human readable format. Correct? Or some usable format. So in this case, we are going to be converting it. I'll write properly. Convert back to XML because that is the format which we are using here. So once the data once we have the data in the XML format, in that case, application 2 can read and understand the XML data which was sent to it, right? So even though your application 1 is written in Java and let us say your application 2 is written in C#, but they both can understand the XML data format, and that is only possible because they are performing all that operation in the XML, and when they are performing it out at that particular time, they are making use of the important steps which are serialization and deserialization. In order to convert your data into binary streams, you are going to be making use of serialization, and in order to convert your data from from byte streams to your readable data XML format, you are going to be performing a step which is called as deserialization. Now once your application 2 has received a request, now what is the next step which your application 2 needs to do? That is sending a response. So here, after processing the data, application 2 may need to send a response back to your application 1. So it is going to be following a similar process. Your application 2 is going to be like, whatever the response data is there. So firstly, we are going to be converting it into XML so that we can send it over. We are going to be serializing your XML data into the binary format, because you cannot straight away understand, right? So it is going to be involving your serialization, which is going to be converting your byte stream. And then that byte stream is going to get sent over the network to your application 1. Now what application 1 will do, your application 1 is going to receive the response. Now upon receiving the response, that is going to be there in the form of your byte stream. So we are going to deserialize it back to XML. We are going to process it and we are going to be taking the necessary action. So that is how basically we are going to be these are the core steps which we are going to be using here. I hope it must be clear to you. So what we do in order to make two applications communicate, we are going to be making use of SOAP. For SOAP, we are going to be converting your data, whatever we want to send, in XML, and then we are going to be converting it to the byte stream. Upon receiving, that byte stream is going to get converted back to XML, and accordingly we can decide if we want to send a response or not based upon the request. All right, I hope this must be clear to everyone. Now we are going to be discussing what are the problems which we were facing with. So also whenever any problems we are going to be encountering, we are going to be making another uh, technology to come into the picture. So we can say let's discuss problems with. So first we'll see what problems we had here, and later on we will see how we actually came up with another technology which was helping us here. Okay, so initially SOAP was widely used whenever we had to perform any communication between two different applications. At that particular time we were using SOAP. However, over the time it started facing several problems that made it less practical. And why? Because people started saying that SOAP is slow. They started saying SOAP is complex. They started saying SOAP is heavy. So with more users, we started facing all of these issues. And because of this, we thought that, okay, what else can come and help us here? So that was the REST, representational state transfer. That is more simple and more flexible. Okay, but before going to your rest, let's discuss all of these things in little more detail. So when you talk about your SOAP, so we say this is heavy and complex. And why it is heavy and complex? That is because of the XML which we are using here. Like I said, if you want to send some data, so how you are going to be sending, let us say you want to send some data, we have a person John whose age is 30. We have a user here. So even if you will see, this is a small piece of data which we want to send, but still we are going to be wrapping it across a lot of tags. And what will actually happen? That is going to make the entire message size large. So let us say we want to represent it. So how we will do? We will do it something like this: user. Then we will do name. Then John. After that, let us say age. So 30. Age. And user. So you will see, just to provide this much of information, now we are actually going to be sending this huge data, correct? So this XML has a lot of extra tags which makes it more difficult to read and process. Now what is the solution for this? So for this one, JSON came into the picture. So when you talk about JSON, so if you want to send such a data, how you can do? You can probably just send it like name, whatever name you are going to be having, like John. And if you want to send age, you can just do age and provide the value. So when you talk about JSON, here whatever data we want to pass, like both sides, left side, right side, both we are going to be putting in the double quotes. So instead of sending this huge data, now you can see we are just sending it in this simpler form. So this one is easy to read, this one is actually shorter, and this one is very simple to work with. I hope this must be clear, right? Now the next disadvantage is heavy metadata. So, when you talk about XML, like I said, when you are going to be talking about XML, so there we are going to be having a lot of metadatas. What are metadata? So here, if you will see, like, in order to send a user information, we are making use of tags, these tags, these tags, these tags. Even if, like, let us say you want to read it word by word. So if you will see, we actually wanted to send a information of 2 words. Instead, how many words we are actually sending? Like, on a very like layman language, I'm saying. So these are called as your metadata. So instead of like, if you will just see, we are passing very less actual information and a lot of metadata. So in such a case, like, if you will be seeing, like, if we are going to have a lot of data, so in that case, again, possibly, like, here we can say the ratio is something like 1:5, something like that. So eventually, like, let us say we are going to be sending some information of 100 words. Instead, we are going to be sending 500. So if you will see here, the difference is actually going to be actually explaining you how bigger data we are going to be sending. So that much, a lot of metadata we are going to be sending there. So, like, when you talk about that communication part, like, if we are processing two applications here, so what will actually happen when we are going to be making it interact over the network at that particular time? Here we are going to be performing some serialization, and if you will see, if we have a lot of metadata, since here we are going to be having a lot of metadata. So what will happen? This is actually going to become very heavy. And that is actually going to be making this entire serialization process super, super slow. Because now we are having a lot of data. So this entire process is actually going to become super slow. Now let's discuss what could be the another disadvantage. So here, if you will see, no matter what we are doing, every time we are performing some serialization and deserialization. So the overhead of serialization and deserialization, that is going to get added up. So we can say serialization and deserialization overhead, correct? So when you talk about serialization, what we are going to be doing, we are going to be converting your data into XML, and in the deserialization we are going to be converting your XML back in the usable data. So entire process, if you will see this one, this process is slow, and here we are also going to be making use of resources. So we can say this is slow, as well as here we are going to be using some resources. So resources intensive processes, correct? Because your XML is complex and it is going to be containing many tags. So this will take more time, more computing power, so that we can convert it into a usable format, and that can actually lead to slow performance. So when we are going to be having some large amount of data, this one is actually going to become super, super slow. What could be the next disadvantage for this? That is complexity and rigidity. So what actually like I mean by this? So if you talk about SOAP, so that is actually going to be involving some strict standards. And why strict? Because if I want both of the application to interact, there we are going to be following some standards, and in order to sending some request or sending some message, so that actually needs to be there in certain format. So that has to have some format that needs to get like transmitted, and that needs to get processed. So all of these things we are going to be seeing, for one thing we are actually taking care of these three things. Also here we are going to be having a rigid structure, like we cannot send it in XML. Like initially we can only do it in XML, but we cannot even send it directly, so we'll need to format it down in zeros and ones. So if you will see, we are actually making it quite rigid. We are actually adding a lot of complexity also here, and because of this rigid structure it will become difficult for the SOAP to modify or adapt to the changing needs. Also if you talk about SOAP, so it requires a lot of setup and configuration, which actually makes it harder for developers to quickly add some new feature or services. So that is how we can say the SOAP was actually coming up with a lot of problems, right? So as the developers started encountering the new challenges with SOAP, that it is heavy, it is complex, it is slow, it is rigid, they started searching for some better alternatives. Their goal was to find a solution that is going to be providing some greater flexibility, which can be even fast, which can be even simple, and that is not going to add a lot of burden to the developer. So they just started thinking of all of the they started thinking of all of the problems, and they started thinking of a solution which can address all of these problems. So in order to solve all these problems, REST came into the picture. So here your REST stands for your representational state transfer. So here what actually happened, when you talk about REST, here we are going to be we are going to be making use of different uh, it is previously we for the SOAP we only had one thing, that we if we want to have that communication we are going to be making use of XML. But with REST we actually came up with a lot of flexibility. When you talk about REST, it can actually use JSON as a file format, it can also use XML and other file formats. It can make use of anything. Now based upon our requirement we are going to be making use of all those things. So before jumping ahead, we will see we listed down whatever problems we had with SOAP. We need to see how REST solved all those problems. So let's discuss the first one, which is simplicity, correct? So what issue we had with the SOAP, that it is not simple, it is not flexible. So we are going to be discussing simplicity and flexibility. So when you talk about SOAP, so SOAP was built on XML, which is actually going to be making use of some metadata, not some, a lot of metadata. So that is how when you are going to be sending messages through SOAP, that is going to get heavy and it will become difficult to work with. On the other side, when you talk about REST, so that is actually going to be making use of JSON. So this JSON stands for your JavaScript object notation. So JavaScript notation. Okay. And this is lightweight, this is human readable, and it is easy to parse. So when you talk about JSON, so this one actually became a preferred format for data exchange, and that is all because it was providing a faster communication. At the same time, this was lightweight. Plus, if you talk about the format in which, the format which JSON follows, so that is very human readable, correct? At the same time, if you talk about JSON, so this is easy to parse, because if you will see here, we are not going to be making use of a lot of metadata. So that is the reason the moment JSON was introduced, it quickly became popular. It quickly became the preferred format for data exchange, because people knew when we are going to be making use of JSON, it is going to be providing a faster and more efficient alternative to XML. Also, let's little bit talk about JSON as well. So your JSON, this actually stands for your JavaScript object notation. All right. So although like this name JSON, it stands for JavaScript object notation. Although this name actually has this JavaScript in this, but yeah, this is not like, this has nothing to do with the JavaScript. It, like, just in the full form we are going to be having it. Apart from that, it has nothing to do with JavaScript. Also, when you talk about JSON, so this is 100% language agnostic. Now, what do we actually mean by that? So it means when you talk about JSON, it can be used with virtually any programming language, not just JavaScript. So if you will be having any programming language, be it C Sharp, Java, Python, anything. So with all of these programming languages, you can make use of JSON. Here, if you will see this JSON word, this JSON full form, this has JavaScript object, uh, JavaScript there in its full form. So that naming confusion, like how this naming confusion actually came. So we had the person who created the JSON, the Douglas Crockford. So he was the developer of the popular JSON, and he was also the board member of JavaScript. So when he came up with the idea of coming up with JSON, he thought that it can mostly be used with JavaScript application, which is why it carries JavaScript in its name. Although when he created it, he had no vision like how we are going to be consuming it later. So that is the reason this full form is going to be having JavaScript in its name, but it's very important to note that it has nothing to do with the JavaScript. And if you talk about today, so JSON is the widely used format which we use to share data between the different applications. Also, it works with a lot of programming languages like your Java, Python, C Sharp, Ruby, and many others. Also, we'll be discussing one more important point, like how JSON is better than XAML. How JSON is better than XML. Okay. So when you talk about JSON, so it is very simplified. So when you talk about the format, JSON is going to be using, that is going to be of the format key value pair. So that is how we are going to be putting our data. So if you talk about this format, so this is quite compact as compared to XML, because here we are making use of key value pair so that we can represent our data. On the other side, when you talk about XML, so there we are going to be making use of a lot of metadata. We are going to be making use of a lot of tags so that we can organize our data, and that is what is going to make our entire data longer, complex, and hard to read. So this is what is making JSON more compact and straightforward. Yeah, so when you talk about JSON, here we are going to be having a key value pair structure. When you talk about a key value pair structure, so this is something which we have been using in other programming languages as well. So when you talk about JavaScript, so there we are going to be having something called as JavaScript objects, and there we are going to be providing some information in the form of some objects. Like similarly, when you talk about your Python, so there you are going to be having this key value pair structure, and that is what you are going to be calling it as dictionary. Similarly, when you talk about Java, so in Java, you are going to be having a key value pair, which you are going to be calling as map. Similarly, when you talk about C sharp, so there also you are going to be calling it as dictionary. So this key value pair structure is something which we have been using across different languages as well. Now I'll be just taking some example of some data, and I'll just firstly I'll just say like, okay, this is all data I am going to be having, and later we will see how we can format it out. Okay. So let us say I want to add some user information. So what and all user information I can be adding? Like let us say I am adding name. So for name, I am going to be making use of a string, correct? Now let us say I want to add age. So if I want to add age, age is a number, right? So for that we are going to be making use of a number only. Now let us say I want to add hobbies of this person. So when you talk about hobbies, a person can actually have more than one hobby as well. He can actually be like, having a hobby of something like dancing, singing, coding. So these could be the hobbies. Now if you will see, in order to input all the hobbies, I have actually taken the format of arrays, where I'm putting more than one information, right? Now, if I want to add address of this person, how I can do? I can actually go ahead and add, like, let us say I want to add some lane information. So I will write lane, and next to that, let us say I'm entering something like lane number. If I want to add city, I can add like city, and here I can go ahead and provide city name. If I want to add state, I can go ahead and provide state name here. So if you are going to be seeing what we have used for the address part, we are making use of nested JSON, because in order to enter the address, I'm actually making use of the same with the help of some another JSON only, right? Now I'll just quickly see, like, how it is actually differing, like, how we represent our data in XML as well as how we represent our data in JSON. So instead of writing down the entire, I'm just going to be taking a small snippet of that. Okay. So first, let's see for the JSON, like, for the person, I am going to be entering name. So the name could be something like John. For the age, I can go ahead and add 30. Like it could be anything, okay? So you can see just this amount of data. Now, if I want to represent the same in XML, how I will be doing? I'm going to be firstly having an opening tag user. Inside user, I'm going to be having another tag for the name. And here I'm going to be adding John. Then I'll have closing tag for this name. After that, we are going to be having another tag for age, and there I'm going to be writing the value for age, then a closing tag of age. And after that, I'm having a closing tag of user. So you can see for entering this amount of information, I'm going to be making use of these many metadatas here. So if you will take the example of these two here on the screen, you can see JSON is much shorter and clearer. In JSON, we are not making use of any extra metadata. As you can see, JSON contains only the data. There are no extra tags or metadata. So the file is much lighter and easier to process. On the other side, if you will see XML, so that is heavily structured with a lot of opening and closing tags, which is going to be making it more complex and heavy. Plus, if you see JSON, since it is having a concrete amount of data only which is relevant, so it will be very easy for us to serialize and deserialize. Because, like, again, even if it is in JSON, we will have to perform serialize and deserialize on the top so that it can interact. So when you talk about JSON, so it is a simple structure. It means it is going to be more efficient. It, when you talk about working with a large amount of data, when you will be having a lot of requests and responses in that particular time, JSON is actually going to make the entire process more faster. All right. Here, if you will see, yeah. So here, if you are going to be seeing, I mentioned something like JSON is 100% language agnostic. So what do I mean by that? So when you talk about JSON, so this is compatible with all programming languages. So whether you are working with JavaScript, whether you are working with Python, whether you are working with Ruby or Java or any other programming language, you can easily use JSON. So most of our modern languages, they have built-in libraries for parsing JSON so that the entire process will become simple, and it will be easier for us to integrate it across all the different tech stacks available to us. So because of this, JSON is generally preferred for services that needs to communicate with each other. So even if it is going to be written in different programming languages, still, JSON is going to be the perfect format, because this is going to be bringing the flexibility, and because of that flexibility only, this is so widely used. When I took that example, this particular one. So in this example, if you will see, this is how generally we are going to be representing a JSON object. So in this example, you can see that JSON data structure is in the form of key value pair. This is our key, this is our value, this is our key, this is our value. So accordingly, I have structured everything. And all of those things are going to be inside your curly braces. So we are going to be having your keys, and all the keys, like be it your name, age, email, all of those are going to be strings. And when you talk about value, so it could be either in the form of number, strings, or any other data type. So this is pretty much similar to your JavaScript object or your Python dictionary. But if you will see, some little difference is there, right? Since this module is pretty much bigger in size, so I have broken it down into two different parts. In this particular one, we have discussed about your SOAP, and we have also discussed about your REST. In the next module, we are going to be covering what are the advantages of REST, and if we will have to write the REST APIs, how we can do that. So I'll be seeing you in the next module. Bye bye.